ಈ ಗೌರವಾನ್ವಿತ ಸಭೆಗೆ ಪರಿಚಯಿಸಲು ನಾನು ಸಂತೋಷಪಡುತ್ತೇನೆ. ಡಾಕ್ಟರ್ ಎಚ್ ಲಕ್ಷ್ಮೀಕಾಂತ್ ಅವರು ಅತ್ಯಂತ ಸಾಧನೆಗೈದ ಶಿಕ್ಷಣ ತಜ್ಞ, ಸಂಶೋಧಕ ಮತ್ತು ಪರಿಸರ ವೃತ್ತಿಪರರು. ಡಾಕ್ಟರ್ ಲಕ್ಷ್ಮೀಕಾಂತ್ ಅವರು 1993ರಲ್ಲಿ ಮೈಸೂರು ವಿಶ್ವವಿದ್ಯಾಲಯದಿಂದ ಸಿವಿಲ್ ಇಂಜಿನಿಯರಿಂಗ್ ಪದವಿ, 1996ರಲ್ಲಿ ಬೆಂಗಳೂರು ವಿಶ್ವವಿದ್ಯಾಲಯದಿಂದ ಪರಿಸರ ಇಂಜಿನಿಯರಿಂಗ್ನಲ್ಲಿ ಸ್ನಾತಕೋತ್ತರ, ಪರಿಷ್ಕೃತ ಭಾರತೀಯ ವಿಜ್ಞಾನ ಸಂಸ್ಥೆಯಿಂದ ಪರಿಸರ ಭೂತಾಂಶಶಾಸ್ತ್ರದಲ್ಲಿ PhD ಪದವಿ ಪಡೆದಿದ್ದಾರೆ. ಇದಲ್ಲದೆ ಇವರು 2004ರಲ್ಲಿ ಅಣ್ಣಾಮಲೈ ವಿಶ್ವವಿದ್ಯಾಲಯದಿಂದ ಶೈಕ್ಷಣಿಕ ಕಾನೂನಿನಲ್ಲಿ ಪದವಿ ಪಡೆದಿದ್ದಾರೆ. ಇದು ಅವರ ಬಹುಶಿಸ್ತೀಯ ಪರಿಣತಿಯನ್ನು ಪ್ರತಿಬಿಂಬಿಸುತ್ತದೆ. ಅವರು ಭಾರತ ಸರ್ಕಾರದ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ನಿರ್ದೇಶನಾಲಯದಿಂದ ಬೆಂಬಲಿತವಾದ ಘನತ್ಯಾಜ್ಯ ನಿರ್ವಹಣೆಯ ಅಧ್ಯಯನಗಳು ಮತ್ತು ಕರ್ನಾಟಕ ಸರ್ಕಾರದ ಉಪಕ್ರಮಗಳ ಅಡಿಯಲ್ಲಿ ಜರ್ಮನ್ ತಾಂತ್ರಿಕ ಸಹಕಾರದ ಸಹಯೋಗದಿಂದ ಅಪಾಯಕಾರಿ ತ್ಯಾಜ್ಯ ನಿರ್ವಹಣಾ ಯೋಜನೆಗಳು ಸೇರಿದಂತೆ ಹಲವಾರು ಮಹತ್ವದ ಯೋಜನೆಗಳಲ್ಲಿ ಸಕ್ರಿಯವಾಗಿ ತೊಡಗಿಸಿಕೊಂಡಿದ್ದಾರೆ. ಭಾರತ ಸರ್ಕಾರದಿಂದ ಗೇಟ್ ಮತ್ತು ಸೀನಿಯರ್ ರಿಸರ್ಚ್ ಫೆಲೋಶಿಪ್ ನಂತಹ ಪ್ರತಿಷ್ಠಿತ ಫೆಲೋಶಿಪ್ಗಳನ್ನು ಪಡೆದಿರುವ ಡಾಕ್ಟರ್ ಲಕ್ಷ್ಮೀಕಾಂತ್ ಅವರು ಇಂಡಿಯನ್ ಜಿಯೋಟೆಕ್ನಿಕಲ್ ಸೊಸೈಟಿ, ಇಂಡಿಯನ್ ಏರ್ ಪೊಲ್ಯೂಷನ್ ಕಂಟ್ರೋಲ್ ಸೊಸೈಟಿಯ ಅಜೀವ ಸದಸ್ಯ ಮತ್ತು ಅಕಾಡೆಮಿ ಆಫ್ ಸರ್ಟಿಫೈಡ್ ಹಜಾರ್ಡಸ್ ಮೆಟೀರಿಯಲ್ಸ್ ಮ್ಯಾನೇಜರ್ಸ್ PSA ಇದರ ಸದಸ್ಯರಾಗಿರುತ್ತಾರೆ. ಅವರ ಶೈಕ್ಷಣಿಕ ಕೊಡುಗೆಗಳಲ್ಲಿ 10 ಜರ್ನಲ್ ಪ್ರಕಟಣೆಗಳು, ಹಲವಾರು ಸಮ್ಮೇಳನ ಪ್ರಬಂಧಗಳು ಮತ್ತು ತ್ಯಾಜ್ಯ ನಿರ್ವಹಣೆ, ಪರಿಸರ ಪರಿಣಾಮ ಮೌಲ್ಯಮಾಪನ ಮತ್ತು ಭೂಕುಸಿತ ತಂತ್ರಜ್ಞಾನಗಳ ಕುರಿತು ಹಲವಾರು ಪ್ರಭಾವಶಾಲಿ ತಾಂತ್ರಿಕ ವರದಿಗಳು ಸೇರಿವೆ. ಅವರ ಅತ್ಯುತ್ತಮ ವೃತ್ತಿಪರ ಶ್ರೇಷ್ಠತೆಯನ್ನು ಗುರುತಿಸಿ ಅವರು ಸತತ 3 ವರ್ಷಗಳ ಕಾಲ, ಅಂದರೆ 2008, 2009 ಮತ್ತು 2010ರಲ್ಲಿ ಅಕಾಡೆಮಿ ಆಫ್ ಸರ್ಟಿಫೈಡ್ ಹಜಾರ್ಡಸ್ ಮೆಟೀರಿಯಲ್ಸ್ ಮ್ಯಾನೇಜರ್ಸ್ PSA ನಿಂದ ಚಾಂಪಿಯನ್ ಆಫ್ ಎಕ್ಸಲೆನ್ಸ್ ಪ್ರಶಸ್ತಿಯನ್ನು ಪಡೆದಿದ್ದಾರೆ. ಅವರ ಸಂಶೋಧನಾ ಆಸಕ್ತಿಗಳು ತ್ಯಾಜ್ಯ ನಿರ್ವಹಣೆ, ಮಣ್ಣಿನ ಸ್ಥಿರೀಕರಣ, ಭೂಕುಸಿತ ಲೈನರ್ಗಳು ಮತ್ತು ಪರಿಸರ ಜಾಗೃತಿಯನ್ನು ಒಳಗೊಂಡಿವೆ. ಅದಲ್ಲದೆ ಅವರು ಹಲವಾರು ಪದವಿ ಪೂರ್ವ, ಸ್ನಾತಕೋತ್ತರ ಮತ್ತು ಡಾಕ್ಟರೇಟ್ ವಿದ್ವಾಂಸರಿಗೆ ಮಾರ್ಗದರ್ಶನ ನೀಡಿದ್ದಾರೆ. ಶೈಕ್ಷಣಿಕತೆಯನ್ನು ಮೀರಿ ಅವರು ಕರ್ನಾಟಕ, ತಮಿಳುನಾಡು, ಕೇರಳ ಮತ್ತು ಇತರ ರಾಜ್ಯಗಳ ವಿವಿಧ ಶಾಲಾ ಕಾಲೇಜುಗಳಲ್ಲಿ ದೂರದರ್ಶನ, ರೇಡಿಯೋ ಮತ್ತು ಶೈಕ್ಷಣಿಕ ಸಂಪರ್ಕ ಕಾರ್ಯಕ್ರಮಗಳ ಮೂಲಕ ಪರಿಸರ ಜಾಗೃತಿಗೆ ಸಕ್ರಿಯವಾಗಿ ಕೊಡುಗೆ ನೀಡಿದ್ದಾರೆ. ಅವರು ದಾವಣಗೆರೆಯ ಸಿವಿಲ್ ಇಂಜಿನಿಯರಿಂಗ್ ಸಂಘದ ಕಾರ್ಯದರ್ಶಿಯಾಗಿ ಮತ್ತು ಬೆಂಗಳೂರಿನ ಭಾರತೀಯ ವಿಜ್ಞಾನ ಸಂಸ್ಥೆ IICಯಲ್ಲಿ ವಿದ್ಯಾರ್ಥಿ ಪರಿಷತ್ತಿನ ಅಧ್ಯಕ್ಷರಾಗಿ ಸೇವೆ ಸಲ್ಲಿಸಿದ್ದಾರೆ. ಪ್ರಸ್ತುತ ಅವರು ಕರ್ನಾಟಕ ರಾಜ್ಯ ಮಾಲಿನ್ಯ ನಿಯಂತ್ರಣ ಮಂಡಳಿಯ ಉಡುಪಿ ಪ್ರಾದೇಶಿಕ ಕಚೇರಿಯಲ್ಲಿ ಪರಿಸರ ಅಧಿಕಾರಿ, ಎನ್ವೈರನ್ಮೆಂಟಲ್ ಆಫೀಸರ್ ಆಗಿ ಸೇವೆ ಸಲ್ಲಿಸುತ್ತಿದ್ದಾರೆ. ಪರಿಸರ ಸಂರಕ್ಷಣೆ ಮತ್ತು ಸುಸ್ಥಿರತೆಯ ಕಡೆಗೆ ತಮ್ಮ ಸಮರ್ಪಿತ ಸೇವೆಯನ್ನು ಮುಂದುವರಿಸಿದ್ದಾರೆ. ಈ ಸಂಕ್ಷಿಪ್ತ ಪರಿಚಯದೊಂದಿಗೆ ಡಾಕ್ಟರ್ ಎಚ್ ಲಕ್ಷ್ಮೀಕಾಂತ್ ಅವರು ಅವರ ಅಮೂಲ್ಯವಾದ ವಿಚಾರಗಳನ್ನು ಈಗ ನಮ್ಮೊಂದಿಗೆ ಹಂಚಿಕೊಳ್ಳಬೇಕೆಂದು ನಾನು ವಿನಂತಿಸುತ್ತೇನೆ.
Good morning to all of you. Good morning, sir. Yeah. ಕನ್ನಡದಲ್ಲೇ ಹೇಳ್ತೀನಿ. ವೇದಿಕೆ ಮೇಲಿರುವಂತಹ ನನ್ನ ಎಲ್ಲ ಹಿರಿಯರು, ಗೌರವಾನ್ವಿತರು, ಅವರಿಗೆ ಮತ್ತೆ ವೇದಿಕೆ ಮುಂದೆ ಇರುವಂತಹ ನನ್ನ ಹಿರಿಯರು ಮತ್ತೆ ಗೌರವಾನ್ವಿತರು, ಮತ್ತೆ ಸೇರಿರುವಂಥ ಎಲ್ಲ ಫ್ಯಾಕಲ್ಟಿ, ಶಿಕ್ಷಕ ವರ್ಗದವರು ಮತ್ತೆ ವಿದ್ಯಾರ್ಥಿ ಸಮುದಾಯ, ಯಾರಿದ್ದೀರಾ ಅವರೆಲ್ಲರಿಗೂ ನನ್ನ ಬೆಳಗಿನ ಶುಭೋದಯ. ಮತ್ತೆ ಅತಿ ಮುಖ್ಯವಾಗಿ ಇಂಜಿನಿಯರಿಂಗ್ ಇನ್ಸ್ಟಿಟ್ಯೂಷನ್ಗೆ ಧನ್ಯವಾದಗಳೊಂದಿಗೆ ನಾನು ನೀಡ್ತಾ ಇದ್ದೇನೆ ನಿಮ್ಮ ಮುಂದೆ. I'll try to share some of the things which I learned during my tenure of service with the government of Karnataka and to a small extent with the government of India, and also my coordination with the student community. ಅದು ಮೇಡಮ್ ಅವರು 2008, 2009, 2010ರಲ್ಲಿ ಇವರಿಗೆ ಬೇರೆ ದೇಶದವರೇನೋ ಒಂದು ಅವಾರ್ಡ್ ಕೊಟ್ಟಿದ್ರು ಅಥವಾ ರೆಕಗ್ನೇಷನ್ ಕೊಟ್ಟಿದ್ರು ಅಂದ್ರೆ ದಟ್ ಈಸ್ ಪ್ಯೂರ್ಲಿ ಪಾಸಿಬಲ್ ಬಿಕಾಸ್ ಆಫ್ ಮೈ ಸ್ಟೂಡೆಂಟ್ ಅಸೋಸಿಯೇಷನ್. ಡೆಫಿನೆಟ್ಲಿ. ಈಗ ಸುಮಾರು 20 ವರ್ಷಗಳ ಹಿಂದೆ, ಸ್ವಲ್ಪ ಸಮಯ ತಗೊಳ್ತೇನೆ, ಇನ್ನು ನಿಮ್ಗೆ 11 ಗಂಟೆವರೆಗೂ ಸಮಯ ಕೊಟ್ಟಿದೆ ಅಂತ ಸಾಹೇಬರು ಹೇಳಿದ್ದಾರೆ. ಒಂದು 20 ವರ್ಷಗಳ ಹಿಂದೆ, ಅದಕ್ಕಿಂತ ಹೆಚ್ಚು 23 ವರ್ಷಗಳ ಹಿಂದೆ, ಫೆಬ್ರವರಿ 2002-2003 ರೇಂಜಲ್ಲಿ they started working on the solid waste management and its disposal, especially with the city of Bangalore. And that article is published in Waste Management Journal, American Waste Management Journal. That was a single author publication, which was reporting about the dump sites. ಅಂದ್ರೆ ಬೆಂಗಳೂರು ನಗರ ಆ ಕಾಲಕ್ಕೆ ಬೆಂಗಳೂರಲ್ಲಿ ಪಾಪ್ಯುಲೇಷನ್ ಮೇಬಿ ಅರೌಂಡ್ ಲೆಟ್ಸ್ ಸೇ 1 crore, 25 ವರ್ಷಗಳ ಹಿಂದೆ 1 ಕೋಟಿವರೆಗೆ ಇರ್ಬೋದು, 80 ಲಕ್ಷದಿಂದ 1 ಕೋಟಿವರೆಗೆ. ಇಷ್ಟು ಡಂಪ್ ಸೈಟ್ಗಳನ್ನು ಕಸ ವಿಲೇವಾರಿ ಹೇಗೆ ಮಾಡ್ತಾ ಇದ್ದಾರೆ? ನೀವು ಸರ್ ಇದು ಹೈಡ್ರೋಜನ್ ಎನರ್ಜಿ ಬಗ್ಗೆ ಹೇಳಿ ಸರ್, ನೀವು ಯಾಕೆ ಕಸ ವಿಲೇವಾರಿ ಬಗ್ಗೆ ಹೇಳ್ತೀರಿ ಅಂದ್ರೆ, ಬರೀ ಕಸ ವಿಲೇವಾರಿ ಅಲ್ಲ, ನೀವು ಊಟ ಮಾಡೋದ್ರ ಸಹ ಹೇಳ್ತೇನೆ. ಹೈಡ್ರೋಜನ್ ಎನರ್ಜಿಗೂ, ನೀವು ಊಟ ಮಾಡ್ತಿರೋದಕ್ಕೂ, ನಾವು ಹಾಕೊಳ್ಳೋ ಬಟ್ಟೆಗಳಿಗೂ, ನಿಮ್ಮ ಆರೋಗ್ಯಕ್ಕೂ, ಎಲ್ಲೋ 20 ಕಿಲೋಮೀಟರ್ ಮೇಲೆ ಇರುವಂತಹ ಓಝೋನ್ ಲೇಯರ್ಗೂ ಏನು ಸಂಬಂಧ ಇದೆ? ಮತ್ತೆ ನಮ್ಮ ಪ್ರೊಫೆಸರ್ ಅವರು ಹೇಳ್ತಾ ಇದ್ದಾರೆ in his speech, and he was mentioning about sustainable development or sustainable future. He was mentioning ಯಾಕೆ ಸಸ್ಟೈನಬಲ್ ಫ್ಯೂಚರ್ ಇದೆಯಲ್ಲಪ್ಪ, ಎಲ್ಲ ತಿನ್ಬಿಟ್ಟು ಎಲ್ಲ ಏನ್ ಬೇಕೋ ಹಂಗಿಂತ ಹೋಗೋಣ ಬಿಡಿ. ಒಂದು ಪೀಸ್ ತಿನ್ನೋದಿದ್ರೆ 4 ಪೀಸ್ ಆರ್ಡರ್ ಮಾಡೋಣ, ಎಲ್ಲ ತಿನ್ನೋಣ, ತಿಂದು ಖಾಲಿ ಮಾಡಿ ಹೋಗೋಣ ಅಲ್ವಾ? ಇನ್ನೆಷ್ಟು ಬರ, ನೀವು ಆಗಲೇ 40 ಕ್ರಾಸ್ ಮಾಡಿರ್ತಾರೆ, ಇನ್ನೊಬ್ರು ಯಾರು ಇಲ್ಲಿರೋರೆಲ್ಲ ಸ್ವಲ್ಪ 50 ಕ್ರಾಸ್ ಮಾಡಿರ್ತಾರೆ, ಏನೇನ್ ತಿನ್ನೋಕ್ ಸಾಧ್ಯ ಇದೆಲ್ಲ ತಿನ್ಬಿಟ್ಟು ಹೋಗ್ಬಿಡೋಣ ಅಲ್ವಾ? We are behaving like the visitors. ಇದು ನಾವು ಈ ಭೂಮಿಗೆ ಇದೆಯಲ್ಲ, ನಾವಿರೋ ಜಾಗ ಇದೆಯಲ್ಲ, ಇದಕ್ಕೆ ನಾವು ಟೂರಿಸ್ಟರ್ಸ್ ತರ ಬಿಹೇವ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಟೂರಿಸ್ಟರ್ಸ್ ಅಂದ್ರೆ ಹೇಗೆ ಹೇಳಿ, ಅಲ್ಲೆಲ್ಲ ಮಲ್ಪೆ ಬೀಚಿಗೆ ಬಂದ್ರೆ, ಅಲ್ಲೆಲ್ಲ ಓಮ್ ಬೀಚ್, ಅಲ್ಲಿ ಕಾರವಾರದ ಹತ್ರ ಓಮ್ ಬೀಚಿಗೆ ಬಂದ್ರೆ ಅವ್ರು ಹೇಗ್ ಮಾಡ್ತಾರೆ? ಏನೋ ಒಂಥರ ಹುಚ್ಚಿಡೋ ತರ ಆಡ್ತಾರೆ, ಗೊತ್ತಲ್ವಾ? ಎಲ್ಲ ಏನ್ ಬೇಕು ಅದೆಲ್ಲ ಮಾಡಿ ಕೊನೆಗೆ ಅವ್ರು ಇದ್ರು ಇಲ್ಲಿ, ಮನುಷ್ಯರು ಯಾರು ಇಲ್ಲಿ ಬಂದಿದ್ರು ಇಲ್ಲಿ ಅನ್ನೋ ರೀತಿಯಲ್ಲಿ ನಿಮ್ಮ ಕುರುಹುಗಳನ್ನ, ನಿಮ್ಮ ಲೆಫ್ಟ್ ಓವರ್ಗಳನ್ನ, ಇಟ್ ಇಂಡಿಕೇಟ್ಸ್ ದ ವೇ ಯು ಲೀವ್ ದೇರ್ ಫಾರ್ ದಟ್ ಮೂಮೆಂಟ್. ನೀವು ಎಂತ ಜನ, ಏನು ತಿಂದ್ರಿ, ಹೇಗೆ ಇದ್ರಿ ಅನ್ನೋದು ನೀವು ಹೋದ್ಮೇಲೆ ಆ ನೆಲ ಹೇಳ್ತಾ ಇರ್ತದೆ. ನೀವಿದ್ರಲ್ಲ ಆ ಜಾಗ ನಿಮ್ ಬಗ್ಗೆ ಹೇಳ್ತಾ ಇರ್ತದೆ. ಕಾರವಾರ ಬಿಡಿ, ಓಮ್ ಬೀಚ್ ಬಿಡಿ, ಅಥವಾ ಮಲ್ಪೆ ಬೀಚ್ ಬಿಡಿ, ನಾವು ಎಲ್ಲಿದ್ದೇವೆ ಅಲ್ಲಿಗೆ ನಾವು ಈ ಭೂಮಿಯಲ್ಲಿರುವಾಗ ನಮ್ಮ ಅಸ್ತಿತ್ವವನ್ನ ಹೇಗೆ ಕಾಪಾಡಬೇಕು ಅದನ್ನೇ ನಮ್ಮ ಸಾಹೇಬರು ಇಂಗ್ಲಿಷ್ ಸ್ವಲ್ಪ ಸಸ್ಟೈನಬಲ್ ಡೆವಲಪ್ಮೆಂಟ್, ಸಸ್ಟೈನಬಲ್ ಲಿವಿಂಗ್. ವೈ ಇಟ್ ಇಸ್ ರಿಕ್ವೈರ್ಡ್? ಎಲ್ಲರೂ ಬೇಕಾಗಿದ್ದೆಲ್ಲ ಇದೆಯಲ್ವಾ? ಒಂದು ಕಾಲಕ್ಕೆ ಜಸ್ಟ್ ಲೆಟ್ಸ್ ಸೇ ಅಬೌಟ್ 40 years ಬ್ಯಾಕ್, ನಮ್ಮ ಅಜ್ಜನ ಕಾಲಕ್ಕೆ, ಅದು ನಂದೇ ಚಿಕ್ಕ ವಯಸ್ಸಿನ ಕಾಲಕ್ಕೆ, ನಾನು ತುಂಬಾ ಹಳಬಂದೆ ಅಲ್ವಾ? ಆ ಕಾಲಕ್ಕೆ ನಾವು ನೇರವಾಗಿ ಬಾವಿ ನೀರು ಈಗಲೂ ಕುಡಿತಾ ಇದ್ದೇವೆ ನೋಡಿ, ಬಾವಿ ನೀರು ಈಗಲೂ ಕುಡಿತೇವೆ, ಆಮೇಲೆ ನೀರು ಕುಡಿತಾ ಇದ್ದೇವೆ. ನಾನು ಸ್ವಲ್ಪ ನಮ್ಮ ಪೂರ್ವ ಭಾಗದಲ್ಲಿರುವಂತಹ ಕೆಲವು ಜಿಲ್ಲೆಗಳು, ಅದು ತುಮಕೂರು ಆಗಿರ್ಬೋದು, ಬೆಂಗಳೂರು ಆಗಿರ್ಬೋದು, ದಾವಣಗೆರೆ ಆಗಿರ್ಬೋದು, ಇನ್ನ ಆ ಕಡೆ ಏನದು ರಾಯಚೂರು ಆಗಿರ್ಬೋದು, ಬೀದರ್ ಗುಲ್ಬರ್ಗ ಆಗಿರ್ಬೋದು, ಅಲ್ಲಿ ಹೇಗಿತ್ತು, ಏನ್ ಆಗೋಗಿದೆ, ಈಗ ಏನಿದೆ, ಮೊದಲು ಏನಿತ್ತು, 100 ವರ್ಷಗಳ ಹಿಂದೆ ಹೇಗಿತ್ತು, 1000 ವರ್ಷಗಳ ಹಿಂದೆ ಹೇಗಿತ್ತು, ಈಗ ಏನಾಗಿದೆ, ದೆನ್ what is the relation between this sustainable development and the people that they are facing on ನಾವು ಹೇಳಿದಾಗೆ ಕಟ್ಟದ ಮೇಲ್ ನಾವು ಸರಿ ತಾನೆ, ಅಥವಾ ಬಯಸಿರುವುದು ಏನಾಗಿದೆ? ನಾನು ಬಹಳಷ್ಟು ವಿಚಾರಗಳನ್ನ ನಿಮ್ಮ ಹತ್ರ ಹಂಚ್ಕೋಬೇಕು. ಆದ್ರೆ ಮೊದಲನೇದಾಗಿ ಬಿಗಿನಿಂಗ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ನಮ್ಮ ಹೈಡ್ರೋಜನ್ ತೆಗಿತೇನೆ, ಎನರ್ಜಿ ಬಗ್ಗೆ ಹೇಳ್ತಾ ಹೋಗ್ತೇನೆ. ಅಂಡ್ ದ ವೇ ವಿ ಆರ್ ಕನ್ಸ್ಯೂಮಿಂಗ್ ದ ಫ್ಲೂಯಿಡ್ ಎನರ್ಜಿ, ಅದು ಕೆರೋಸಿನ್ ಆಗಿರ್ಬೋದು, ಡೀಸೆಲ್ ಆಗಿರ್ಬೋದು, ಅಥವಾ ಪೆಟ್ರೋಲ್ ಆಗಿರ್ಬೋದು, 20 ವರ್ಷಗಳಿಂದ ಎಷ್ಟು ಬಳಕೆ ಆಗ್ತಾ ಇತ್ತು, ಹೇಗೆ ಬಳಕೆ ಆಗ್ತಾ ಇತ್ತು, 40 ವರ್ಷಗಳಿಂದ ಎಷ್ಟು ಬಳಕೆ ಆಗ್ತಾ ಇತ್ತು, ಹೇಗೆ ಬಳಕೆ ಆಗ್ತಾ ಇತ್ತು, ನಾವೆಲ್ಲ ಈಗ ಇದ್ದೇವೆ ಅಂದ್ರೆ ಯಾವ ಒಂದು ವಾತಾವರಣದಲ್ಲಿ ಇದ್ದೇವೆ, and what is required to be considered. Again, he was also mentioning about the possibilities. I think she was mentioning about the possibilities of getting into R&D, research and development. ಏಕೆ ಮಾಡಬೇಕು ಇದೆಯಲ್ಲ, ಎಲ್ಲರಿಗೂ ಬರ್ತಾ ಇದೆ ರಿಸರ್ಚ್ ಅಂಡ್ ಡೆವಲಪ್ಮೆಂಟ್. ಏನು ಇದು ನಿಮ್ಗೆ ಕೆಲವರಿಗೆ ಕೆಲಸ ಸಿಕ್ಕಿದೆ, ಕೆಲಸ ಇದ್ದಿರೋರಿಗೆ ವಿದ್ಯಾರ್ಥಿ ಅನ್ನೋ ಒಂದು ಸ್ಥಾನಮಾನ ಬಂದಿದೆ, ನಿಮ್ಗೆ ಬಸ್ ಬರ್ತದೆ, ಬಸ್ ಅಲ್ಲಿ ಕರ್ಕೊಂಡ್ ಬರ್ತಾರೆ, ಇಲ್ಲಿ ಬಿಡ್ತಾರೆ, ಕೇಳ್ತೀರಾ ಬೇಡ ಅಂದ್ರೆ ಸುಮ್ಮನೆ ಇರ್ತೀರಾ, ಬ್ಲಾಕ್ ಮಾಡ್ಕೋತೀರಾ ಒಳಗೆ, ನಿಮ್ದು ಆತರ ಮೆಕ್ಯಾನಿಸಮ್ ಇದೆ ಒಳಗೆ, ಮಾಡ್ಕೋತೀರಾ, ಮನೆಗೆ ಹೋಗ್ತೀರಾ, ಮತ್ತೆ ನಿಮ್ ತಾಯಿ ಏನು ಮಾಡಿರ್ತಾರೆ, ಸಂಜೆ ಟೀ ಕುಡಿತೇವೆ, ಕಾಫಿ ಕುಡಿತೇವೆ, ಮುಗಿಸ್ತೇವೆ, ಅಟೆಂಡಿಂಗ್ ಆದವರು ಸ್ಟೂಡೆಂಟ್ ಆಮೇಲೆ ನೀವು ಬೇರೆ ಬೇರೆ ಹಾರ್ಶಿಪ್ ಇದೆ. ಮದುವೆ ಅಂದ್ರೆ ನಿಮ್ಗೆ ಇನ್ನೂ ಎನರ್ಜಿ ರಿಕ್ವೈರ್ಮೆಂಟ್ ಫಾರ್ ಅನ್ ಹ್ಯೂಮನ್ ಬೀಯಿಂಗ್ ಟು ಲೀವ್ ಇಸ್ 1 day ರಿಕ್ವೈರ್ಮೆಂಟ್, 1 capita ಎನರ್ಜಿ ರಿಕ್ವೈರ್ಮೆಂಟ್. ಎಲ್ಲಿಂದ ಶುರು ಆಗ್ತದೆ? ಬೆಳಿಗ್ಗೆ ಎನರ್ಜಿ ಕನ್ಸಂಪ್ಷನ್ ಇದೆಯಲ್ಲ ಅದನ್ನು ಗಮನಿಸ್ತಾ ಹೋಗಿ ಅಂಡ್ ದ ವೇ ವಿ ಆರ್ ಲಿವಿಂಗ್ ಅಂಡ್ ದ ವೇ ವಿ ಹ್ಯಾವ್ ಚೇಂಜ್ ಅವರ್ ಕಲ್ಚರ್, ನಮ್ಮ ಒಂದು ಜೀವನ ಶೈಲಿ, ಜೀವನ ಕ್ರಮ ಅಥವಾ ಸಂಪ್ರದಾಯ ಅಥವಾ ಆಚರಣೆಗಳು ಏನ್ ಹೇಳ್ತೀರಾ ಹೇಳಿ. ನೀವು ದೀಪಾವಳಿ ಬಗ್ಗೆ ಹೇಳಿ, ಗಣೇಶ ಹಬ್ಬದ ಬಗ್ಗೆ ಹೇಳಿ, ದೀಪಾವಳಿ ಪಟಾಕಿ ಹಚ್ಚೋದ್ರ ಬಗ್ಗೆ ಹೇಳಿ, ಬೇರೆಯವರು ಯಾವುದೋ ಒಂದು ಕಾರ್ತಿಕ್ ಮಾಸದೊಳಗೆ ದೀಪ ಹಚ್ಚೋದ್ರ ಬಗ್ಗೆ ಹೇಳಿ, ಎಷ್ಟು ಸಾವಿರ ದೀಪೋತ್ಸವ, ಲಕ್ಷ ದೀಪೋತ್ಸವ, ನಿಮಗೇನಾಯ್ತು ಸರ್? ಧರ್ಮ ಹೇಳ್ತದೆ ದೀಪ ಹಚ್ತೇವೆ ಸುಮ್ಮನೆ ಅಂತ ಹೇಳ್ತೀರಾ? ಹೇಗೆ? what is the bearing, what is the pivotal role to be played by this kind of activities, this kind of culture, this kind of modifications in our mindset, without understanding, without having any kind of deeper thinking about the possibilities of its influence into the environment. Then come back to this sustainable system. ಯಾಕೆ ಬೇಕು ಅಂತ ಸ್ವಲ್ಪ ಕಥೆ ಹೇಳ್ತೇನೆ ನಿಮಗೆ. ಜಂಬೂ ದ್ವೀಪೆ ಭರತ ವರ್ಷೆ ಭರತ ಖಂಡೆ ದಂಡಕಾರಣ್ಯ ಅಂತ ಹೇಳ್ತಾ ಇದ್ವಿ, ಪೂಜೆ ಮಾಡೋದಕ್ಕೆ ಮುಂಚೆ ಹೇಳ್ತೇವೆ. ಏನಿದು? ಇದು ನಮ್ಮ ಭಟ್ರು GPS ರೆಡಿ ಸೆಟ್ ಮಾಡ್ತಾರೆ ದೇವರಿಗೆ ಕಮ್ಯುನಿಕೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ. ನಾವೆಲ್ಲಿ ಕೂತ್ಕೊಳ್ತೇವೆ ಅನ್ನೋದನ್ನ ಹೇಳಲಿಕ್ಕೆ ಬೇಕಾಗಿರೋ ಮೊದಲ ಲೈನ್ ಇದು. ಎಲ್ಲಿ ನಿಂತಿದ್ದೇವೆ? ಪಶ್ಚಿಮ ದಿಕ್ಕಾಗೆ. ಗೊತ್ತಾಯ್ತಲ್ವಾ? ಯಾವ ನಕ್ಷತ್ರ ಇದೆ ಇವತ್ತು, ಎಲ್ಲಿದ್ದೇವೆ, ದಕ್ಷಿಣಾಯನೆ, ಪಶ್ಚಿಮ ದಿಕ್ಕಾಗೆ ಅಂತೆಲ್ಲ ಹೇಳ್ಕೊಂಡು ನಾವು GPS ಸೆಟ್ ಮಾಡ್ತಾರೆ ಎಲ್ಲಿ ಕೂತ್ಕೊಂಡಿದ್ದೇವೆ. ಅದು ಬಿಟ್ಬಿಡಿ ಅವ್ರು GPS. ಅದರೊಳಗೆ ಜಂಬೂ ದ್ವೀಪೆ ಭರತ ವರ್ಷೆ ಭರತ ಖಂಡೆ ದಂಡಕಾರಣ್ಯ ಅಂತ ಹೇಳಿದ್ರು. ಯಾಕೆ ಅಂತ ಹೇಳ್ತೀನಿ ಮತ್ತೆ. ಸಸ್ಟೈನಬಲ್ ಡೆವಲಪ್ಮೆಂಟ್ ದಂಡಕಾರಣ್ಯ ಇತ್ತು ಹಂಗಂದ್ರೇನು? ಅರಣ್ಯ ಇತ್ತು, ಹೋಗ್ಲಿಕ್ಕೆ ಬೇಕಾಗ್ಲಿಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲಿರುವಂತ ಅರಣ್ಯ ಇತ್ತು. ಎಲ್ಲಿ ಇತ್ತು? ಬಯಲುಸೀಮೆಯಲ್ಲಿ. ಈಗೇನ್ ನಾವು ಟೈಟಲ್ ಚೇಂಜ್ ಮಾಡಿದ್ದೇವೆ ಬಯಲುಸೀಮೆ ಅಂತ. ದಟ್ ವಾಸ್ ದ ಪ್ಲೇಸ್ ವೇರ್ ದಿಸ್ highest possible, densest possible, thickest possible forest was there. It was existing. ಈಗ ನೀವು ಬನ್ನಿ ಗೋವಾದಲ್ಲಿ ಏರ್ಪೋರ್ಟ್ ಗೆ ಬನ್ನಿ, ಟೇಕ್ ಆಫ್ ಮಾಡಿ ಮೆಡ್ರಾಸ್ಗೆ ಇಳಿರಿ, ವಿಂಡೋ ಪಕ್ಕ ಸೀಟ್ ಅನ್ನು ತಗೊಳ್ಳಿ, ನೀವು ನೋಡ್ತಾ ಬನ್ನಿ, ಒಂದೇ ಒಂದು ಮರ ಕಾಣಿಸೋದಿಲ್ಲ. ನೆಲ ಗಮನಿಸ್ತಾ ಬನ್ನಿ, ಕಾಣಿಸೋದಿಲ್ಲ, ಬರೀ ಕೆಂಪು ನೆಲ ಕಾಣಿಸ್ತದೆ. ಯಾರಾದ್ರೂ ಮನುಷ್ಯರನ್ನ ಪ್ರಾಣಿಗಳನ್ನ ಓಡಾಡ್ತಿದ್ರೆ ಅವನು ಸಹ ಕಾಣಿಸ್ತಾನೆ. ಎಲ್ಲಿ ಹೋಯ್ತು ದಂಡಕಾರಣ್ಯ? ಕೊಯಂಬತ್ತೂರಲ್ಲಿ there was one program which was organized to educate the people on drip irrigation. ಕೊಯಂಬತ್ತೂರು ತಮಿಳುನಾಡು ಗೊತ್ತಲ್ವಾ? ಅದನ್ನೇ ಅವ್ರಿಗೆ ನಮ್ಮ ಆ ದೇಶದವರು ಡ್ರಿಪ್ ಇರಿಗೇಷನ್ ಅಲ್ಲಿ ತುಂಬಾ ಎಕ್ಸ್ಪರ್ಟ್ಸ್ ಇದಾರಲ್ಲ, ಇಸ್ರೇಲ್ನವರಲ್ವಾ, ಅವರು ದೇ ಆರ್ ಗುಡ್ ಅಟ್ ಡ್ರಿಪ್ ಇರಿಗೇಷನ್. ಎಂತ ಸೈನ್ಸ್ ಇದೆ ಅದರೊಳಗೆ ಡ್ರಿಪ್ ಇರಿಗೇಷನ್? ನಿಮ್ಗೆ ಅರ್ಥ ಆಗದಿರೋದೇನು ಅಂತಿದ್ಯಾ? ಒಂದು ಬಿಂದಿಗೆ ತಗೊಂಡು ಅಥವಾ ಒಂದು ಮಡಿಕೆ ತಗೊಂಡು ಅದರೊಳಗೆ ನೀರು ತುಂಬಿ ಚಿಕ್ಕ ಹೋಲ್ ಮಾಡಿ, ನಮ್ಮ ಮೊದಲು ಬನಿಯನ್ ಬಟ್ಟೆನ ಹಾಕಿ ಅದರೊಳಗೆ ಒಳಗೆ ಚುಚ್ಚಿಬಿಟ್ಟು ಒಂದೊಂದೇ ನೀರನ್ನ ಹನಿ ನೀರಾವರಿ ಮಾಡೋದು, ಜಿನುಗು ನೀರಾವರಿ ಮಾಡೋದು ನಮ್ ಜನ ಮಾಡಿದ್ದಾರೆ. ನಾನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಇಷ್ಟೇ. ಕೊಯಂಬತ್ತೂರಲ್ಲಿ ನಿಂತ್ಕೊಂಡು, ಇಲ್ಲಿ ನಾವು ನಿಂತ್ಕೊಂಡಿದ್ದೇವೆ, ಇಸ್ರೇಲ್ ತಂತ್ರಜ್ಞಾನಿಗಳನ್ನು ಕರೆದಿದ್ದೇವೆ, ನಾವು ಅವ್ರನ್ನ ಗೌರವದಿಂದ ನೋಡ್ತೇವೆ. ಅದ್ರ ವಿಷಯ ಏನಂತ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಇದೇ ಜಾಗದಲ್ಲಿ ನನ್ನ ಅಜ್ಜನ ಕಾಲದಲ್ಲಿ ನಾವು ಫ್ಲಡ್ ಇರಿಗೇಷನ್ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ದೇವೆ. ನಾವು ವಿ ಹ್ಯಾವ್ ರೀಚ್ಡ್ ಎ ಸಿಚುಯೇಷನ್ ವೇರ್ ವಿ ಡೋಂಟ್ ಹ್ಯಾವ್ ದ ವಾಟರ್ ಫಾರ್ ಫ್ಲಡ್ ಇರಿಗೇಷನ್, ದಟ್ ಈಸ್ ಫಾರ್ ಶ್ಯೂರ್. ಬಟ್ ಅಷ್ಟೇ ಅಲ್ಲಪ್ಪ, ಸ್ವಲ್ಪ ಒಂದು ಚೆಂಬಲ್ಲಿ ಬಿಂದಿಗೆಯಲ್ಲಿ ಹಾಕ್ಲಿಕ್ಕೆ ಬೇಕಾಗಿರೋ ನೀರು ಸಹ ಇಲ್ದಿರುವಂತ ಸ್ಥಿತಿಯಲ್ಲಿ ನಾವು ರೀಚ್ ಆಗಿದ್ದೇವೆ. ಯಾಕೆ? ಸರಿ ತಾನೆ? And that too, we are trying to learn the drip irrigation system by calling international experts. ಏನ್ ಡ್ರಿಪ್ ಇರಿಗೇಷನ್? ಸುಮ್ಮನೆ ಹನಿ ಹನಿ ಆಗ್ತಾ ಇರ್ಬೇಕು ಅಷ್ಟೇನೆ, ಮಾಡ್ಲಿಕ್ಕೆ ಬರೋದಿಲ್ಲ. ಈ ಕೊಯಂಬತ್ತೂರಲ್ಲಿ ನಿಂತ್ಕೊಂಡು ಎಡಗಡೆಗೆ ನೀವು ಸುಮಾರು ಒಂದು 300 ಕಿಲೋಮೀಟರ್ ದಾಟಿದ್ರೆ ಕರಾವಳಿ ಇದೆ. ಇದೇ ಕರಾವಳಿ ಅಲ್ಲಿದೆ. 4000ರಿಂದ 5000 ಮಿಲಿಮೀಟರ್ ನೀರು ಮಳೆ ನೀರಾಗಿ ಬೀಳ್ತದೆ. ಕೊಯಂಬತ್ತೂರಿಗೆ ಬಂದ್ರೆ 300 ಮಿಲಿಮೀಟರ್ ಬೀಳೋದಿಲ್ಲ. ಏನಾಯ್ತು? ಯಾಕಾಯ್ತು? ಇದೊಂದು ಶಾಪನ ಅಲ್ವಾ? ಕೆಲವು ಜನ ನಮ್ಮ ರಾಜ್ಯದಲ್ಲೇ ಕೆಲವು ಜಿಲ್ಲೆ ಜನಗಳು ಇಲ್ಲಿಗೆ ಕರಾವಳಿಗೆ ಕೆಲಸಕ್ಕೆ ಬರ್ತಾರೆ. ನಾನು ಅವ್ರ ಹೆಸರು ಇಂಥ ಜಿಲ್ಲೆ ಅಂತ ಹೇಳ್ಬೋದು, ಹೇಳಿದ್ರೆ ಕೆಲವರು ಹರ್ಟ್ ಆಗ್ತದೆ. ನಮ್ಮ ಜಿಲ್ಲೆ ಬಗ್ಗೆ ಕೀಳರು ಮಾತಾಡ್ತಾರೆ. ಉತ್ತರದಲ್ಲಿರುವಂತ ಕೆಲವು, ಕರ್ನಾಟಕದ ಉತ್ತರದಲ್ಲಿರುವಂತ ಕೆಲವು ಜಿಲ್ಲೆಗಳು, ಸರಿ ತಾನೆ? ಇಲ್ಲಿಗೆ ಕರಾವಳಿಗೆ ಕೆಲಸಕ್ಕೆ ಬರ್ತಾರೆ. ಯಾಕೆ? ಅಥವಾ ಅವ್ರು ಬಡವರಿದ್ದಾರೆ, ಇಲ್ಲಿ ಸಾವುಕಾರರಿದ್ದಾರೆ. ಯಾಕೆ? ಶ್ರೀಮಂತಿಗೆ ಇಲ್ಲಿದೆ, ಅಲ್ಲಿಲ್ಲ. ಯಾಕೆ? ಅಲ್ಲಿ ಆರೋಗ್ಯ ಕಡಿಮೆ ಇದೆ, ಇಲ್ಲಿ ಆರೋಗ್ಯ ಜಾಸ್ತಿ ಇದೆ. ಯಾಕೆ? ಇಲ್ಲಿ ನೋಡ್ಲಿಕ್ಕೆ ಚೆನ್ನಾಗಿದ್ದಾರೆ, ಅಲ್ಲಿ ನೋಡ್ಲಿಕ್ಕೆ ಚೆನ್ನಾಗಿಲ್ಲ. ಗಲ್ಲೆಲ್ಲ ಒಳಗೆ ತಿಳಿಲ್ಲ. ನಮ್ಮ ಮೇಡಮ್ ಅವ್ರಿಗೆ ನೋಡಿದ್ರೆ ತುಂಬಾ ಚೆನ್ನಾಗಿದ್ದಾರೆ, ಗೊತ್ತಲ್ವಾ? ಆ ಮೇಡಮ್ಗಳು ನೋಡಿ ನೀವು ಕಾಲೇಜಿಗೆ ಬನ್ನಿ, ಗಲ್ಲೆ ಎಲ್ಲ ಒಳಗೋಗಿರ್ತದೆ, ಹೊಟ್ಟೆ ಎಲ್ಲ ಒಳಗೋಗಿರ್ತದೆ. ನೀವು ಮರ ಹತ್ಲಿಕ್ಕಾಗಲ್ಲ, ಅವ್ಳಿಗೆ ಹೇಳಿ ಮರ ಹತ್ತಿ ಅಲ್ಲಿ ಹಣಕಿತ್ಕೊಂಡು ಕೊಟ್ಟು ಬರ್ತಾಳೆ. ಅಷ್ಟು ಗೊತ್ತಲ್ಲ? ಹಾಗಿರ್ತಾಳೆ. ವಾಟ್ ಈಸ್ ಹ್ಯಾಪನಿಂಗ್ ವಿತ್ ದಿಸ್ ಅಲ್ವಾ? ಹಾಗಾದ್ರೆ ಅಲ್ಲಿ ಹೋಗಿ ನೀವು ಆ ಜಿಲ್ಲೆಯಲ್ಲಿ ಹೇಳ್ಬಿಡ್ತೀನಿ, ಬಿಜಾಪುರ ಗುಲ್ಬರ್ಗ ಜಿಲ್ಲೆಯಲ್ಲಿ ಕಿಡ್ನಿ ಸ್ಟೋನ್ ಮ್ಯೂಸಿಯಂಗಳಿದೆ, ಬಂಗಾರದಲ್ಲ ಮನೆ, ಬಂಗಾರ ವಜ್ರ ಇದ್ದಲ್ಲ, ಕಿಡ್ನಿ ಸ್ಟೋನ್ ಮ್ಯೂಸಿಯಂಗಳಿದೆ. ಇಲ್ಲೇನಿದೆ? ಇಲ್ಲಿಲ್ಲ ಸರ್ ಅಂತೀನಿ. ಸ್ವಲ್ಪ ಮೇಲೆ ಹೋಗಿ ಒಂದು 8 hours ಜರ್ನಿ ಮಾಡಿ ದಾವಣಗೆರೆ ಹತ್ರ ಹೋಗಿ ಟುವರ್ಡ್ಸ್ ಸೌತ್ ಆಫ್ ದಾವಣಗೆರೆ ಯು ವಿಲ್ ಫೈಂಡ್ ಒನ್ ಹಾಸ್ಪಿಟಲ್. ನಾನು ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇರೋ ನಮ್ಮ ಡ್ರೈವರ್ ಕೇಳಿದೆ, ಸ್ವಲ್ಪ ಎಲ್ಲ ಹೇಳ್ತೇನೆ ಪ್ಲೀಸ್, ಯಾಕೆಂದ್ರೆ ಇಟ್ಸ್ ಅ ವೈಡ್ ಸ್ಪೆಕ್ಟ್ರಮ್ ಆಫ್ ಇನ್ಫ್ಲುಯೆನ್ಸ್ ದಟ್ ವಿ ಕ್ಯಾನ್ ಥಿಂಕ್ ಆಫ್ in the name of environment and its influence only because of your lifestyle. ನಿಮ್ಮ ಜೀವನ ಕ್ರಮದಿಂದನೇ ನೀವೆಲ್ಲ ಹಾಳಾಗಿ ಹೋಗ್ತಿರೋದು. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ದಾವಣಗೆರೆ ನಿಮ್ಗೆ ಹೆಸರು ಹೇಳಿದೆ, ದಾವಣಗೆರೆ ದಕ್ಷಿಣಕ್ಕೆ ಹೋಗ್ತಾ ಇದ್ದೇವೆ. ನಾನು ಡ್ರೈವರ್ ಕೇಳಿದೆ, ಇಷ್ಟು ದೊಡ್ಡ ಬೋರ್ಡ್ ಇದೆ, ಏನ್ ಚಿಕ್ಕ ಬೋರ್ಡ್ ಅಲ್ಲ, ಇಷ್ಟು ದೊಡ್ಡ ಬೋರ್ಡ್ ಅಂದ್ರೆ ಮೇ ಬಿ ಅರೌಂಡ್ 4 to 5 feet ಡೈಮೆನ್ಷನ್ ಇರುವಂತ ಲೆಟರ್ಸ್, ವರ್ಡಿಂಗ್ಸ್ ಏನಂತ ಇದೆ, ಇಂಥ ಹೆಸರನ್ನ ದೊಡ್ಡ ಕ್ಯಾನ್ಸರ್ ಹಾಸ್ಪಿಟಲ್ ಅಂತ ಹೆಸರಿದೆ. ಮಂಗಳೂರಲ್ಲಿ ಯಾಕೆ ಕ್ಯಾನ್ಸರ್ ಹಾಸ್ಪಿಟಲ್ ಇಲ್ಲ? ಸರಿ ತಾನೆ? ಅಲ್ಲಿ ಯಾಕೆ ಕ್ಯಾನ್ಸರ್ ಹಾಸ್ಪಿಟಲ್ ಬಂತು? ಏನಾಯ್ತು? ಏನು ಶಾಪ ಸರ್, ಅದು ಎಲ್ಲಮ್ಮ ಏನೋ ಶಾಪ ಮಾಡಿದ್ರು. ಎಂತದ್ದು ಇಲ್ಲ. ಅಗೇನ್ ದಟ್ ಗೋಸ್ ಟು ದ ಫುಡ್ ಹ್ಯಾಬಿಟ್ಸ್. ಸಂಜೆ ಆದ್ರೆ ನಮ್ಮ ಡ್ರೈವರ್ ಕೇಳ್ತೀನಿ, ಏನೋ ಒಂದು ಸ್ವಲ್ಪ ತಿನ್ಲಿಕ್ಕೆ ಕರ್ಕೊಂಡು ಹೋದ, ನನಗೆ ದೋಸೆ ನನ್ನ ಕೋರ್ಸ್ ಆದ್ರೆ ಬನ್ನಿ ಸರ್, ಏನೋ ಆ ಬಸಣ್ಣದ್ದು ಬಜ್ಜಿಗೊಂಡ ಹೋಟ್ಲಿದ್ದು ಬಹಳ ಚೆನ್ನಾಗಿದೆ, ಬನ್ನಿ, ಅವ್ನು ಬಹಳ ಫೇಮಸ್ ಅಂತ. ಇದು ನಿಜ. ಸಂಜೆ 4-5 ಗಂಟೆ ನಾನು ಬಜ್ಜಿಗೊಂಡ ಹೋಟ್ಲಿಗೆ ಕರ್ಕೊಂಡು ಹೋಗ್ತಾನೆ. ಏನಾಯ್ತು ಸರ್, ಎನರ್ಜಿ ಬಗ್ಗೆ ಮಾತಾಡಿದ್ರೆ ಬಜ್ಜಿಗೊಂಡ ಬಗ್ಗೆ ಮಾತಾಡ್ತೀನಿ. ಕ್ಯಾನ್ಸರ್ ಹಾಸ್ಪಿಟಲ್ಗೂ ಬಜ್ಜಿ ಬೋಂಡ ಅಲ್ಲಿ ಮಾಡ್ತಾ ಇರೋದು ಸಂಬಂಧ ಇದೆ. ಒಂದು ಅಡಿಗೆ ಎಣ್ಣೆಯನ್ನ 1 ಅಥವಾ 2 ಸರಿಗಿಂತಲೂ ಹೆಚ್ಚು ಸಾರಿ ಬಿಸಿ ಮಾಡಿ ಅಥವಾ ಬೇಯಿಸಿ ತಿನ್ಲಿಕ್ಕೆ ಬೇಕಾಗಿರುವಂತ ಸಂದರ್ಭ ಬರಬಾರದು. ಆದ್ರೆ ಬಸಳು ನಮಗೆ ಬರ್ತಾ ಇದೆಯಾ? ಅವನು ಹೋದ ವರ್ಷ ಹಾಕಿರೋ ಎಣ್ಣೆ ಈಗಲೂ ಬೇಯ್ತಾ ಇದೆ. ಮಲ್ಟಿಪಲ್ ಟೈಮ್ಸ್ ಅದು ಬಾಯ್ಲ್ ಆಗ್ತಾ ಇದೆ, ಓವರ್ ಬಾಯ್ಲ್ ಆಗ್ತಾ ಇದೆ. ನೀವು ಅಷ್ಟೇನೆ ಹೈ ಫ್ರೈಡ್ ಫುಡ್ ಅನ್ನ ಅಥವಾ ಕಾರ್ಬನ್ ಕಂಟೆಂಟ್ ಮೇಲೆ ಕಪ್ಪಾಗಿ ಬಂದಿರ್ತದಲ್ಲ ಅಂತದನ್ನ ತಿಂದ್ರೆ ಏನಾಗ್ತದೆ? ಸ್ವಲ್ಪ ಗರಿ ಗರಿ ಆಗಿರುತ್ತೆ ಸರ್, ಚೆನ್ನಾಗಿರುತ್ತೆ ಅಂತೀರಾ, ಕ್ಯಾನ್ಸರ್ ಖಂಡಿತ. ಅಂತ ಎಣ್ಣೆಯಲ್ಲಿ ಅವನಿಗೆ ಬಜ್ಜಿ, ಮೆಣಸಿನಕಾಯಿ ಬಜ್ಜಿ ಹಿಂಗೆ ಹಾಕಿ ನಿಮ್ಗೆ ಕೊಡ್ತಾ ಇದ್ದಾನಂದ್ರೆ ನಿಮ್ಗೆ ಬಜ್ಜಿ ತಿನ್ನಿಸ್ತಾ ಇಲ್ಲ, ಕ್ಯಾನ್ಸರ್ ಹಾಸ್ಪಿಟಲ್ ಪೇಷಂಟ್ ರೆಡಿ ಮಾಡ್ತಾ ಇದ್ದಾನೆ. ಈಗ ಹೋಗಿ ಓದ್ಕೊಳ್ಳಿ ಬೇಕಾದ್ರೆ 100% ನಿಜ. ಗೊತ್ತಾಯ್ತಲ್ವಾ? The food habits that we are having, the way that we are trying to live, leading to all these kinds of problems. ಆಯ್ತು, ದಾವಣಗೆರೆ ಕ್ಯಾನ್ಸರ್ ಜಾಸ್ತಿ ಇದೆ. ಬಿಜಾಪುರದಲ್ಲಿ ಬರೋದಕ್ಕೆ ಕಿಡ್ನಿ ಸ್ಟೋನ್ ಹಾಕಿದೆ, ಅದನ್ನ ತಗೊಂಡು ಮ್ಯೂಸಿಯಂ ಹಾಕಿ ಮಾಡಿದ್ದಾರೆ. ನೀರಿಲ್ಲ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ನಿಮ್ಮ ಶ್ರೀಮಂತಿಕೆಗೆ, ನಿಮ್ಮ ಯೋಗ್ಯತೆಗೆ, ಯೋಚನೆ ಮಾಡೋ ಯೋಗ್ಯತೆಗೆ ಎಲ್ಲದಕ್ಕೂ ಸಂಬಂಧ ಒಂದೇ, ನೀರು. ನೀವು ಶ್ರೀಮಂತರಂದ್ರೆ ಕಾರಣ ನೀರು, ನೀವು ಬಡವರಂದ್ರೆ ಕಾರಣ ನೀವು ಆರೋಗ್ಯವಂತರಂದ್ರೆ ಕಾರಣ ನೀರು, ನೀವು ಅನಾರೋಗ್ಯವಂತರಂದ್ರೆ ಕಾರಣ ನೀವು ಕೆಟ್ಟದಾಗಿ ಯೋಚನೆ ಮಾಡ್ತೀರಂದ್ರೆ ಕಾರಣ ನೀರು, ಹೆಚ್ಚು ಸಮಯ ಬದುಕ್ತಿರೋದ್ರೆ ಕಾರಣ ನೀರು. ಏನ್ ಹೇಳ್ತೀರಿ ಹೇಳಿ? The wonderful element, impossible to imagine without water. All these ecological system, ಈ ಅಮೆರಿಕನ್ ನಾಸಾ ಸೈಂಟಿಸ್ಟ್ ಏನಾದ್ರು ಹುಡುಕ್ತಾ ಇದಾರೆ, ಯಾವುದೋ ಮಂಗಳ ಗ್ರಹದಲ್ಲಿ ಏನೋ ಹುಡುಕ್ತಾ ಇದಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ, it's only the traces of water. ಇಲ್ಲಿರೋದನ್ನ ಬಿಟ್ಟು ಅಲ್ಲಿ ಇಲ್ಲದೆ ಇರೋದನ್ನ ಹುಡುಕ್ತಾ ಇದ್ದಾರೆ, ಕೋಟಿಗಟ್ಟಲೆ ಖರ್ಚು ಮಾಡಿ. ಈಗ ಎನರ್ಜಿ ಬಗ್ಗೆ ಹೇಳ್ತೇನೆ ಸ್ವಲ್ಪ. ಒಂದು 25 ವರ್ಷಗಳಿಂದ ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ಫ್ಯಾಕ್ಟ್, ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ಫ್ಯಾಕ್ಟ್. ನಾನು ಅದಕ್ಕೆ ಸೀನಿಯರ್ಸ್ ನ ಬಹಳ ನಮ್ಮ ಮನೇಲಿ ಅಜ್ಜಿ ಇರ್ತಾರಲ್ಲ, ಅವ್ರನ್ನೆಲ್ಲ ಹೇಳ್ತಾ ಇರ್ತೇನೆ. ಅವರು 50 ವರ್ಷ ಅಥವಾ 60 ವರ್ಷ ಅಥವಾ 70 ವರ್ಷ 80 ವರ್ಷ ಅಂದ್ರೆ ವಯಸ್ಸಾಗಿರೋ ಅಂತ ಅನ್ಬೇಡಿ. 60 years 70 years ಹಾರ್ಡ್ ಡಿಸ್ಕ್ ಅದು, ಇಟ್ ವಿಲ್ ಕ್ಯಾರಿ ಆಲ್ ದ ಇನ್ಫಾರ್ಮೇಶನ್ ಫಾರ್ ಲಾಸ್ಟ್ 60 years 70 years. ಹಾಗಾಗಿ ನೀನು ಅನ್ಕೊಂಡಿರೋಂಥ ವಿಚಾರಗಳು ತಲೆ ಇರ್ತದೆ, ಅದನ್ನು ನೀವು ಟ್ಯಾಪ್ ಮಾಡಬೇಕಾಗಿದೆ. ಯಾಕೆ ಅಂತ ಕೇಳಿ, ಯಾಕೆ ಟ್ಯಾಪ್ ಮಾಡಬೇಕು? ನಮ್ಮ ಸರ್ ಸಸ್ಟೈನಬಲ್. ಇಟ್ ಈಸ್ all this database, all this database is required for sustainability. 25 ವರ್ಷಗಳಲ್ಲಿ ಬೆಂಗಳೂರಿಗೆ ಕೇರಳ 25 ವರ್ಷಗಳಲ್ಲಿ ಹೇಗಿತ್ತು? ಲೆಟ್ಸ್ ಸೇ ಇಯರ್ 2000 ಅಥವಾ 1994 ಅಲ್ಲಿ ಪಾಪ್ಯುಲೇಷನ್ ಎಷ್ಟಿತ್ತು? 30 ರಿಂದ 40 ಲಕ್ಷ, 40 ರಿಂದ 70 ಲಕ್ಷ ಆಯ್ತು, 1 ಕೋಟಿ ಆಯ್ತು. ಈಗ 1.5 ಕೋಟಿ ಕಾಡಿದೆ. ನಮ್ಮ ಮಂಗಳೂರು ಎಷ್ಟಿದೆ? 5 ಲಕ್ಷ, 5 ರಿಂದ 6 ಲಕ್ಷ. ಇಲ್ಲಿ ವೆಹಿಕಲ್ ಪಾಪ್ಯುಲೇಷನ್ ಎಷ್ಟಿದೆ? ಒಂದು ಮನೆಗೆ 2 ಕಾರ್ಗಳು ಅಥವಾ 2 ಬೈಕ್, 1 ಕಾರ್ ಹೀಗೆ ನೆಟ್ಕೊಳ್ಳೋದು. ಅಂದ್ರೆ 5 ಲಕ್ಷ ಇದ್ರೆ ಅಟ್ಲೀಸ್ಟ್ 3 ರಿಂದ 4 ಲಕ್ಷ ವೆಹಿಕಲ್ ಇದೆ, ಅಥವಾ ಅದಕ್ಕಿಂತ ಹೆಚ್ಚಿರ್ಬೋದು. ಬೆಂಗಳೂರು ಹೋಗೋಣ, 60 ಲಕ್ಷ ವೆಹಿಕಲ್ ಇತ್ತು 20 ವರ್ಷಗಳ ಹಿಂದೆ. 30 ರಿಂದ 45 ಲಕ್ಷ ಕಾಡ ತೋರಿಸ್ತಾ ಇದ್ರು. ಟೋಟಲ್ ಪಾಪ್ಯುಲೇಷನ್ ಎಲ್ಲ ಲೆಕ್ಕ ತಗೊಂಡ್ರೆ somewhere around 50 to 60 lakh, ಅಂದ್ರೆ 5 to 6 million vehicles were traveling on road. Okay, ಈಗ ಎಷ್ಟಿರ್ಬೋದು ಅಂತ ಹೇಳಿ. ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದ ಟ್ರಾಫಿಕ್ ಎಷ್ಟಿತ್ತು ಮೊದಲು, ಆ ಜನಗಳ ಎಕನಾಮಿಕ್ಸ್ ಎಷ್ಟಿತ್ತು, ಆ ಮನೆಗಳಲ್ಲಿ ಎಷ್ಟು ಜನರ ಹತ್ರ ಕಾರ್ ಇತ್ತು, ಈಗೇನು ಕಾರ್ ಇದೆ, ಫ್ಯೂಯಲ್ ಕನ್ಸಂಪ್ಷನ್ ಹೇಗೆ ನಡೀತಾ ಇದೆ ನೀವು ಕಂಪೇರ್ ಮಾಡಿ. ಅಂಡ್ ವೈ ವಿ ಆರ್ ಗೆಟಿಂಗ್ ಇನ್ ಟು ದಿಸ್ ಹೈಡ್ರೋಜನ್ ಎನರ್ಜಿ, ಅಥವಾ ಇನ್ನು ಯಾರೋ ನೀರು ಮಾಡ್ಕೊಳ್ತೀವಿ ಅಂತಾರೆ, ಇನ್ನು ಯಾರೋ ಸೋಲಾರ್ ಪ್ಯಾನಲ್ ಮಾಡ್ತಾರೆ, ಅವ್ರು ಯಾರೋ ದೊಡ್ಡ ಕಾರ್ಯಗಳು ಮಾಡಿ ಸೋಲಾರ್ ಪ್ಯಾನಲ್ ಇದ್ರೆ ಮುಂದ್ಗಡೆ ಬಾನೆಟ್ಗೆ ಸೋಲಾರ್ ಪ್ಯಾನಲ್ ಸೆಟ್ ಮಾಡ್ಬಿಟ್ಟು ನೀವು ಹಾಗೇನೆ ಸೋಲಾರ್ ಇಂಜಿನ್ ಟ್ಯಾಪ್ ಮಾಡೋಣ ಅಂತ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ರೆ ಯಾಕೆ ಮಾಡ, ಇದೆಯಲ್ಲ ಡೀಸೆಲ್ ಇದೆ, ಪೆಟ್ರೋಲ್ ಇದೆ, ಕುಡಿತಾ ಇರಿ ಸಾಕು ನೀವು ಅಲ್ವಾ. ನೋಡಿ, ಒಂದು ವೆಹಿಕಲ್ಗೆ 200 ml ಅಷ್ಟೇನೆ. ನಾನು 20 ವರ್ಷದ ಹಿಂದಿನ ಮಾತುಕತೆ ನಿಮ್ಗೆ ಹೇಳ್ತಾ ಇದ್ದೇನೆ. ಆಗಿನ ಟ್ರಾಫಿಕ್ ಡೆನ್ಸಿಟಿ, ಆಗಿನ ವೆಹಿಕಲ್ ಯುಟಿಲಿಟಿ ಬಗ್ಗೆ ನಿಮ್ಗೆ ಹೇಳ್ತಾ ಇದ್ದೇನೆ. 200 ml per vehicle per day ಮಿಸ್ಯೂಸ್ ಆಗ್ತಿದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. ಇನ್ ದ ನೇಮ್ ಆಫ್ ಟ್ರಾಫಿಕ್ ಅಂಡ್ ಟ್ರಾಫಿಕ್ ಡೆನ್ಸಿಟಿ ಅಂಡ್ ಸಿಗ್ನಲ್ಸ್ ಪ್ರೈಸ್ ಮಾಡ್ತಾ ಇರೋದ್ರಿಂದ ನಾವು ಮಲ್ಟಿಪ್ಲೈ ವಿತ್ 50 million vehicles, ಅದು ಇನ್ ಎನಿ ಫಾರ್ಮ್, ಡೀಸೆಲ್ ಆಗಲಿ ಪೆಟ್ರೋಲ್ ಆಗಲಿ, 50 million 50 ಲಕ್ಷ 5 million 50 ಲಕ್ಷ ವೆಹಿಕಲ್ಗಳನ್ನ 200 ml ವೇಸ್ಟ್ ಆಗ್ತಿದೆ ಸಿಗ್ನಲ್ ನಿಂತಾಗ, ಟ್ರಾಫಿಕ್ ಡೆನ್ಸಿಟಿ ಬರೋದ್ರಿಂದ. ರಾಜಭವನ ಹೋಗ್ಬೇಕಂದ್ರೆ ನಡ್ಕೊಂಡು ಹೋದ್ರೆ ಅದಕ್ಕೆ ಒಂದು 20 ನಿಮಿಷದ ಹೋಗ್ತೇವೆ, ಬೈಕಲ್ಲಿ ಹೋದ್ರೆ ಇನ್ನು ಸ್ವಲ್ಪ 20 30 ನಿಮಿಷಕ್ಕೆ ಹೋಗ್ತೇವೆ, ಕಾರಲ್ಲಿ ಹೋದ್ರೆ 1 ಗಂಟೆ ನಂತರ ಹೋಗ್ತೇವೆ. ಅದೇ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನು ಕಾರಲ್ಲಿ ಹೆಚ್ಚು ಸಮಯ ಖರ್ಚು ಮಾಡಿ ರೀಚ್ ಆಗ್ತೇವೆ. ದೆನ್ ಫ್ಯೂಯಲ್ ಕನ್ಸಂಪ್ಷನ್ ಹೇಗಿದೆ, ಅಲ್ಲೆಲ್ಲ ಸೆಕೆಂಡ್ ಗೇರ್ ಅಲ್ಲಿ ಇರ್ತೇವೆ, ಫಸ್ಟ್ ಗೇರ್ ಸೆಕೆಂಡ್ ಗೇರ್ ಅಲ್ಲಿ ಇರ್ತೇವೆ, ನಿಲ್ಲಿಸಿರೋ ಹತ್ರ ಕಂಪ್ಲೀಟ್ ಐಡಲ್ ಹೋಗ್ತಾ ಇದ್ದಾರೆ. ಎಮಿಷನ್ಸ್ ಎಷ್ಟು ನಡೀತಾ ಇದೆ, ಫ್ಯೂಯಲ್ ಕನ್ಸಂಪ್ಷನ್ ಬಗ್ಗೆ ಯೋಚನೆ ಮಾಡೋಣ. 200 ml ಮಿಸ್ಯೂಸ್ ಆದ್ರೆ ಮಲ್ಟಿಪ್ಲೈ ವಿತ್ ದಿಸ್ 50 lakh ವೆಹಿಕಲ್ ಪಾಪ್ಯುಲೇಷನ್ ಇದೆ, ಎಷ್ಟು ಮಿಲಿಯನ್ ಲೀಟರ್ ಫ್ಯೂಯಲ್ ಅನ್ನ ಪರ್ ಡೇ ವಿ ಆರ್ ಜಸ್ಟ್ ವೇಸ್ಟಿಂಗ್ ಆನ್ ವೇರ್ ವಿ ಆರ್ ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಸಿಗ್ನಲ್ಸ್. ಅದು ಇದು ಅನ್ನೋ ಹೆಸರೊಳಗೆ ನೀವು ನಿಂತಿರೋ ಜಾಗದೊಳಗೆ ಮಿಲಿಯನ್ಸ್ ಆಫ್ ಲೀಟರ್, ಲಕ್ಷಾಂತರ ಲೀಟರ್ ಫ್ಯೂಯಲ್ ಅನ್ನ ನಾವು ಹಾಳು ಮಾಡ್ತಾ ಇದ್ದೇವೆ ಬಿಕಾಸ್ ಆಫ್ ಇಂಪ್ರಾಪರ್ ಡಿಸೈನ್ ಆಫ್ ಸಿಟಿ. Totally agglomerated, unscientific design of city leads to all these kinds of things. AJIET college ಅನ್ನ ಇಲ್ಲಿ ಕಟ್ಟಿದ್ದೇವೆ, AJIET college ಅನ್ನ ಸಿಟಿ ಸೆಂಟ್ರಲ್ ಕಟ್ಟಿದ್ರೆ ಹೇಗಿರ್ತಾ ಇತ್ತು ಯೋಚನೆ ಮಾಡಿ. ಏನಪ್ಪ, ಅಲ್ಲಿ ಒಂದು ಮದುವೆ ಆದ್ರೆ ಮುಂದ್ಗಡೆ ಇರೋದ್ರೊಳಗೆ ಒಂದು ಬಸ್ ಹೋಗ್ಲಿಕ್ಕಿಲ್ಲ, ಒಂದು ಕಾರ್ ಹೋಗ್ಲಿಕ್ಕಿಲ್ಲ, ಒಂದು ಬೈಕ್ ಹೋಗ್ಲಿಕ್ಕಿಲ್ಲ, ಒಂದು ಹಸು ದನ ಕಾರು ಏನು ಹೋಗ್ಲಿಕ್ಕೆ ಇಲ್ಲ. ಅಷ್ಟೊಂದು ಟ್ರಾಫಿಕ್ ಡೆನ್ಸಿಟಿ ಅಲ್ಲಿ ಆಗ್ತದೆ. ಮೊದಲು ಕೊಡ್ಬೇಕು, ಆಚೆ ಜನತಾ ನಿಲ್ಲಿಸ್ತಾರೆ, ಪಕ್ಕದಲ್ಲಿ ನಿಲ್ಲಿಸ್ತಾರೆ, ರಸ್ತೆಯಲ್ಲಿ ನಿಲ್ಲಿಸ್ತಾರೆ, ಆ ಏರಿಯಾ ಎಲ್ಲ ಪಾರ್ಕಿಂಗ್ ಪ್ಲೇಸ್ ಆಗಿರ್ತದೆ. Can we have that kind of activities which we can think of in the city center there ಅಲ್ವಾ. ಅದ್ರ ಎದುರುಗಡೆ ಇನ್ನೊಂದು ಪ್ರಾಜೆಕ್ಟ್ ಬಗ್ಗೆ ಇರುತ್ತಾ ಇಲ್ಲ, ಯಾರ ವಿರೋಧ ಅಲ್ಲ, ಅನ್ಸೈಂಟಿಫಿಕ್ ಡಿಸೈನ್ ಆಫ್ ಸಿಟಿ ಹೇಗೆ ಮಾಡ್ತಾ ಇದ್ದೇವೆ ನಾವು. ಅಲ್ಲಿ ನೋಡಿ, ಒಮ್ಮೆ ಯಾರೋ ಮದುವೆ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ಬೇಕಾದ್ರೆ ಕೊನೆಗೆ ಮೊದಲಿಗಾನೆ ಬರ್ದಲೇ ಇರುವಂತ ಸ್ಥಿತಿ ಬಂತೇನೋ, ಅಥವಾ ಹುಡುಗಿ ಮದುವೆ ಆಗೋ ಹುಡುಗಿನೇ ಬರದೇ ಇರುವಂತ ಸ್ಥಿತಿ ಬರಬಹುದೇನೋ ಅಷ್ಟು. Okay, should I start?
Yes, sir.
You want the fresh energy? Yeah. Okay, very good. See, today I will share with you two things, which are purely technical, but to a small extent, I will make it in a very simplified manner, and I am permitted for half an hour, 30 minutes. You hear this and in between, any time, you are at liberty to ask the question. Simple question agli, tough question agli, helike baruvanthadagli, ಬಂದಿರೋದಾಗ್ಲಿ, legal agli, illegal agli, you are at free to express. Now let me start with something which is related to the women community. ಅಂದ್ರೆ ನಮ್ಮ ಹೆಣ್ಣು ಸಮುದಾಯಕ್ಕೂ ಪರಿಸರಕ್ಕೂ ಏನ್ ಸಂಬಂಧ, ಜಾಸ್ತಿ ಇದೀವಿ ಅಂತ ಹೇಳಿ ಹೆಣ್ಣು ಸಮುದಾಯದ ಬಗ್ಗೆ ಹೇಳ್ತೀರ ಅಂತ ಹಾಗೆಲ್ಲ. ಈ ಒಂದು ecological system ಏನಿದೆ, in all dimensions, ಪ್ರಾಣಿ ವರ್ಗ ಯೋಚನೆ ಮಾಡಿದ್ರೆ, ಮಾನವ ಸಮುದಾಯ ಯೋಚನೆ ಮಾಡಿದ್ರೆ, ಅದರೊಳಗೆ ಗಂಡು ಹೆಣ್ಣು ಅಂತ ಯೋಚನೆ ಮಾಡಿದ್ರೆ, ಯಾರಿಗೆ ಜವಾಬ್ದಾರಿ ಜಾಸ್ತಿ ಇದೆ ಅಥವಾ ಯಾರ ಇನ್ಫ್ಲೂಯೆನ್ಸ್ ಹೆಚ್ಚಿದೆ, ಕೋಳಿನ, ಕಾಗೆನ, ಕತ್ತೆನ, ಕುಬ್ಬಿನ, ನಾಯಿನ, ನರಿನ ಅಂತ ಎಲ್ಲ ನೋಡ್ತಾ ಬಂದ್ರೆ, ಕೊನೆಗೆ ಮಾನವ ಸಮುದಾಯವನ್ನು ಪ್ರಾಣಿ ವರ್ಗದಲ್ಲೇ ಸೇರಿಸ್ಕೊಂಡ್ರೆ, ಯೋಚನೆ ಮಾಡಿದ್ರೆ ಯಾರ ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ಅಂದ್ರೆ, who can have a better role, pivotal role, important role to safeguard the environment. ಅಲ್ವಾ, ಏನಾದ್ರೂ ಪೊಲ್ಯೂಷನ್ ಪ್ರಿವೆನ್ಷನ್ ಬಗ್ಗೆ ಯೋಚನೆ ಮಾಡಿದ್ರೆ ಪ್ರೊಡಕ್ಷನ್ ಬಗ್ಗೆ ಯೋಚನೆ ಮಾಡಲೇಬೇಕಾಗ್ತದೆ. ಪ್ರೊಡಕ್ಷನ್ ಇನ್ ಎನಿ ಫಾರ್ಮ್ ವಿಚ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್ ಇನ್ ದ ಇಂಡಸ್ಟ್ರಿಯಲ್ ಏರಿಯಾ, ಯಾವುದೇ ಇಂಡಸ್ಟ್ರಿಯಲ್ ಏರಿಯಾ ಆಗಿರ್ಬೋದು, ಬೇರೆ ಎಲ್ಲ ಆಗಿರ್ಬೋದು, ಕೊನೆಗೆ ನಾವು ಹೋಟೆಲ್ ಇಂಡಸ್ಟ್ರಿ ಅಂತ ತಗೊಳ್ತೇವೆ. ಯಾವುದೇ ರೂಪದಲ್ಲಿ ಏನೇ ಪದಾರ್ಥ ಎಲ್ಲೇ ಪ್ರೊಡಕ್ಷನ್ ಆಗ್ತಾ ಇದ್ರು ಕೊನೆಗೆ ಮಾನವನ ಜೀವನದಲ್ಲಿ ಅದು ಹೋಗ್ಲೇಬೇಕಿದೆ, ಸೇರ್ಲೇಬೇಕಿದೆ, ಸರಿ ತಾನೆ? ಇಲ್ಲಾಂದ್ರೆ ಅದು ಪ್ರಾಡಕ್ಟ್ ಅಲ್ಲ, ಅವ್ನು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಿರೋದು ಪ್ರಾಡಕ್ಟ್ ಅಲ್ಲ, ಅದು ಪ್ರೊಡಕ್ಷನ್ ಆಕ್ಟಿವಿಟಿ ಅಲ್ಲ, ಅದು ಮಾಡ್ತಿರೋದು ಪ್ರಾಡಕ್ಟ್ ಅಲ್ಲ. ಏನೋ ಸಮಥಿಂಗ್ ವಿಚ್ ಇಸ್ ಆಂಟಿ ನ್ಯಾಷನಲ್, ಆಂಟಿ ಸೋಷಿಯಲ್ ಆಕ್ಟಿವಿಟಿ ಅಲ್ಲಿ ನಡೀತಾ ಇದೆ ಅನ್ನೋ ರೂಪದಲ್ಲಿ ನೀವು ಯೋಚನೆ ಮಾಡಬಹುದು. ಯಾವಾಗ ಅಂದ್ರೆ ಆ ಪ್ರಾಡಕ್ಟ್ ಸಮಾಜದಲ್ಲಿ ಬೆರೆತು ಹೋಗ್ಲಿಲ್ಲ ಅಂದ್ರೆ, ಏನೋ ಬೇರೆ ರೆಡಿ ಮಾಡ್ತಾ ಇದ್ದಾರೆ, ನಿಮ್ಗೆ ಅರ್ಥ ಆಗುತ್ತಲ್ಲ ಏನು ಅಂತ? ಸೊ ಎವ್ರಿಥಿಂಗ್ ವಿಚ್ ದೇ ಆರ್ ಪ್ರೊಡ್ಯೂಸಿಂಗ್ ಈಸ್ ರೀಚಿಂಗ್ ಅವರ್ ಡೊಮೆಸ್ಟಿಕ್ ಲೈಫ್, ನಮ್ಮ ಜೀವನಕ್ಕೆ ಬರ್ತಾ ಇದೆ, ಸರಿ ತಾನೆ? ಅದು ಏನೇ ಆಗ್ಬೋದು, ಪೇಸ್ಟ್ ಆಗಿರ್ಬೋದು, ಬ್ರಷ್ ಆಗಿರ್ಬೋದು, ಬಟ್ಟೆ ಆಗಿರ್ಬೋದು, ಬಟನ್ ಆಗಿರ್ಬೋದು, ಎನಿಥಿಂಗ್, ಇಟ್ ವಿಲ್ ಡೆಫಿನೆಟ್ಲಿ ಎಂಡ್ ಅಪ್ ಇನ್ ಅವರ್ ಲೈಫ್ ಸ್ಟೈಲ್, ರೈಟ್ ಸರ್? ನಾವು ಈಗ ಏನೇ ಆಗಲಿ ಹೈಲಿ ಪೊಲ್ಯೂಟಿಂಗ್ ಆಕ್ಟಿವಿಟೀಸ್ ಅಂತ ನೋಡ್ತೇವೆ. ನಮ್ಮಲ್ಲಿ ರೆಡ್, ಆರೆಂಜ್, ಗ್ರೀನ್ ಅಂತ ಹೇಳ್ತೇವೆ ಕ್ಯಾಟಗರೈಸೇಷನ್ ಫಾರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್. ರೆಡ್ ಅಂದ್ರೆ ಹೈಲಿ ಪೊಲ್ಯೂಟಿಂಗ್ ಇಂಡಸ್ಟ್ರಿ, ಆರೆಂಜ್ ಅಂದ್ರೆ ಮಾಡರೇಟ್ಲಿ ಪೊಲ್ಯೂಟಿಂಗ್ ಇಂಡಸ್ಟ್ರಿ, ಗ್ರೀನ್ ಅಂದ್ರೆ ಲೆಸ್ ಪೊಲ್ಯೂಟಿಂಗ್ ಇಂಡಸ್ಟ್ರಿ ಅಥವಾ ನೋ ಪೊಲ್ಯೂಷನ್ ಇಂಡಸ್ಟ್ರೀಸ್ ಅಂತ ಹೇಳ್ತೇವೆ. ನಾವು ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಥಿಂಕ್ ಆಫ್, 15 ನಿಮಿಷ ಸಮಯ ಅಷ್ಟೇ ಇರೋದು, ಹಾಗಾಗಿ ಲೆಟ್ ಅಸ್ ಕಾನ್ಸಂಟ್ರೇಟ್ ಓನ್ಲಿ ಆನ್ ಹೈಲಿ ಪೊಲ್ಯೂಟಿಂಗ್ ಇಂಡಸ್ಟ್ರೀಸ್. ಇವು ಯಾವ ಏನು ಅಂತ ಯೋಚನೆ ಮಾಡಿದ್ರೆ ಟೆಕ್ಸ್ಟೈಲ್ ಇಂಡಸ್ಟ್ರಿ, ಗಾರ್ಮೆಂಟ್ಸ್ ಇದೆ, ಹೈಲಿ ಪೊಲ್ಯೂಟಿಂಗ್ ಇಂಡಸ್ಟ್ರೀಸ್ ಅಲ್ಲಿ ಇದೆ. ನೆಕ್ಸ್ಟ್ ಯಾವ್ದು ಇರ್ಬೋದು? ವೆಹಿಕಲ್ ಇಂಡಸ್ಟ್ರಿ, ಮೆಟಲ್ ಪ್ಲೇಟಿಂಗ್ ಇಂಡಸ್ಟ್ರಿ. ನೀವು ಆ ಡೋರ್ ಅಲ್ಲಿ ಬಂಗಾರದ ರೀತಿಯಲ್ಲಿ ಹ್ಯಾಂಡ್ ಆಗಲಿ, ಲ್ಯಾಚ್ ಆಗಲಿ, ಅವೆಲ್ಲ ಒಂದು ಗೋಲ್ಡ್ ಕೋಟೆಡ್ ತರ ಕಾಣಿಸ್ತದಲ್ಲ, ದಟ್ಸ್ ನಾಟ್ ಗೋಲ್ಡ್ ಕೋಟೆಡ್, ಇಟ್ ಇಸ್ ಕ್ರೋಮಿಯಂ ಕೋಟೆಡ್. ಕ್ರೋಮಿಯಂ ಮೆಟಲ್ ಗೊತ್ತಲ್ಲ, ಹೆಕ್ಸಾವೆಲೆಂಟ್ ಕ್ರೋಮಿಯಂ, ಟ್ರೈವೆಲೆಂಟ್ ಕ್ರೋಮಿಯಂ. ಕ್ರೋಮಿಯಂ ಮೆಟಲ್ ಅನ್ನ ಅದನ್ನ ಕೋಟ್ ಮಾಡಿದ್ರೆ ಬಂಗಾರದ ರೀತಿಯಲ್ಲಿ ಕಾಣಿಸ್ತದೆ, ಅದು ಬಂಗಾರ ಅಲ್ಲ, ಅಲ್ವಾ? ಆಯ್ತು, ಪ್ಲೇಟ್ ಮಾಡಿದ್ರೆ ಕಳಿಸ್ತಾ ಇದ್ದಾರೆ, ಏನ್ ಸಮಸ್ಯೆ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. ಆ ಕ್ರೋಮಿಯಂ ಏನಿದೆ, ಎಫ್ಲುಯೆನ್ಸ್ ಏನಿದೆ, ಅದು ಟ್ರೈವೆಲೆಂಟ್ ಆಗಲಿ, ಹೆಕ್ಸಾವೆಲೆಂಟ್ ಕ್ರೋಮಿಯಂ ಆಗಲಿ, ಹೈಲಿ ಕ್ಯಾನ್ಸರ್ ಕಾಸಿಂಗ್. ಆದ್ರೆ ಇದನ್ನು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡೋದು ನಮ್ಮ ಮನೆಗೆ ಬಂದಿರೋದು ಬರೀ ಡೋರ್ ಅಷ್ಟೇ ಅಲ್ಲ ಸರ್, ಅದೇನು ಹ್ಯಾಂಡಲ್ ಅಷ್ಟೇ ಅಲ್ವಾ? ನೋ, think of the people those who are working there and the vanity bags that we are using, leather bags that we are using, leather bags or leather appliances that we are using, and how they are getting tanned. ನಿಮ್ಮ ದನದ ಚರ್ಮ, ಕುರಿ ಚರ್ಮ ಎಲ್ಲ ಕೊನೆಗೆ ಮಹಿಳಾ ಸಮುದಾಯಕ್ಕೆ ಏನ್ ಸಂಬಂಧ ಅಂತ ಹೇಳ್ತೇನೆ, ಗೊತ್ತಾಯ್ತಲ್ವ? ಯಾಕೆ ನೀವು ಹುಷಾರಾಗಬೇಕು, ಪರಿಸರ ಉಳಿಬೇಕಂದ್ರೆ ಮಹಿಳೆಯ ಪಾತ್ರ ಏನು ಅಂತ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು, ಗೊತ್ತಾಯ್ತಲ್ವಾ? ಅಂದ್ರೆ ನಮ್ಮ ಅಮ್ಮಗೆ ಹೇಳ್ತೇವಲ್ವಾ, ಒಂದು ಹೆಣ್ಣು ಸಮುದಾಯಕ್ಕೆ ಏನಾದ್ರು ವಿಷಯ ಅರ್ಥ ಆದ್ರೆ ಚಿತ್ರವಾದ ಒಂದು ವಿಷಯ ಹೇಳ್ತೇನೆ. ಕ್ರೈಮ್ ರೇಟ್ಗೂ ಹೆಣ್ಣು ಸಮುದಾಯಕ್ಕೂ ಸಂಬಂಧ ಇದೆಯಾ? ಕ್ರೈಮ್ ರೇಟ್ ಹೇಳ್ತಿರ್ತೀವಿ, ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲ. ಕ್ರೈಮ್ ರೇಟ್ಗೂ ಒಂದು ಯಾವುದೋ ದೇಶ, ಆ ದೇಶದಲ್ಲಿ ತುಂಬಾ ತೊಂದರೆ ಅನುಭವಿಸ್ತಾ ಇದ್ದಾರೆ, ಆ ದೇಶದವರು ಇನ್ನೊಂದು ದೇಶದಲ್ಲಿ, ನಾನು ಯಾವುದೇ ಹೆಸರು ಹೇಳುದಿಲ್ಲ, ಬೇಡ, ನಮ್ಗೆಲ್ಲ ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ ಅಲ್ಲಿ ಯಾವುದೇ ಒಂದು ಸಮುದಾಯ ಅಥವಾ ಯಾವುದೋ ಒಂದು ಜನಾಂಗ ಅಥವಾ ವಿದ್ಯಾರ್ಥಿಗಳು ಅಥವಾ ಜನರು ಇನ್ ಜನರಲ್, ಅವರ ಬಿಹೇವಿಯರ್ ತಾಯಿಯ ಪಾತ್ರಕ್ಕೂ ಸಂಬಂಧ ಇದೆಯಾ? ಖಂಡಿತ ಇದೆ. ಕ್ರೈಮ್ ರೇಟ್ಗೂ ತಾಯಿಗೂ ಸಂಬಂಧ ಇದೆ, ನಿಜವಾಗ್ಲಿದೆ. ಯಾರಾದ್ರೂ ಏನೇನೋ ನಾವು ಸಮಾಜ ವಿದ್ರೋಹಿ ಘಟನೆಗಳು, ಸಮಾಜ ವಿದ್ರೋಹಿ ಶಕ್ತಿಗಳು, ಸಮಾಜ ವಿದ್ರೋಹಿ ಚಟುವಟಿಕೆಗಳು ಯಾವನೋ ಒಬ್ಬನು ಮಾಡ್ತಾ ಇದ್ದಾನೆ ಅಂದ್ರೆ ಇವು ಹೀಗೆ ಮಾಡ್ಲಿಕ್ಕೆ ಕಾರಣ ತಾಯಿ. ಹೌದು, ನಂತರ ಮಾತ್ರ ಸಮಯ ಇಲ್ಲ, ಗೊತ್ತೇ ಸಿಗೋಣ. ಈಗ ಒಂದು ಹೇಳ್ತೇನೆ, ಒಂದು ಥೈಲ್ಯಾಂಡ್ ಅಲ್ಲಿ ಒಂದು ಇಂಟರ್ನ್ಯಾಷನಲ್ ಕಾನ್ಫರೆನ್ಸ್ ಇತ್ತು. ದಟ್ ಸಬ್ಜೆಕ್ಟ್ ವಾಸ್ ಆನ್ the things that we have to think of, or that we can think about a system change in our social life. ನಮ್ಮ ಸಾಮಾಜಿಕ ಜೀವನದಲ್ಲಿ ಬೇಕಾಗಿರುವಂತಹ ಬದಲಾವಣೆಗಳನ್ನ ಯಾವ ರೀತಿ ಮಾಡಿದರೆ ವಿಶ್ವ ಸಮುದಾಯ ಪರಿಸರ ಪೂರಕವಾದ ಜೀವನವನ್ನ ನಡೆಸಲಿಕ್ಕೆ ಸಾಧ್ಯ ಅನ್ನೋದು ಟೈಟಲ್. ಏನ್ ಮಾಡಬಹುದು? ಲಕ್ಷ್ಮೀಕಾಂತ ಅದರೊಳಗೆ ಇದ್ದ, ಏನಂತ ಏನ್ ಮಾತಾಡಿರ್ಬೋದು? ಅಲ್ಲಿ ಬಸ್ಗಳ ಬಗ್ಗೆ, ಕಾರುಗಳ ಬಗ್ಗೆ, ಬೆಂಗಳೂರು ಬಗ್ಗೆ ಹೇಳಿದ್ನ? ನೋ, ಇನ್ನೊಂದು ಸಬ್ಜೆಕ್ಟ್ ಇದೆ, ಹೇಳ್ಬಿಟ್ಟು ಮತ್ತೆ ಹೇಳ್ತಾರೆ, ಮುಗಿಸೋಣ. ಅವರಿಗೆ ನಾನು ಹೇಳಿದೆ, ವಿಶ್ವ ಸಮುದಾಯ ಬಂಟ್ವಾಳದವರು, ಮಂಗಳೂರಿನವರು, ದಕ್ಷಿಣ ಕನ್ನಡದವರು, ಕರ್ನಾಟಕದವರು ಅಲ್ಲ. ವಿಶ್ವ ಸಮುದಾಯ ಅವರು ನಡೆಸ್ಕೊಂಡು ಹೋಗ್ತಾ ಇರುವಂತಹ ತನ್ನ ದೈನಂದಿನ ಜೀವನದ ಪರಿಕ್ರಮ ಅಥವಾ ಕ್ರಮ, ದಲ್ಲಿ ಬದಲಾವಣೆ ತಂದ್ರೆ ವಿಶ್ವ ಪರಿಸರಕ್ಕೆ ಸಹಾಯ ಆಗಬಹುದು ಅಥವಾ ಪೂರಕವಾಗಬಹುದು ಅನ್ನೋದು ಸಬ್ಜೆಕ್ಟ್. ನಾ ಏನ್ ಮಾತಾಡ್ಲಿ, ನಾನು ಹೇಳಿದೆ ಕಮ್ಯುನಿಟಿ ಕಿಚನ್ ಇಸ್ ದ ಕಾನ್ಸೆಪ್ಟ್. ವಾಟ್ ಇಸ್ ಕಮ್ಯುನಿಟಿ ಕಿಚನ್? ಸಾಹೇಬ್ರ ಜೊತೆ ನಾನು ಕ್ಯಾಂಟೀನ್ ಮಾತಾಡ್ತಿರೋವಾಗ ಹೇಳ್ತಾ ಇದ್ದೆ, ನೀವು ವಿದ್ಯಾರ್ಥಿಗಳು ಯೂನಿವರ್ಸಿಟಿಯಲ್ಲಿ ಇರೋವರು, ಇಂಜಿನಿಯರಿಂಗ್ ಕಾಲೇಜಲ್ಲಿ ಯೂನಿವರ್ಸಿಟಿ ಇರೋವರು, ಹೆಣ್ಮಕ್ಳು ಚೆನ್ನಾಗಿ ಓದ್ತಾರೆ, ಹೆಣ್ಮಕ್ಳು ಚೆನ್ನಾಗಿ ಓದ್ತಾರೆ, ಹೆಣ್ಮಕ್ಳು ರ್ಯಾಂಕ್ ಬರ್ತಾರೆ, ಗಂಡ್ಮಕ್ಳು ರ್ಯಾಂಕ್ ಬರ್ತಾರೆ. ಒಂದು ಕ್ಷಣ, ಒಂದು ಮೂಮೆಂಟ್, ದ ಮೂಮೆಂಟ್ ಯು ಲೀವ್ ದಿಸ್ ಕ್ಯಾಂಪಸ್, ಯೂನಿವರ್ಸಿಟಿ ಕ್ಯಾಂಪಸ್, ನಿಮ್ಮ ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ಟು ದ ಸೊಸೈಟಿ ಏನು ಆಸ್ ಅ ಮೇಲ್, ನಿಮ್ಮ ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ಟು ದ ಸೊಸೈಟಿ ಏನು ಆಸ್ ಅ ಫೀಮೇಲ್, ಜಸ್ಟ್ ಥಿಂಕ್ ಆಫ್. ಕ್ಯಾಂಪಸ್ ಅಲ್ಲಿ ಇರೋವರೆಗೂ ಹೆಣ್ಮಕ್ಳು ಸರಿಯಾಗಿ ಕಾಂಟ್ರಿಬ್ಯೂಟ್ ಮಾಡ್ತಾರೆ, ಕ್ಯಾಂಪಸ್ ಅಲ್ಲಿ ಇರೋವರೆಗೆ ಅವರು ರ್ಯಾಂಕ್ ಬರ್ತಾರೆ, ಇವರು ರ್ಯಾಂಕ್ ಮಾಡ್ತಾರೆ. ಕ್ಯಾಂಪಸ್ ಇಂದ ಹೊರಗೆ ಹೋದ ತಕ್ಷಣ ಹೆಣ್ಮಕ್ಳು ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ಟು ದ ಸೊಸೈಟಿ ಇಸ್ ಆಲ್ಮೋಸ್ಟ್ ಲೈಕ್ ಝೀರೋ. ವೈ? ಏನಾಗ್ತಾ ಇದೆ ನಿಮಗೆ? ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ನಾನು ಹೇಳ್ತಾ ಇದ್ದೆ ನಂಬರ್ ಆಫ್ ಪೇಟೆಂಟ್ಸ್ ಫೈಲ್ ಅನ್ನ ಚೆಕ್ ಮಾಡಿ. ಯಾಕಂದ್ರೆ ವಿಶ್ವ ಸಮುದಾಯದಲ್ಲಿ ನೀವು ಏನಾದ್ರೂ ನೀವು ಜಾಣ, ನೀವು ದಡ್ಡ ಅಂತ ಹೇಳಿಕೆ ಬೇಕಾಗಿರೋ ಒಂದು ಕ್ಯಾರೆಕ್ಟರೈಸೇಷನ್ ಅಂಡ್ analysis is also there based on the statistical information. The number of check ಮಾಡಿ plot the graph against the then community. ಏನು ನಮ್ಮಲ್ಲಿ ಡಿವೈಡ್ ಮಾಡ್ಲಿಕ್ಕೆ ಏನೋ ಮಾಡ್ತಾರೆ ನೀವು ಮನುಷ್ಯ ಅಂತೀರಾ? ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿಪ್ಪ, ಹೇಗಿದೆ ವ್ಯವಸ್ಥೆ, ಹೇಗಿದೆ ಸಮಾಜ. ಯುಎಸ್ ಅಲ್ಲಿ ಇರುವಂತ ಕೆಲವು ಜನ ನನಗೆ ಇಷ್ಟು ಉದ್ದ ಪತ್ರ ಬರೆದಿದ್ದಾರೆ, ಇವೆಲ್ಲ ನೀವು ಮಾತಾಡಬಾರ್ದು ಅಂತ. ಯಾಕೆ ಅಂತ ಹೇಳ್ತಾರೆ ಕೇಳಿ. I told them the number of patents filed by women community in India is very minimal. Why? If you plot that, the graph touches almost x-axis. Check with that. X-axis ಹತ್ರ ಇದ್ದೀರಿ ಅಂತ ಅರ್ಥ ನೀವು ಬುದ್ಧಿವಂತರು ಅಲ್ಲ. ಇನ್ನು ಸ್ವಲ್ಪ ಕೆಟ್ಟ ಭಾಷೆ ಹೇಳ್ಬೇಕಂದ್ರೆ ನೀವು ಅಯೋಗ್ಯರು. ಸರಿ ತಾನೆ? ಯಾಕೆ ಹೀಗೆ? ನನ್ನ ಮಾತು ಕೇಳಿ, ಯಾಕೆ ಹೀಗೆ? ವೈ ಇಟ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್ ಲೈಕ್ ದಿಸ್? ನಿಮಗೆ ಜಾಣ್ಮೆ ಇಲ್ವಾ ಅಥವಾ ಇರೋ ಜಾಣ್ಮೆನ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬಿಡ್ತಾ ಇಲ್ವಾ? ಸಮಾಜದ ಹೆಸರಲ್ಲಿ, ಸಾಮಾಜಿಕ ವ್ಯವಸ್ಥೆ ಹೆಸರಲ್ಲಿ ನಿಮ್ಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬಿಡ್ತಾ ಇಲ್ವಾ? ಏನಾಗ್ತಾ ಇದೆ? ನಾನು ಹೇಳ್ತಾ ಇದ್ದೆ, ಅಲ್ಲ ಕಣೆ, ನೀನ್ ನನಗೆ ಜೀವನ ಪರ್ಯಂತ ಅನ್ನ ಮಾಡಾಕ್ತೀಯ ಅಂತೇಳಿ ನಿನಗೆ ನಾನು ಅನ್ನ ಹಾಕ್ಬೇಕಾ? ಜೀವನ ಪರ್ಯಂತ. ಅರ್ಥ ಆಯ್ತಾ ನಿಮ್ಗೆ? ನೀನ್ ನನಗೆ ಅನ್ನ ಮಾಡಾಕ್ತೀಯ, ಅದ ನನಗೆ ಹೊಟ್ಟೆಗೆ ಅನ್ನ ಹಾಕ್ತೀಯ ಅಂತ. ಸಾಮಾಜಿಕ ವ್ಯವಸ್ಥೆ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾ ಇಲ್ಲ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಕೆಲವೊಂದ್ಸರಿ ಈ ಗಣೇಶನ ಪೂಜೆ ಬಗ್ಗೆ ಮಾತಾಡ್ತಿರುವಾಗ ನಮ್ಗೆ ಏನೆಲ್ಲ ಪ್ರಶ್ನೆ ಬಂದಿದೆ ಅಂತ ನಿಮ್ಗೆ ಹೇಳ್ತೇನೆ. ಈಗ ಸಮಯ ಇಲ್ಲ, ಆಯ್ತಾ? ನೀನು ನನಗೆ ಜೀವನ ಪರ್ಯಂತ ಅನ್ನ ಮಾಡಾಕ್ತೀಯ ಅಂತ ಹೇಳಿ ನಾನು ನಿನಗೆ ಜೀವನ ಪರ್ಯಂತ ಅನ್ನ ಹಾಕ್ಬೇಕಾ? ಇಂಥ ಒಂದು ಸಾಮಾಜಿಕ ವ್ಯವಸ್ಥೆ ಬೇಕಾ? ಹಾಗಾದ್ರೆ why you are not allowed to express? Why you are not expressing? Why you are getting relaxed after your marriage? ಏನು ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ಇಲ್ಲ ಅಂದ್ರೆ ಎಂತ ಗೊತ್ತಾಯ್ತಲ್ವಾ? ಹೇಳಿದವ್ರಿಗೆ ಯಾಕೆ ಏನ್ ಮಾಡ್ತಾರೆ? ಸಾಮಾಜಿಕ ಪರಿವರ್ತನೆ ಏನ್ ಬೇಕು? ಒಂದು ವಿಷಯ ಯೋಚನೆ ಮಾಡಿ. ನಾನು ನಿಮ್ಗೆ ಹೇಳಿದೆ, ಯೂನಿವರ್ಸಿಟಿ ಇರುವಾಗ ನೀವು ಇಬ್ರು ಕಾಂಟ್ರಿಬ್ಯೂಟ್ ಮಾಡ್ತೀರಾ, ಇಬ್ರು ಜಾಣರು ಅಂತ ಹೇಳ್ಕೊಡ್ತೀರಾ, ಯೂನಿವರ್ಸಿಟಿ ಕಾಂಪೌಂಡ್ ದಾಟಿದ್ರೆ ನಿಮ್ಮನ್ನು ಬರ್ತಾ ಇಲ್ಲ. ಚೆಕ್ ವಿತ್ ಯುವರ್ ಸೋಷಿಯಲ್ ಸಿಸ್ಟಮ್ ವಾಟ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್ ಟು ದಿಸ್ ಕಮ್ಯುನಿಟಿ. ಗೊತ್ತಾಯ್ತಾ? ಅಲ್ಲಿ ನಾನು ಥೈಲ್ಯಾಂಡ್ ಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ದೇನೆ ಅಂದ್ರೆ ಲೆಟ್ಸ್ ಹ್ಯಾವ್ ಎ ಕಮ್ಯುನಿಟಿ ಕಿಚನ್ ಅಂತ. ಲೆಟ್ಸ್ ಹ್ಯಾವ್ ಎ ಕಮ್ಯುನಿಟಿ ಕಿಚನ್ ಸಿಸ್ಟಮ್ ಫಾರ್ ಅವರ್ ಸೋಷಿಯಲ್ ಸಿಸ್ಟಮ್. ಸಾಮಾಜಿಕ ವ್ಯವಸ್ಥೆಯಲ್ಲಿ ಸಾಮಾಜಿಕ ಬದಲಾವಣೆಗಳನ್ನ ಹೇಗೆ ತರಬೇಕಂದ್ರೆ ಸಮಾಜನೇ ಯೂನಿವರ್ಸಿಟಿ ತರ ಮಾಡೋಣ. ಸಮಾಜನೇ ಯೂನಿವರ್ಸಿಟಿ ತರ ಯೋಚನೆ ಮಾಡೋಣ. ಅಂದ್ರೆ ಯೂನಿವರ್ಸಿಟಿಲಿ ಏನಾಗ್ತಾ ಇದೆ? ಬೆಳಿಗ್ಗೆ ನೀನು ಎದ್ದೇಳ್ತೀಯ, ರೆಡಿ ಆಗ್ತೀಯ, ಸ್ನಾನ ಮಾಡ್ತೀಯ, ಬಟ್ಟೆ ಹಾಕೊಳ್ತೀಯ, ಅಲ್ಲಿ ಎಎಂಎಸ್ ಅಲ್ಲಿ, ಬಿಎಂಎಸ್ ಅಲ್ಲಿ, ಸಿಎಂಎಸ್ ಅಲ್ಲಿ ಅಡಿಗೆ ಮಾಡಿರ್ತಾರೆ, ವೆಜ್ ನಾನ್ ವೆಜ್ ಎಲ್ಲ ಹೋಗ್ತೀಯ, ಚಾಯ್ಸ್ ಮಾಡ್ತೀಯ, ಊಟ ಮಾಡ್ತೀಯ, ಕಾಲೇಜಿಗೆ ಬರ್ತೀಯ, ಯೂನಿವರ್ಸಿಟಿ ಬರ್ತೀಯ, ಲ್ಯಾಬೊರೇಟರಿ ಬರ್ತೀಯ. ಯು ಆರ್ ಕಾಂಟ್ರಿಬ್ಯೂಟಿಂಗ್ and you are allowed to contribute. Whereas when the moment you get into the social system, you are not allowed to get into the system. ನೀನು ಅಡಿಗೆ ಮನೆಯಲ್ಲೇ ಸಮಯ ಕಳ್ತಾ ಇದ್ದೀಯ. ಹಂಗಾದ್ರೆ ನೀನು ಹೆಣ್ಮಕ್ಳು ಸಪೋರ್ಟ್ ಮಾಡ್ತೀಯ? ನೀನು ಹೆಣ್ಮಕ್ಳು ಸಪೋರ್ಟ್ ಮಾಡೋದಿದ್ಯಾ ಅಂತ ಕೇಳಿರೋ ಜನರು ಇದ್ದಾರೆ. ವಿಷಯ ಏನಂತ ಕೇಳಬೇಕು. ಫಾರ್ ಯು ಕಿಚನ್, ನಿಮಗೆ ನಾನು ಇದಕ್ಕೆ ಮುಂಚೆ ಹೇಳ್ತಾ ಇದ್ದೆ, ನೀವು ತಿನ್ನೋ ಮೆಡಿಸಿನ್ ನಿಮಗೆ, ನನಗಲ್ಲ, ಎನ್ವೈರನ್ಮೆಂಟಲಿಸ್ಟ್ ಅಲ್ಲ. ಇಟ್ಸ್ ಎ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಕೆಮಿಕಲ್ ಕ್ಯಾಪ್ಸೂಲ್ ಅಂತ ಹೇಳಿದ್ರೆ, ಕ್ಯಾಪ್ಸೂಲ್ ವಿಚ್ ಇಸ್ ಡಿಸೈನ್ಡ್ ಟು ಸೂಟ್ ಯುವರ್ ಇಲ್ನೆಸ್. ರಾಸಾಯನಿಕ ಅದು. ನೀನು ಅದಕ್ಕೆ ಬೇರೆ ಇಟ್ಕೊಂಡಿದ್ದೆ ಅಷ್ಟೇ, ಸೇರ್ಪ ತಿನ್ಕೊಳ್ಳಿಕ್ಕೆ, ನಿನ್ನ ಮೈಂಡ್ ಒಪ್ಕೊಳ್ಳಿಕ್ಕೆ. ಸರಿ ತಾನೆ? ಅದನ್ನ ಈಗ ಅಡಿಗೆ ಮನೆಗೆ ಬಂದ್ರೆ, ಅಡಿಗೆ ಮನೆ ನಿಮ್ಗೆ ಏನ್ ಕಾಣಿಸ್ತಾ ಇದೆ? ಅದೊಂದು ಮೆಟಲ್ ಕ್ಯಾಬಿನ್. ಅದು ಅಡಿಗೆ ಮನೆ ಮೆಟಲ್ ಕ್ಯಾಬಿನ್ ಅಂದ್ರೆ ಹಿಂಗ್ ತಟ್ಟೆ, ಲೋಟ, ಚಮಚ, ಅಂಡೆ, ಕೊಳಗ ಅವೆಲ್ಲ ಇಟ್ಕೊಂಡು ಜೊತೆಗೆ ಅಟ್ಟದ ಮೇಲೆ ಅಂಡೆ, ಕೊಳಗ ಎಲ್ಲ ಸ್ಟಾರ್ಟ್ ಮಾಡಿರ್ತಾರೆ. ನಿಮ್ ತಾಯಿಗೋ ನಿಮ್ಮ ಅಜ್ಜಿಗೋ ಕೇಳಿ, ಏನೇ ಎಕ್ಸ್ಟ್ರಾ ಕೊಳಗ, ಎಕ್ಸ್ಟ್ರಾ ಅಂಡೆ, ಎಕ್ಸ್ಟ್ರಾ ತಟ್ಟೆಗಳೆಲ್ಲ ಅಟ್ಟದ ಮೇಲೆ ಇಟ್ಟಿದ್ದೀರಿ, ಬೇಕಾಗಿರ್ಲಿಲ್ಲ ಅಂತ ಕೇಳಿದ್ರೆ, ಮಗ ಮದುವೆ ಇದೆಯಲ್ಲೋ ಕೊಡ್ಬೇಕಲ್ಲ, ಅದಕ್ಕೆ ಅಲ್ಲಿಟ್ಟಿದೆ. ಮಿನಿಮಮ್ 1 ರಿಂದ 2 ಟನ್ ಮೆಟಲ್ ಅಂಡ್ ಮೆಟಾಲಿಕ್ ಐಟಮ್ಸ್ ಆರ್ ದೇರ್ ಇನ್ ಯುವರ್ ಕಿಚನ್ ಕ್ಯಾಬಿನೆಟ್. ಏನಾಯ್ತು ಬೇಕಲ್ಲ ಸರ್, ಫೋರ್ಕ್ ಬೇಕು, ನೋಡಿ ಫೋರ್ಕ್ ಬೇಕು, ತಟ್ಟೆ ಬೇಕು, ಲೋಟ ಬೇಕು, ಗ್ಯಾಸ್ ಸಿಲಿಂಡರ್ ಇಂದ ಹಿಡಿದು ಅಷ್ಟು ಮೆಟಲ್ ಇದೆ. ನಿಮ್ಗೆ ಮೆಟಲ್ ಕಾಣಿಸ್ತಾ ಇದೆ, ನನಗೆ ಮೈನಿಂಗ್ ಕಾಣಿಸ್ತಾ ಇದೆ. ಗೊತ್ತಾಯ್ತಲ್ವಾ? ಮೈನಿಂಗ್ ಅಂದ್ರೆ ಏನು? ಮೈನಿಂಗ್ ಅಂದ್ರೆ ಗೊತ್ತಲ್ವಾ? ಅದು ಸಾಲಿಡ್ ವೇಸ್ಟ್ ಆಗ್ಬೋದು, ಹೆಸಲೆಸ್ ವೇಸ್ಟ್ ಆಗ್ಬೋದು, ಕೆಮಿಕಲ್ ವೇಸ್ಟ್ ಆಗ್ಬೋದು, ಏರ್ ಪೊಲ್ಯೂಷನ್ ಆಗ್ಬೋದು, ಸಾಯಿಲ್ ಪೊಲ್ಯೂಷನ್ ಆಗ್ಬೋದು, ವಾಟರ್ ಪೊಲ್ಯೂಷನ್ ಆಗ್ಬೋದು. Entire ecological system is getting damaged because of our social system, which is allowing you to cook your. ನಾನು ಕೊಟ್ಟಿದ್ದು ಏನು ಬರಲಿ, 2 ಇಡ್ಲಿ, 1 ವಡೆ, ಸರಿ ತಾನೆ? ಅಷ್ಟೇ. ಒಂದು 150 ml ಸಾಂಬಾರ್, ಒಂದು 100 ml ಚಟ್ನಿ, ಸರಿ ತಾನೆ? ಇಷ್ಟಕ್ಕೆ ನನ್ನ ಎಂಟೈರ್ ಹ್ಯೂಮನ್ ಕಮ್ಯುನಿಟಿ is forced to not to deliver their duty, not to express their talent. ಸರಿ ತಾನೆ? ಆಗಿರುವಾಗ ಈ ಒಂದು ಸಾಮಾಜಿಕ ವ್ಯವಸ್ಥೆ ಒಳಗೆ ಅಡಿಗೆ ಮನೆ ಬೇಕಾ ಬೇಡ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೆ ನಾನು. ಅದಕ್ಕೆ ನನ್ನ ಜೋರ್ ಮಾಡಿರೋ ಜನ ಇದ್ದಾರೆ. ನಿಜವಾಗ್ಲೂ ನಾನು ಏನ್ ಹೇಳ್ತಾ ಇದ್ದೆ, ಕೊಡುತ್ತಾಯೇ ಕೊಡುವರವ ಕುಡುಕನಲ್ಲದ ಗಂಡ ನಾ ಅಂತ ಒಂದು ಮಾತಿದೆ. ಕೊಡುತ್ತಾಯೇ ಕೊಡುವರವ ಕುಡುಕನಲ್ಲದ ಗಂಡನ. ಯಾಕಂದ್ರೆ ತುಂಬಾ ಜನ ಗೊತ್ತಲ್ಲ, ಅವನು ಹಾಳಾಗುವುದಂದ್ರೆ ಇವನು ಹೊಡೆದು ಹಾಳುತ್ತೆ. ನಿಮ್ಗೆ ಇಲ್ಲಿ ಗೊತ್ತಾಗಲ್ಲ, ಕರಾಳ ಸ್ವಲ್ಪ ಮೇಲೆ ನಮ್ಗೆ ಗೊತ್ತಾಗ್ತದೆ ನಿಮ್ಗೆ ಹೇಗಿರ್ತದೆ, ಅಲ್ಲಿ ಹೇಗಿರ್ತದೆ ಡೈಲಿ. ಪ್ರಾಂತೀಯ ಅಸಮತೋಲನ ಅಂತ ಒಂದು ಪದ ಯಾಕಿದೆ ಅಂತ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ತದೆ. ರೀಜನಲ್ ಇಂಬ್ಯಾಲೆನ್ಸ್ ಅಂದ್ರೆ ಏನು ಅನ್ನೋದು ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ತದೆ. ಎಕ್ಸ್ಪ್ಲಾಯಿಟೇಷನ್ ಅಂದ್ರೆ ಏನು, ಆ ವರ್ಡ್ ಯಾಕಿದೆ ಎಕ್ಸ್ಪ್ಲಾಯಿಟೇಷನ್ ಅನ್ನೋದು ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ತದೆ. ಜಸ್ಟ್ ಕಮ್ ದೇ. ಖಂಡಿತ ನಾನು ನಿಮ್ಗೆ ತಮಾಷೆ ಇರ್ತಾ ಇಲ್ಲ, ಇದು ಕಮ್ ದೇ. ಚೆಕ್ ಫಾರ್ ದ ಪೀಪಲ್ ಅಂಡ್ ದೇರ್ ಲೈಫ್ ಸ್ಟೈಲ್. ಈ ಮೆಟಲ್ ಕ್ಯಾಬಿನ್ ಬಗ್ಗೆ ಮಾತಾಡೋಣ. ಒಂದು ಫ್ಯಾಮಿಲಿ ಅವನು ತಿನ್ನೋ ಒಂದು ಟಿಫನ್ಗೆ, ಒಂದು ಊಟಕ್ಕೆ, ರಾತ್ರಿ ಊಟಕ್ಕೆ ಬೇಕಾಗಿರೋ ಹಾಗೆ ಎಷ್ಟು ದೊಡ್ಡ ಇನ್ಫ್ರಾಸ್ಟ್ರಕ್ಚರ್ ನಾನು ನಿಮಗೆ ಮಾಡಿಕೊಡ್ಬೇಕಾಗಿದೆ. ಬ್ಯಾಂಕಿಂಗ್ ಸಿಸ್ಟಮ್ ಬಗ್ಗೆ ಸಪರೇಟ್ ಹೇಳಿದ್ದೇನೆ, ಸಿಂಗಲ್ ಬ್ಯಾಂಕಿಂಗ್ ಸಿಸ್ಟಮ್ ಅಂತ ಹೇಳಿದ್ದೇನೆ. ಅದು ನೀವು ಇನ್ನೊಮ್ಮೆ ಹೇಳ್ತೇನೆ. ಸಿಂಗಲ್ ಬ್ಯಾಂಕಿಂಗ್ ಸಿಸ್ಟಮ್ ಏನು ಅನ್ನೋದನ್ನ ಒಂದು ಸಿಂಪಲ್ ಆಗಿ ಹೇಳ್ತೇನೆ. ಒಬ್ಬ ವ್ಯಕ್ತಿಗೆ ಬ್ಯಾಂಕ್ ಇದೆ ಅಂದ್ರೆ, ಸಾಮಾಜಿಕ ವ್ಯವಸ್ಥೆಯಲ್ಲಿ ಬ್ಯಾಂಕ್ ಇದೆ ಅಂದ್ರೆ, ಪರಿಸರಕ್ಕೂ ಬ್ಯಾಂಕು ಏನ್ ಸಂಬಂಧ ಅಂತ ನೀವು ಹೇಳ್ಬೋದು. ಪರಿಸರಕ್ಕೂ ಬ್ಯಾಂಕಿಗೆ ಏನ್ ಸಂಬಂಧ? ಬ್ಯಾಂಕ್ ಅಲ್ಲಿ ಏನ್ ನಡೀತಾ ಇದೆ? ಹಣ ಕಟ್ತೇನೆ, ಇಲ್ಲ ಹಣ ಡ್ರಾ ಮಾಡ್ತೇನೆ. That's all it's happening. ಆಗಿರುವಾಗ why you want to have multiple banking system? There is no need to have a multiple banking system for any community across the world. ನೀನು ಹುಟ್ಟಿದೆ ಅಂದ್ರೆ ನೀನು ಹಣೆ ಮೇಲೆ ಒಂದು ಬ್ಯಾಂಕ್ ಅಕೌಂಟ್ ಹಾಕಿದ್ರೆ ಬೆಳೆಯೋವರೆಗೂ ಸಾಯೋವರೆಗೂ ಅದೇ ಬ್ಯಾಂಕ್ ಅಕೌಂಟ್ ಇಸ್ ವ್ಯಾಲಿಡ್ ಅಂಡ್ ಸಿಂಗಲ್ ಬ್ಯಾಂಕ್ ಇಸ್ ಎನಫ್ ಟು ಮ್ಯಾನೇಜ್ ದ ಎಂಟೈರ್ ಸಿಸ್ಟಮ್. ಒಂದು ಯಾವ ಸ್ಟೇಟ್ ಬ್ಯಾಂಕ್ ಆಫ್ ಇಂಡಿಯಾ, ಸ್ಟೇಟ್ ಬ್ಯಾಂಕ್ ಆಫ್ ಭಾರತ್ ಎಲ್ಲೋ ಮಾಡ್ಕೊಳ್ಳಿ, ಅದು ಒಂದೇ ಸಾಕು. ಮಲ್ಟಿಪಲ್ ಬ್ಯಾಂಕಿಂಗ್ ಸಿಸ್ಟಮ್ ಇಂದ ನಿಮಗೆ ಏನಾಗ್ತಾ ಇದೆ, ಪರಿಸರಕ್ಕೆ ಏನಾಗ್ತಾ ಇದೆ ಅಂತ ಕೇಳಿ. ನೀವು ಒಂದು ಬ್ಯಾಂಕ್ ನೋಡಿದ್ರೆ ಯಾವ್ದೋ ಒಂದು AB ಬ್ಯಾಂಕ್, ಕೆನರಾ ಬ್ಯಾಂಕ್, ಯಾವ್ದೋ ಒಂದು ಬಿಲ್ಡಿಂಗ್ ನೋಡ್ತೀರಾ, ನಿಮಗೆ ಬಿಲ್ಡಿಂಗ್ ಕಾಣಿಸ್ತದೆ, ನನಗೆ ಅಲ್ಲಿ ಜಲ್ಲಿ ಕಾಣಿಸ್ತದೆ, ಮರಳು ಕಾಣಿಸ್ತದೆ, ಸ್ಟೀಲ್ ಕಾಣಿಸ್ತದೆ, ಫ್ಯಾಬ್ರಿಕೇಶನ್ ಕಾಣಿಸ್ತದೆ, ಲ್ಯಾಂಡ್ ಯೂಸ್ ಪ್ಯಾಟರ್ನ್ ಚೇಂಜ್ ಆಗಿರೋದು ಕಾಣಿಸ್ತದೆ, ನಿಮ್ಮ ಚೇರ್ ಟೇಬಲ್ ಕಾಣಿಸ್ತದೆ, ಫ್ಯಾನ್ ಕಾಣಿಸ್ತದೆ, ಕಂಪ್ಯೂಟರ್ ಕಾಣಿಸ್ತದೆ. ದ ಎಂಟೈರ್ ಇನ್ಫ್ರಾಸ್ಟ್ರಕ್ಚರ್ ಸ್ಟಾರ್ಟ್ಸ್ ಫ್ರಮ್ ದ ಲ್ಯಾಂಡ್ ಕನ್ವರ್ಷನ್. ಅಗ್ರಿಕಲ್ಚರ್ ಆಕ್ಟಿವಿಟಿ ಇದನ್ನ ಬಿಲ್ಡಿಂಗ್ ಆಕ್ಟಿವಿಟಿ ಮಾಡ್ತಾ ಇರೋದನ್ನ ನನ್ನ ಕಣ್ಣಿಗೆ ಕಾಣಿಸ್ತದೆ. Into thousands of banks and bank outlets, which we are dealing in our system. Now you can imagine the influence of this banking system. ಏನು ನಡೀತಾ ಇದೆ ಅಲ್ಲಿ? ನಿಮಗೆ ಒಂದು ವಿಡ್ರಾವಲ್ ಫಾರ್ಮ್ ಬೇಕು, ಇಲ್ಲ ಡೆಪಾಸಿಟ್ ಫಾರ್ಮ್ ಬೇಕು, ಅದಷ್ಟೇ ಬೇಕು. ಕರೆನ್ಸಿ ಲೆಸ್ ಕಂಟ್ರಿ ಅಂತ 25 ವರ್ಷಗಳಿಂದ ಹೇಳಿದೆ. ನಿಮ್ಮ ಸಮಾಜ ನಡೆಸಲಿಕ್ಕೆ ಪ್ರಿಂಟೆಡ್ ಕರೆನ್ಸಿ ಅವಶ್ಯಕತೆ ಇಲ್ಲ ಅಂತ ಹೇಳಿದೆ. ಬರೀ ಬಾಯಲ್ಲಿ ರೈಟಿಂಗ್ ಅಲ್ಲಿ ಇದೆ, ಗೊತ್ತಾಯ್ತಲ್ವಾ? There is no need to have the printed currency at all to run the. Now it is happening. ನಿಮ್ಗೆ ಗೊತ್ತಲ್ಲ, ನಿಮ್ಮ ಪೆಟ್ರೋಲ್ ಉಳಿಸ್ತಾ ಇದೆ, ಡೀಸೆಲ್ ಉಳಿಸ್ತಾ ಇದೆ, ಅಥವಾ ನಿಮ್ಮ ಎನರ್ಜಿ ಉಳಿಸ್ತಾ ಇದೆ, ಅಥವಾ ನಿಮ್ಮ ಸರ್ವಿಸ್ ಅವರ್ಸ್ ಉಳಿಸ್ತಾ ಇದೆ. ನೀವು ಬಂದು ಆಫೀಸಲ್ಲಿ ಬಂದ್ರೆ, ಯಾವ್ದು ಸರ್ಕಾರಿ ಆಫೀಸಲ್ಲಿ ಬಂದ್ರೆ, ಅವನಿಲ್ಲ ಸರ್ ಬ್ಯಾಂಕ್ ಹೋಗಿದ್ದಾರೆ, ಮೇಡಮ್ ಅವರೆಲ್ಲ ಸರ್ ಬ್ಯಾಂಕ್ ಹೋಗಿದ್ದಾರೆ, ಆಫೀಸಿಗೆ ಬಂದ್ರೆ ಅವನೆಲ್ಲ ಬ್ಯಾಂಕ್ ಹೋಗಿದ್ದಾನೆ. ಯಾಕೆ? ಟು ಡ್ರಾ ದ ಮನಿ ಆರ್ ಟು ಡೆಪಾಸಿಟ್ ದ ಮನಿ. ಬಟ್ ಇಷ್ಟು ದೊಡ್ಡ ಇನ್ಫ್ಲೂಯೆನ್ಸ್, ಪೆಟ್ರೋಲ್ ಕನ್ಸಂಪ್ಷನ್ ಕಡಿಮೆ ಮಾಡೋದು, ಡೀಸೆಲ್ ಕನ್ಸಂಪ್ಷನ್ ಕಡಿಮೆ ಮಾಡೋದು, ಟ್ರಾಫಿಕ್ ಡೆನ್ಸಿಟಿ ಕಡಿಮೆ ಮಾಡೋದು ಯಾರು? ದೇವರ. ನಿಮ್ಮ ಪ್ಲಾಸ್ಟಿಕ್ ಕಾರ್ಡ್, ATM ಕಾರ್ಡ್ ನಿನ್ನನ್ನು ಬೀದಿ ಬದಲು ಮಾಡಿದೆ, ನಿನ್ನ ಜೀವ ಉಳಿಸಿದೆ. ಡೀಸೆಲ್ ಕನ್ಸಂಪ್ಷನ್ ಕಡಿಮೆ ಮಾಡಿದೆ, ಪೆಟ್ರೋಲ್ ಕನ್ಸಂಪ್ಷನ್ ಕಡಿಮೆ ಮಾಡಿದೆ, ಆಕ್ಸಿಡೆಂಟ್ಸ್ ಕಡಿಮೆ ಮಾಡಿದೆ, ಟ್ರಾಫಿಕ್ ಡೆನ್ಸಿಟಿ ಕಡಿಮೆ ಮಾಡಿದೆ. ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ಗೆಟಿಂಗ್ ಇನ್ಫ್ಲುಯೆನ್ಸ್ಡ್ ಬೈ ದ ಸಿಂಗಲ್ ಕಾರ್ಡ್, ATM ಕಾರ್ಡ್. ನೀವು ಹೋಗ್ತಾ ಇದ್ದೀರಾ ಅಲ್ಲಿಗೆ? ಇಲ್ಲ ತಾನೆ? ಈಗ ಅದಕ್ಕೂ ಮುಂಚೆ this is not the thought which we are dealing with now. 25 years back ಇದು ಹೇಳಿದೆ ಕರೆನ್ಸಿ ಲೆಸ್ ಕಂಟ್ರಿ. ಮತ್ತೆ ಅಡಿಗೆ ಮನೆಗೆ ಬರೋಣ. ಈ ಮೆಟಲ್ ಕ್ಯಾಬಿನ್ಗೂ ನಿಮ್ಮ ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ಎಷ್ಟು ದೊಡ್ಡ ಸಂಬಂಧ ಇದೆ. ಆಗ ನಾನು ಹೇಳಿದ್ದೇನು, ಕೊಡುತ್ತಾಗೆ ಕೊಡುವರಲ್ಲ ಕುಡುಕನಲ್ಲದ ಗಂಡನ. ಆ ಟೈಟಲ್ ಚೇಂಜ್ ಮಾಡಿದ್ದಾನೆ ಲಕ್ಷ್ಮೀಕಾಂತ. ಕೊಡುತ್ತಾಯ ಕೊಡುವರವ ಅಡುಗೆ ಮನೆ ಇಲ್ಲದ ಗಂಡನ. ಅರ್ಥ ಆಯ್ತಾ ನಿಮಗೆ? ಅಡುಗೆ ಮನೆ ಯಾಕೆ ಬೇಕು ಅಂತ ನಾನು ಹೇಳಿದ್ರೆ ನನ್ನ ಮೇಲೆ ಜೋರು ಮಾಡುವ ಜನ ಇದ್ದಾರೆ. ಖಂಡಿತ ನಿಮ್ಗೆ ಅಡುಗೆ ಮನೆ ಬೇಡ. ಯೂನಿವರ್ಸಿಟಿ ಹೇಗೆ ನಡೀತಾ ಇದೆ, ಮಲ್ಲೇಶ್ವರಂ ಒಂದು ಹೋಟೆಲ್ ಮಾಡೋಣ ಅಥವಾ ಮೆಸ್ ಮಾಡೋಣ ಅಥವಾ ಏನೋ ಒಂದು ನಿಮ್ಮ ಫುಡ್ ಸೆಂಟರ್ ಮಾಡೋಣ, ಅದರಿಂದ ಎಲ್ಲರಿಗೂ ಸಪ್ಲೈ ಆಗಬೇಕು ಅಥವಾ ಎಲ್ಲರೂ ಎಲ್ಲ ಊಟ ಮಾಡಬೇಕು. Then the solid waste management is proper, liquid waste management is very proper, and hygiene that is going to be managed or maintained is proper. When the people in our ancient ages, they have proved that we can even have community bathing system. ಗೊತ್ತಲ್ವಾ ಆರ್ಕಿಮೆಡಿಸ್ ಎಲ್ಲಿ ಸ್ನಾನ ಮಾಡ್ತಾ ಇದ್ದ ಅಂತ? ಅವನಿಗೆ ಕಿರೀಟದಲ್ಲಿ ಡಿಫರೆನ್ಸ್ ಅಂದ್ರೆ ಬಂಗಾರ ಮತ್ತು ತಾಮ್ರ ಎಷ್ಟಿದೆ ಕಿರೀಟದಲ್ಲಿ ಕಂಡಿಡಿ ಅಂತ ಹೇಳಿದಾಗ ಈ ಆಚಾರ್ಯನಲ್ಲ ಎಷ್ಟು ಮಿಕ್ಸ್ ಮಾಡಿದ್ರೆ ನೋಡ್ಬೇಕು ಅನ್ನೋದು ನನಗೆ ಗೊತ್ತಾಗ್ಬೇಕು ಅಂತ ರಾಜ ಹೇಳಿದಾಗ ಅವನೇನು ಲ್ಯಾಬ್ರೇಟರಿಗೆ ಹೋಗಿದ್ದ ಕಿರೀಟ ಇಟ್ಕೊಂಡು ಚೆಕ್ ಮಾಡ್ಲಿಕ್ಕೆ. ತಾನು ಬಾತಿಂಗ್ ಟಬ್ಬಲ್ ಇಳಿದಿದ್ದ ಅಷ್ಟೇ, ತೊಟ್ಟಿಯಲ್ಲಿ ಇಳಿದಿದ್ದ ಅಷ್ಟೇನೆ. ಅವನು ತೊಟ್ಟಿಯಲ್ಲಿ ಇಳಿದ್ರೆ ಕಿರೀಟಕ್ಕೂ ಇದಕ್ಕೆ ಎಂತ ಸಂಬಂಧ? ಡೆನ್ಸಿಟಿ ಬಗ್ಗೆ ಅರ್ಥ ಆಗಿದ್ದೆ ಅವಾಗ. ಮೆಟಲ್ ಅಂಡ್ ಮೆಟೀರಿಯಲ್ ಡೆನ್ಸಿಟಿ ಅಂದ್ರೆ ಏನು ಅಂತ ಅರ್ಥ ಆಗಿದ್ದು, ಅದರೊಳಗೆ ಕಾಪರ್ ಇದ್ರೆ ಎಷ್ಟಿದೆ ಫ್ರಾಕ್ಷನ್ ಅಂತ ವಿತೌಟ್ ಈವನ್ ಮೆಲ್ಟಿಂಗ್ ದಟ್ ground, yes, made a theory to say that to prove that it is possible to assess the amount of metal which is there. In ದೇಹ in ಗಾತ್ರ ದೊಡ್ಡ ವಿಷಯ. ಈ ಮೆಟಲ್ ಕ್ಯಾಬಿನ್ ನ ಬಗ್ಗೆ ಹೇಳಿದಾಗ ನೀವು ಮಲ್ಟಿಪ್ಲೈ ಅನ್ನೋದನ್ನ ಹೇಳಿದಾಗ ಇಡೀ ಪ್ರಪಂಚದಲ್ಲಿ ಎಷ್ಟು ಮೆಟಲ್ ಉಳಿಸಬಹುದು ಅನ್ನೋದನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಹೇಳಿದ್ರೆ ಬರೀ ಒಂದು ಟನ್ ಒಂದು ಫ್ಯಾಮಿಲಿಗೆ ಲೆಕ್ಕ ಹಾಕಿದ್ರೆ ನಾವು 700 ಈಗ 800 ಮಿಲಿಯನ್ ಪಾಪ್ಯುಲೇಷನ್ಸ್ ಇದೆ. ಗೊತ್ತಲ್ವಾ? 800 ಕೋಟಿ ಅಲ್ವಾ? 800 ಕೋಟಿ ಪಾಪ್ಯುಲೇಷನ್ ಭೂಮಿ ಮೇಲೆ ಇದ್ದಾರೆ. ಡಿವೈಡೆಡ್ ಬೈ 4 ಮೆಂಬರ್ಸ್ ಪರ್ ಫ್ಯಾಮಿಲಿ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಒಂದು ಕಿಚನ್ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಅಷ್ಟು ಮಿಲಿಯನ್ ಟನ್ಸ್ ಆಫ್ ಮೆಟಲ್ ಇಸ್ ಕನ್ಸ್ಯೂಮ್ ಜಸ್ಟ್ ಟು ಫುಡ್. ನಮ್ಮ ಸಂಪ್ರದಾಯ ಹೇಗಿದೆ, ನಮ್ಮ ಅದು ಹಾಗಿದೆ, ಅದನ್ನೆಲ್ಲ ನೀವು ಹಾಳು ಮಾಡಬೇಡಿ. ಕಮ್ಯುನಿಟಿ ಕಿಚನ್ ಕಾನ್ಸೆಪ್ಟ್ ನಿಂದ ಈ ತರ ತೊಂದರೆಗಳಾಗ್ತದೆ. Now, what I am expressing before you is, you are all technocrats for me, and I am expressing the possibilities of considering a kind of changes that we can think of globally to address the issues with respect to environment. I'll tell you why and how. ಒಂದು 40 ವರ್ಷಗಳ ಹಿಂದೆ ನಾವು ಟೆಲಿಫೋನ್ ಮಾಡ್ತಾ ಇರಬೇಕು ಅಂದ್ರೆ ಹೇಗಿತ್ತು? ಅಲ್ಲಿ ಒಂದೇ ಪ್ರಿನ್ಸಿಪಲ್ ಚೇಂಬರ್ ಅಲ್ಲಿ ಒಂದು ಡಬ್ಬ ಇರ್ತಾ ಇತ್ತು, ಮೂಲೆಯಲ್ಲಿ ಅಲ್ಲಿ ಮಾತ್ರ. ಆ ಡಬ್ಬಕ್ಕೆ ಹಿಂಗೆ ರಿಸೀವರ್ಗೆ ಕನೆಕ್ಷನ್ ಇರ್ತಾ ಇತ್ತು. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ವೈರು, ಅಲ್ಲಿಂದ ಗೋಡೆಗೆ ವೈರು, ಗೋಡೆಯಿಂದ ಹೊರಗಡೆ ಟೆಲಿಫೋನ್ ಕಂಬಕ್ಕೆ ವೈರು, ಕಂಬದಿಂದ ಬೆಂಗಳೂರಿಗೆ ವೈರು, ಬೆಂಗಳೂರಿಂದ ಮೆಡ್ರಾಸ್ಗೆ ವೈರು, ಮೆಡ್ರಾಸಿಂದ ನೀವು ಡೆಲ್ಲಿ ಹೇಳ್ತೀರಾ, ಇಲ್ಲಿ ಹೇಳ್ತೀರಿ, ಎಲ್ಲಾ ಕಡೆ ವೈರ್ ಇತ್ತು ತಾನೇ. ನಾನು ಇಲ್ಲಿ ಮಾತಾಡ್ಬೇಕಂದ್ರೆ ಮೊದಲು ಕಾಲ್ ಬುಕ್ ಮಾಡ್ಬೇಕಿತ್ತು, ಫೋನ್ ಮಾಡಿ ಅವ್ನು ಮಧ್ಯಾಹ್ನ 2 ಗಂಟೆ ಕನೆಕ್ಷನ್ ಕೊಡ್ತಾ ಇದ್ದ. ಆಗ ಬಂದು ನೀವು ಹಲೋ ಅನ್ಬೇಕು, ಮೆಡ್ರಾಸ್ ಕೇಳ್ಬೇಕಂದ್ರೆ. This cable-free power system, cable-free communication system, how it is, replace the entire material requirement globally. ಆಗ ಅಷ್ಟು ದೊಡ್ಡ ಒಂದು ಕೇಬಲ್ ನೆಟ್ವರ್ಕ್ ಇದ್ದಂತ ವ್ಯವಸ್ಥೆಯನ್ನ 40 ವರ್ಷಗಳ ನಂತರದ ಜನಾಂಗ ಅಂದ್ರೆ ನೀವು ಈಗ ಯಾವುದೋ ಒಂದು ಚಿಕ್ಕ ಡಬ್ಬ ಇಟ್ಕೊಂಡು ಹೀಗೆ ಪ್ರೆಸ್ ಮಾಡಿದ್ರೆ ಆ ವೆಂಕಟೇಶ ಎಲ್ಲಿದೆ ಅಂತ ಕೇಳಿದ್ರೆ ಅವನು ಇಲ್ಲಿ ನನ್ನ ವಾಶ್ರೂಮ್ ಅಲ್ಲಿ ಬರ್ತೀನಿ ಅಂತ ಹೇಳಿ ಬಚ್ಚಲ್ ಮನೆಯಲ್ಲಿ ಐಡೆಂಟಿಫೈ ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಯಾಟಲೈಟ್ ಸಹಾಯ ತಗೊಂಡು ಎಲ್ಲಿದೆ ಅಂತ ಟ್ರೇಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. ದಟ್ ಈಸ್ ಪಾಸಿಬಲ್ ಅಂಡ್ ಇಟ್ ಇಸ್ ಆಲ್ರೆಡಿ ಪ್ರೂವ್ಡ್. And what it is proved, there is no need to have the metal connectivity at all. ಸರಿ ತಾನೆ? ಹಾಗಿರುವಾಗ ಆ ತರದ್ದು ನೀವು ಯೋಚನೆ ಮಾಡಿ ನೀವು ಒಪ್ಕೊಳ್ಬೇಕಾಗಿರುವಾಗ ಇದನ್ನ ಯಾಕೆ ಒಪ್ಕೊಳ್ಳೋದಕ್ಕೆ ಹಿಂಜರಿತಾ ಇದ್ದೀರಾ ನೀವು? ಸರಿ ತಾನೆ? ಯಾಕೆ ಒಪ್ಕೊಳ್ಳೋದಕ್ಕೆ ಹಿಂಜರಿತಾ ಇದ್ದೀರಾ? ನಿಮ್ಮಲ್ಲಿ ಏನೋ ಬೇರೆ ವಿಷಯಗಳು ಬರ್ತಾ ಇದೆ. ದಟ್ ಇಸ್ ಸಮಥಿಂಗ್ ವಿಚ್ ಇಸ್ ವರ್ಚುವಲ್ ಅಗೇನ್. ಭ್ರಮಾತೀತವಾದ ವಿಚಾರಗಳು ಅಂದ್ರೆ ವಿಚ್ ಇಸ್ ನಾಟ್ ಪಾಸಿಬಲ್ ಟು ಟೇಕ್ ಇಟ್ ಯುವರ್ ಕಸ್ಟಡಿ. ದಿಸ್ ಆರ್ ಆಲ್ ಕಾಲ್ಡ್ ಭ್ರಮಾತೀತವಾದ ವಿಚಾರ. ಹಾಗೆ ನೋಡಿ, ಇವನ್ ಇನ್ನೊಂದು ಸಬ್ಜೆಕ್ಟ್ ಹೇಳ್ತಾ ಇದೆ, ಕೇಬಲ್ ಫ್ರೀ ಪವರ್ ಟ್ರಾನ್ಸ್ಮಿಷನ್. ಐ ಸೆಡ್ ಕರೆನ್ಸಿ ಲೆಸ್ ಕಂಟ್ರಿ, ಹಣ ಪ್ರಿಂಟೆಡ್ ಹಣ ಇಲ್ಲದಲ್ಲೇ ದೇಶ ನಡೆಸಬಹುದು ಅನ್ನೋದನ್ನ ಹೇಳಿದೆ. ಕೇಬಲ್ ಫ್ರೀ ಪವರ್ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಬಗ್ಗೆ ಮಾತಾಡಿದೆ. ಅದೇ ಕಾರಣ ಮೆಟಲ್ ಕ್ಯಾಬಿನ್ ಬಗ್ಗೆ, ಬ್ಯಾಂಕಿಂಗ್ ಬಗ್ಗೆ ಹೇಳಿದೆ. ಕೇಬಲ್ ಫ್ರೀ ಪವರ್ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಅಂದ್ರೆ ನಮ್ಮ ಮನೆಯಲ್ಲಿ ಈಗ ನೋಡ್ಕೊಳ್ಳಿ, ನಾನು ಟೆಲಿಫೋನ್ ಬಗ್ಗೆ ಹೇಳಿದೆ, ಕೋಣೆಗೆ ಹೋಗಿ ಈ ಲೈಟ್ ಆನ್ ಆಗುತ್ತೆ, ನಾನು ಸ್ವಿಚ್ ಇರ್ತದೆ, ಸ್ವಿಚ್ ಆನ್ ಮಾಡ್ಬೇಕು. ಸರಿ ತಾನೆ? ಅಲ್ಲಿಂದ ಬಲ್ಬ್ಗೆ ಕನೆಕ್ಷನ್ ಇದೆ, ವೈರ್ ಇದೆ. ಇಲ್ಲಿಂದ ಹೊರಗಡೆ ಕರೆಂಟ್ ಕಂಬಕ್ಕೆ ವೈರ್ ಇದೆ, ಕರೆಂಟ್ ಕಂಬದಿಂದ power generation point here, high tension wire, low tension wire, everything wire is there, and cable is helping us to receive the power of electricity. Is it possible to think of something wherein there is no cable at all to transfer the power energy? ಏನೋ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ ಜನರೇಟ್ ಆಗ್ತಾ ಇದೆ, ಪವರ್ ಜನರೇಟ್ ಆಗ್ತಾ ಇದೆ, ಹೈಡ್ರೋ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಆಗಿರ್ಬೋದು, ನ್ಯೂಕ್ಲಿಯರ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಆಗಿರ್ಬೋದು, ಥರ್ಮಲ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಆಗಿರ್ಬೋದು. Is it possible to have a grid, or is it possible to have a network wherein there is no cable is used to transfer the power from the point of generation to the consumer? Is it possible? ಅಲ್ಲ ನೀವು ಈಗ ಫೋನ್ ಮಾಡಿ ನನಗೆ ಒಂದು 250 ರೂಪಾಯಿ ಕರೆಂಟ್ ಕಳಿಸ್ಬಾರ ನಮ್ಮ ಮನೆಗೆ ನನಗೆ ಅಂದ್ರೆ ನೀವು ಕಳಿಸ್ಬೇಕು 250 ರೂಪಾಯಿ ಕರೆಂಟ್ ಕಳಿಸ್ಲಿಕ್ಕೆ ಸಾಧ್ಯನಾ ವಿತೌಟ್ ಹ್ಯಾವಿಂಗ್ ಎನಿ ಪವರ್ ಕೇಬಲ್ಸ್ ಅರೌಂಡ್ ಯು? ಅಲ್ಲಿ ಕರೆಂಟ್ ಕಂಬಗಳು ಎಲ್ಲ ಇದೆಯಲ್ಲ ಅದಿಲ್ಲದೆ ಸಾಧ್ಯನಾ? ಇದು ಸುಮಾರು ಒಂದು 10-15 ವರ್ಷದ ಹಿಂದೆ ಬೆಂಗಳೂರು ವೆಸ್ಟ್ ಅಲ್ಲಿ ಕಾಲೇಜಲ್ಲಿ ಮಾತಾಡ್ತಿರೋ ಹೇಳಿದೆ. ಈಸ್ಟ್ ವೆಸ್ಟ್ ಇಂಜಿನಿಯರಿಂಗ್ ಕಾಲೇಜ್ ಅಲ್ಲಿ ಇದೆ ಬೆಂಗಳೂರು ವೆಸ್ಟ್ ಮಾಂಗಿಗೂಡಲ್ಲಿ. ಅಲ್ಲಿ ಹೇಳ್ತಾ ಇದ್ದು ಈ ವಿಷಯ ಈಗ ನಿಮ್ಮ ಮುಂದೆ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ಕೇಬಲ್ ಫ್ರೀ ಪವರ್ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಅಂದ್ರೆ ಏನು, ಅಂಡ್ ಈಸ್ ಇಟ್ ಪಾಸಿಬಲ್ ಅಂಡ್ ಕ್ಯಾನ್ ವಿ ರಿವೈಸ್ ದಟ್ ಕೈಂಡ್ ಆಫ್ ಸಿಸ್ಟಮ್ ಅಂತ. ಇದೆಲ್ಲದಕ್ಕೂ ಎನರ್ಜಿಗೂ ಸಂಬಂಧ ಇದೆ, ಅರ್ಥ ಆಯ್ತಾ? ಕೇಬಲ್ ಫ್ರೀ ಪವರ್ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಅಂದ್ರೆ ವಿತೌಟ್ ಹ್ಯಾವಿಂಗ್ ಎನಿ ಕೈಂಡ್ ಆಫ್ ಕೇಬಲ್ ಕಮ್ಯುನಿಕೇಶನ್, ಕೇಬಲ್ ಸಿಸ್ಟಮ್, ಕೇಬಲ್ ನೆಟ್ವರ್ಕ್, ಕೇಬಲ್ ಗ್ರಿಡ್, can we have the power supply to the consumer? ನಾನು ಹೇಳ್ತಾರೆ ಪ್ಲಸ್ 1 ಕೊಡ್ಬೇಕು. ಇಸ್ ಇಟ್ ಪಾಸಿಬಲ್? ನಗ್ತಾರೆ, ನಗಲಿ. ಅದು ನನ್ನ ಮುಂದೆ ಕೂತಿರೋರೆಲ್ಲ ಹೈ ವೋಲ್ಟೇಜ್ ಇಂಜಿನಿಯರಿಂಗ್ ಅವರು, ಎಲೆಕ್ಟ್ರಿಕಲ್ ಇಂಜಿನಿಯರಿಂಗ್ ಅವರು, ಪದ್ಧತಿ ಇದ್ದವರು, ಅವರೆಲ್ಲ ಅದು ಹೇಗೆ ಸರ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. Just think of for any kind of a problem, nature seeks the solution. ನಿಜವಾಗ್ಲು ನಾನು ಅವ್ರಿಗೆ ಹೇಳಿದೆ, ನೋಡಿ ನೀವು ಪ್ರತಿ ವರ್ಷ ಮಳೆಗಾಲ ಎದುರು ನೋಡ್ತೀರಾ, ಸರಿ ತಾನೆ? ಮಳೆಗಾಲ ಬರ್ತದೆ, ಮಳೆಗಾಲದಲ್ಲಿ ಮಳೆ ಬರೋದಕ್ಕೂ ಮುಂಚೆ ಏನ್ ಬರ್ತದೆ, ಸ್ವಲ್ಪ ಧೂಳು ಬರ್ತದೆ, ಅದಾದ ನಂತರ ಏನ್ ಬರ್ತದೆ, ಸಿಡ್ಲು ಹೊಡೆಯೋ ಚಾನ್ಸಸ್ ಇರ್ತದೆ ಮಳೆ ಹೊಡೆಯೋದಲ್ಲಿ ಅಲ್ವಾ? ಬಿಗಿನಿಂಗ್ ಅಲ್ಲಿ ತುಂಬಾ ಸಿಡ್ಲು ಹೊಡಿತಾ, ಸಿಡ್ಲು ಹೊಡೆಯೋದು ಗೊತ್ತಾ, ಲೈಟ್ನಿಂಗ್. ಈ ಸಿಡ್ಲು ಹೊಡೆಯೋದು ಅಂದ್ರೆ ಏನು? ಎಲ್ಲೋ ಆಕಾಶದಲ್ಲಿ ಕಿಲೋಮೀಟರ್ಗಳ ಮೇಲೆ ಇರುವಂತ ಮೋಡ್ಗಳಲ್ಲಿ ಇರುವಂತ ಚಾರ್ಜಸ್, ಎಲೆಕ್ಟ್ರಿಕಲ್ ಚಾರ್ಜಸ್, ಅದು ಫಾರ್ ಸಮ್ ರೀಸನ್, ಫಾರ್ ಸಮ್ ಕೈಂಡ್ ಆಫ್ ಆಕ್ಟಿವಿಟಿ, ಫಾರ್ ಸಮ್ ಕೈಂಡ್ ಆಫ್ ಟೆಕ್ನಿಕಲ್ ರೀಸನ್ ಅದು ಕೊಲೈಡ್ ಆದ್ಮೇಲೆ ಬರುವಂತ ಘರ್ಷಣೆಯಿಂದ ಬರುವಂತ ಅಥವಾ ಡೆಲಿವರಿ, ದ ಪ್ರಾಡಕ್ಟ್ ವಿಚ್ ಇಸ್ ಡೆಲಿವರ್ಡ್ ಔಟ್ ಆಫ್ ದಟ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಎನರ್ಜಿ, ಸ್ಪೆಷಲಿ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ ಆರ್ ಚಾರ್ಜಸ್, ಭೂಮಿ ಕಡೆ ಬರ್ತಾ ಇದೆ, ಸರಿ ತಾನೆ? ಭೂಮಿ ಕಡೆ ಬರ್ತಾ ಇದೆ, ಸಿಡ್ಲು ಹೊಡಿತಾ ಇದೆ. ಈ ಬಿಜಾಪುರದಲ್ಲಿ ಎಲ್ಲೋ ಒಂದು MS ಹತ್ತೋಯ್ತಂತೆ, ರಾಮನ MS ಹತ್ತೋಯ್ತಂತೆ, ಸಿಡ್ಲು ಹೊಡಿತಂತೆ. ಇವ್ರ ಮನೆ ಮುಂದೆ ತೆಂಗಿನ ಮರ ಐತಲ್ಲ, ತೆಂಗಿನ ಮರಕ್ಕೆ ಸಿಡ್ಲು ಹೊಡಿತಂತೆ, ತೆಂಗಿನ ಮರ ಬೆಂಕಿ ಹತ್ಕೊಡ್ತಂತೆ ಅಂತ ನ್ಯೂಸ್ ಪೇಪರ್ ಅಲ್ಲಿ, ಅಂತ ಟಿವಿಯಲ್ಲಿ ನೋಡಿರ್ತೀರಾ. ಇಡೀ ಮಂಗಳೂರಿಗೆ ಸಿಡ್ಲು ಹೊಡಿತಂತೆ, ಇಡೀ ಬಿಜಾಪುರಕ್ಕೆ ಸಿಡ್ಲು ಹೊಡಿತಂತೆ ಅಂತ ಎಲ್ಲಾದ್ರೂ ಕೇಳಿದ್ರ? ಇಲ್ಲ ತಾನೆ? ಒಂದು MS ಹತ್ತೋಯ್ತು, ಒಬ್ಬ ಯಾರೋ ಜಮೀನಲ್ಲಿ ಇದ್ದವನು ಎಲ್ಲ ಇದ್ದವನು ಒಬ್ಬ ಸತ್ತೋದ ಹಿಂಗೆ ಅಂತ ಹೇಳ್ತೇವೆ, ಸರಿ ತಾನೆ? ಮೀನ್ಸ್ ವಾಟ್ ಇಟ್ ಸೇಸ್, the power packed energy which is there in the form of clouds there above the surface of the earth is getting delivered to the surface of the earth without having any cable. It is delivering to the surface of the earth, and that too in a very targeted fashion. ಹೋಗಿ ರಾಮಣ್ಣ ಇವಾಗ ಸಿಟ್ಟು ಹೊಡೆದ್ರೆ ಅವನಿಗೆ ಹೊಡಿತದೆ, ಪಕ್ಕದಲ್ಲಿ ಭೀಮಣ್ಣನಿಗೆ ಹೊಡೆಯೋದಿಲ್ಲ. ಹೇಗೆ ಬರ್ತಾ ಇದೆ? How it is delivering, and in such a targeted fashion. When that is possible to transfer the power from the source A to the consumer A without having intermediate cable, can you not think of something like that? ನಾನು ನೀವು ನನಗೆ ಚಾನ್ಸ್ ಕೊಡಿ, ಚಂದ್ರನ ಮೇಲೆ ಒಂದು ಪವರ್ ಸ್ಟೇಷನ್ ಎಸ್ಟಾಬ್ಲಿಷ್ ಮಾಡ್ತೇನೆ, ಅಲ್ಲಿಂದ ನಿಮಗೆ ಕರ್ನಾಟಕಕ್ಕೆ ಇಷ್ಟು ಪವರು, ದುಬೈಗೆ ಇಷ್ಟು ಪವರ್ ಅಂತ ಅಲ್ಲಿಂದನೇ ಸಪ್ಲೈ ಮಾಡ್ತೇನೆ. ನೀವು ಯಾಕಂದ್ರೆ ಬಿಡುದಿಲ್ಲಲ್ಲ, ಹಾಸನದಲ್ಲಿ ಮಾಡ್ಲಿಕ್ಕೆ ಬಿಡುದಿಲ್ಲ, ಮಂಗಳೂರು ಮಾಡ್ಲಿಕ್ಕೆ ಬಿಡುದಿಲ್ಲ, ಸಮುದ್ರದಲ್ಲಿ ಹೋಗಿ ನಾನು ಮಾಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ ಪವರ್ ಸ್ಟೇಷನ್. Give me a chance, I'll get into it. I'll produce the power. It looks funny for you, but it's good for that. Why we should not think of? ಯಾಕೆ ಪವರ್ ಫ್ರೀ ಅಂದ್ರೆ ಕೇಬಲ್ ಫ್ರೀ ಪವರ್ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಬೇಕು? ಯಾಕೆ ಸಿಂಗಲ್ ಬ್ಯಾಂಕಿಂಗ್ ಸಿಸ್ಟಮ್ ಬೇಕು? ಯಾಕೆ ಅಡುಗೆ ಮನೆ ಇಲ್ಲದ ಗಂಡನ ವ್ಯವಸ್ಥೆ ಬೇಕು? ಅದಕ್ಕೂ ಎನರ್ಜಿಗೆ ಏನು ಸಂಬಂಧ ಇದೆ? ನೀವು ಈಗ 700 ಕೋಟಿ 800 ಕೋಟಿ ಆಗಿದ್ದೀರಾ, ಇನ್ನು 1000 ಕೋಟಿಗೆ ಹತ್ರ ಆಗ್ತೀರಾ, ನಿಮ್ಗೆ ಬೆಂಗಳೂರು ಕಾಂಪಿಟೇಷನ್ ಎಲ್ಲಿಂದ ತರಬೇಕು? ಹಿಂಗೆ ನಾನು ಮಂಗಳೂರು ಉಡುಪಿ ಮಧ್ಯದಲ್ಲಿರುವಂತ ಎಲ್ಲಾ ನೆಲನು ಬಿಲ್ಡಿಂಗ್ ಕಟ್ಕೊಂಡು ಕೂತ್ಕೊಂಡ್ರೆ ನಿಮಗೆ ತಿನ್ಲಿಕ್ಕೆ ಮಣ್ಣು ಸಹ ಇರಲ್ಲ, ಗೊತ್ತಾಯ್ತಲ್ವಾ? ಏನಂತ ಮಣ್ಣಿಲ್ಲ ಅಂದ್ರೆ ಅರ್ಥ ಇರೋದು ಏನಿಲ್ಲ ಅಂತ. ನ್ಯೂಟ್ರಿಷನ್ ಚಾಕ್ಲೇಟ್ ತಿಂತೀರಾ ನೀವು? ಸಾಧ್ಯ ಅಲ್ವಾ? ಇಲ್ಲ. Then what is to be preserved and what is to be considered? What is to be considered at global level to think of? ಅಲ್ವಾ? So single banking system ಆಗಲಿ, ಕೇಬಲ್ ಫ್ರೀ ಪವರ್ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಆಗಲಿ, ಕಿಚನ್ ಸಿಸ್ಟಮ್ ಆಗಲಿ, ಎಷ್ಟು ಇನ್ಫ್ಲುಯೆನ್ಸ್ ಇದೆ ಅನ್ನೋದನ್ನ ನೀವು ಗಮನಿಸ್ತಾ ಹೋಗಿ, ಅದ್ರ ಬಗ್ಗೆನೇ ಒಂದು ಬೋರ್ಡ್ ಆರ್ಟಿಕಲ್ ಬರೆದಿ, ಅದ್ರ ಬಗ್ಗೆನೇ ಒಂದು ಥೀಸಿಸ್ ಮಾಡಿ, ಅದ್ರ ಬಗ್ಗೆನೇ ಸಾಮಾಜಿಕ ಪರಿವರ್ತನೆಗಳು ಏನಾಗ್ತದೆ ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಯೋಚನೆ ಮಾಡಿ. ಈಗ ನಮ್ಮ ಸಾಹೇಬರು ನಾನು ಹೇಳ್ತಾ ಇದ್ದೆ, in the name of our social system, in the name of our social system changes that we are adopting, especially the food habits, ನಾನು ಪಿಜ್ಜಾ ಆಗ್ಲಿ ಅದು ಇದು ಏನೋ ತರಿಸ್ಕೊಳ್ತಾ ಇದ್ರಲ್ಲ, 10 ಗಂಟೆ ರಾತ್ರಿ 10 ಗಂಟೆ ಮೇಲೆ ಫೋನ್ ಮಾಡಿ ಊಟ ತರಿಸ್ಕೊಳ್ತಾ ಇದ್ರೆ ನಿಮ್ಗೆ ಎಂತ ಊಟ ಬರ್ತಾ ಇದೆ? ಅವ್ನು ಏನ್ ನೋಡ್ತಿದ್ಯೋ ಅದ್ರ ಮೇಲ್ಗಡೆ ಇರೋ ಲೇಬಲ್ ಬೇರೆ ಯಾವ ಒಂದು ದೊಡ್ಡ ಹೋಟೆಲ್ ಹೆಸರು ಹಾಕಿರ್ತಾನೆ, ಇದು ಬೀದಿ ಬದಿ ಊಟ ತಂದು ಕೊಟ್ಟಿರ್ಬೋದು ನಿಮ್ಗೆ, ಬಾಕ್ಸ್ ಆಗಿರ್ಬೋದು ನಿಮ್ಗೆ, ಸರಿ ತಾನೆ? ವ್ಯಾಪಾರ ದ್ರೋಹ ಚಿಂತನ, ನಿನಗೆ ಮೋಸ ಮಾಡೋದೇ ನನ್ನ ಕೆಲಸ, ಸರಿ ತಾನೆ? ಯಾಕೆ ಮಾಡ್ತಾ ಇಲ್ಲ? ಯಾಕೆ ಮಾಡ್ತಾ ಇದ್ದಾರೆ? ನೀವು ಅವ್ರು ಕೊಟ್ಟಿರೋ ಊಟ ಎಷ್ಟು ಹೈಜಿನಿಕ್ ಇದೆ ಅಂತ ನಿಮ್ಗೇನು ಗೊತ್ತು? ನೀವು ತಿಂದಿರೋದ್ರಿಂದ ನಿಮ್ಮ ಡೈಜೆಸ್ಟಿವ್ ಸಿಸ್ಟಮ್ ಎಷ್ಟು ಹಾಳಾಗ್ತಿದೆ ಅಂತ ನಿಮ್ಗೇನು ಗೊತ್ತು? ನೀವು ಎಷ್ಟು ತಿಂತಿರೋ, ಎಷ್ಟು ಹೋಗ್ತಾ ಇದೆಯೋ. ಅಂಡ್ this kind of practice, how much it is leading to the energy consumption to produce the so-called food for you, and so-called the packaging system for you, and the amount of waste material that is getting delivered back into the social system, ಅಥವಾ ನಮ್ಮಲ್ಲಿರುವಂತಹ ಸಾಲಿಡ್ ವೇಸ್ಟ್ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಸಿಸ್ಟಮ್ ಒಳಗೆ ಎಷ್ಟು ಬರ್ತಾ ಇದೆ ಗಮನಿಸಿದ್ದೀರಾ? ನೋಡಿ, ಚೇಂಜಸ್ ಬೇಕಾ ನಿಮಗೆ ಅಲ್ವಾ? ಇದು ಎಲ್ಲವನ್ನ ನೀವು ಗಮನಿಸಿದ್ರೆ ಸಮಾಜ ಮತ್ತು ಸಾಮಾಜಿಕ ವ್ಯವಸ್ಥೆಯಲ್ಲಿ ಎನರ್ಜಿ ರಿಕ್ವೈರ್ಮೆಂಟ್ ನ ಪಾತ್ರ ಏನು ಅನ್ನೋದು, ಅದಕ್ಕೆ ಮಹಿಳೆಯರ ಪಾತ್ರ ಏನು ಅನ್ನೋದು ಇವಾಗ ನಮ್ಮ ಸಾಹೇಬರು ಹೇಳ್ತಾರೆ. ಸರ್ ಸಂಜೆ ಆದ್ರೆ ಸರ್ ನಮ್ಮನೆಲ್ಲ ಕರ್ಕೊಂಡು ಪಿಜ್ಜಾ ತಿನ್ನೋದು, ಅಲ್ಲಿ ಬೀದಿಗೆ ಹೋಗೋದು. ಒಂದು 30-40 ವರ್ಷಗಳ ಹಿಂದೆ ಊರಿಗೆ 1-2 ಹೋಟ್ಲ್ ಇರಲಿಲ್ಲ, ಈಗ 100 ಹೋಟ್ಲ್ಗಳಿದೆ. ವಾಟ್ ಇಟ್ ಇಂಡಿಕೇಟ್ಸ್? ಚೆಕ್ ಮಾಡಿ ನೋಡಿ ಏನಾಗ್ತಾ ಇದೆ ಅಂತ. 1986 ಒಳಗೆ ಒಂದೇ ದೂರದರ್ಶನ ಚಾನಲ್ ಇದ್ದಿದ್ದು. ಸಂಜೆ ಅದು ನಮ್ಮ ಟಿವಿಯಲ್ಲಿ ಏನದು ಹಾಡುಗಳು ಬರ್ತಾ ಇದ್ದಲ್ಲ, ಯಾರನ್ನ ಹಾಡು when you are given with multiple options, the social system will collapse, and it's happening. The crime rate after 1986 and till date, and earlier to that, you just check. The number of divorces which are happening earlier to 1986 and after 1986. Act 1986 ಹೇಳ್ತಾ ಇದೆ ಅಂದ್ರೆ ಟೆಲಿವಿಷನ್ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಸಮಾಜಕ್ಕೆ ಆದ ದಿನಗಳ ನಂತರ ದಿನಗಳು ಹೇಗಿತ್ತು, ಅದಕ್ಕೆ ಮುಂಚೆ ಹೇಗಿದೆ, ಏನ್ ಡೆವಲಪ್ ಆಗ್ತಾ ಇದೆ, ಸಾಮಾಜಿಕ ವ್ಯವಸ್ಥೆಯಲ್ಲಿ ಎಷ್ಟು ಇನ್ಫ್ಲುಯೆನ್ಸ್ ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದನ್ನ ಅದು ಹೇಳ್ತದೆ. ಸ್ಟಾಟಿಸ್ಟಿಕಲ್ ಇನ್ಫಾರ್ಮೇಶನ್, you just check with it. Try to gather the information for last 30 years. ಅಲ್ವಾ? ಎರಡು ವಿಷಯ ಹೇಳಬೇಕಿತ್ತು, ಹೇಳಿದ್ದೇನೆ. ಸಮಯ ಕಡಿಮೆ ಇದೆ. ನೀವು ಹೇಳೋದು ಪ್ರಶ್ನೆಗಳು ಏನಂದ್ರೆ ದಯವಿಟ್ಟು ಕೇಳಿ, ಸ್ವಲ್ಪ ಸಮಯ ನಿಮ್ಮ ಜೊತೆ ಪ್ರಶ್ನೆಗಳು ಶೇರ್ ಮಾಡಿ. ಎನಿಥಿಂಗ್ ದಟ್ ಯು ಫೀಲ್ ಲೈಕ್ ಇದು ಹೀಗಾಗ್ಬೋದಾ, ಹಾಗಾಗ್ಬೋದಾ. ನಾನು ನಿಮಗೆ ಪೇಟೆಂಟ್ಸ್ ಬಗ್ಗೆ ಹೇಳ್ತಾ ಇದ್ದೆ, ಬರೀ ಹೈಲೈಟ್ ಮಾಡಿದ್ದೇನೆ ಅಷ್ಟೇ. ನಂಬರ್ ಆಫ್ ಪೇಟೆಂಟ್ಸ್ ಫೈಲ್ಡ್ ಬೈ ಇಂಡಿಯನ್ ಕಮ್ಯುನಿಟಿ is zero, almost zero, very close to x-axis. Why? Means the system needs a change. Social system needs a change. ಇಲ್ಲಾಂದ್ರೆ ನೀವು ಅಷ್ಟೇ ಅಲ್ವಾ? ಏನಾದರೂ ಪ್ರಶ್ನೆಗಳಿದೆಯಾ? ಇಲ್ಲ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. ಕೇಬಲ್ ಟ್ರಿಪ್ ಪವರ್ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಬಗ್ಗೆ ಯೋಚನೆ ಮಾಡಿ. ಎಲೆಕ್ಟ್ರಿಕಲ್ ಇಂಜಿನಿಯರ್ಸ್ ಇದೆ. ಇನ್ನು ಸಾಮಾಜಿಕ ಬದಲಾವಣೆಗೆ ಸೋಷಿಯಲ್ ಬ್ಯಾಕ್ಗ್ರೌಂಡ್ ಇದೆ, ಇಂಜಿನಿಯರಿಂಗ್ ಕಾಲೇಜ್ ಆಗಿರೋದ್ರಿಂದ ಸೋಷಿಯಲ್ ಬ್ಯಾಕ್ಗ್ರೌಂಡ್ ಇರೋದಿಲ್ಲ. ಆದ್ರೂ you can have multidisciplinary activity to think of something like this. And plastic ಬಗ್ಗೆ ದೊಡ್ಡ ಹೋಗ್ಬೇ ಇದೆ ಸಮಾಜದೊಳಗೆ. ಈಗ ಸೇ ನೋ ಟು ಪ್ಲಾಸ್ಟಿಕ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಕ್ಯಾನ್ ಯು ಡೂ ಲೈಕ್ ದಟ್? ಸೇ ನೋ ಟು ಪ್ಲಾಸ್ಟಿಕ್ ಅನ್ನೋದು ಸರಿನಾ? ಯೋಚನೆ ಮಾಡಿ. ಅದಲ್ವಾ? ಪ್ಲಾಸ್ಟಿಕ್ ಸಿ ಪರಿಸರವಳಿಸಿ ನನ್ನ is it right in saying no to plastic in general? ಯೋಚನೆ ಮಾಡಿ. ನೀವು ಗಮನಿಸಿ plastic and its contribution. I told you the amount of diesel consumption which is reduced, petrol consumption which is reduced, traffic density which is reduced. It's purely because of that plastic related. ಹೌದು, ನಿಮ್ಮನ್ನ ಜೀವ ಉಳಿಸಿದ್ದು ಸಹ ಪ್ಲಾಸ್ಟಿಕ್. ಈಗ ಇಂಥ ವಿಷಯ ಗೊತ್ತಾ? ನಿಮ್ಮ ಹಾರ್ಟ್ ವಾಲ್ಸ್ ಇದೆಯಲ್ಲ, ದೇ ಆರ್ ಮೇಡ್ ಔಟ್ ಆಫ್ ಪ್ಲಾಸ್ಟಿಕ್. ಹಾರ್ಟ್ ವಾಲ್ಸ್, ಬೋನ್ ಜಾಯಿಂಟ್ಸ್ ಇದೆಯಲ್ಲ, ಪ್ಲಾಸ್ಟಿಕ್. ಮತ್ತೆ ನಿಮ್ಗೆ ಇನ್ನೆಂತ ಬೇಕು? ಪ್ಲಾಸ್ಟಿಕ್ ಸರ್ಜರಿ ಮಾಡಿಸ್ಕೊಡ್ತಾರೆ ನಮ್ಮ ಹೆಣ್ಮಕ್ಳು. ಶ್ರೀದೇವಿ ಇದೆಯಲ್ಲ, ಒಂದು 3 ಸಾವಿರ ಪ್ಲಾಸ್ಟಿಕ್ ಸರ್ಜರಿ ಗೊತ್ತಲ್ವಾ? ತಮಾಷೆ ಅಲ್ಲ, ನಿಜ. ಹೇಗೆ ಸಾಧ್ಯ? ಇಂಥ ಒಂದು ಪ್ಲಾಸ್ಟಿಕ್, ಈ ಬಟನ್ ಪ್ಲಾಸ್ಟಿಕ್ ಇದೆ, ಕನ್ನಡಿಯಲ್ಲಿ ಪ್ಲಾಸ್ಟಿಕ್ ಇದೆ, ಪ್ರೊಜೆಕ್ಟರ್ ಪ್ಲಾಸ್ಟಿಕ್ ಇದೆ, ಮೈಕಲ್ ಪ್ಲಾಸ್ಟಿಕ್ ಇದೆ, ನಿಮ್ಮ ಎದೆ ಮೇಲೆ ಪ್ಲಾಸ್ಟಿಕ್ ಇದೆ. ಈ ಎಂತ ನೀವು ಪೆನ್ ಹೇಳ್ತೀರಿ ಹೇಳಿ, ಪ್ಲಾಸ್ಟಿಕ್ ಇದೆ. ಹಾಸನದಲ್ಲಿ ಸ್ಯಾಟಲೈಟ್ ಕಂಟ್ರೋಲ್ ಸಿಸ್ಟಮ್ ಇದೆ, ಅದು ವರ್ಕ್ ಆಗ್ತಿದೆ ಅಂತ ಚೆಕ್ ಮಾಡಿದ್ರೆ ರಿಪೋರ್ಟ್ ಬರೋದು ಪ್ಲಾಸ್ಟಿಕ್ ಲ್ಯಾಮಿನೇಷನ್. ಪ್ಲಾಸ್ಟಿಕ್ ಇದೆ. Such a sophisticated engineered material it is, the plastic. Then why want to say no to plastic? ಆದರೆ ಯಾವ ಸೆಕ್ಟರ್ ಅಲ್ಲಿ, ಯಾವ ವರ್ಗದಲ್ಲಿ, ಯಾವ ವಿಚಾರದಲ್ಲಿ ಪ್ಲಾಸ್ಟಿಕ್ ನಮಗೆ, ಸಮುದಾಯಕ್ಕೆ, ಪ್ರಾಣಿಗಳಿಗೆ, ಪಕ್ಷಿಗಳಿಗೆ ತೊಂದರೆ ಕೊಡ್ತಾ ಇರೋದು ನೀವು ನೋಡ್ಬೇಕಾಗಿದೆ. ಅದರೊಳಗೂ ಮಕ್ಕಳಿಗೆ ಪ್ಲಾಸ್ಟಿಕ್ ತೊಂದರೆ ಕೊಡ್ತಾ ಇದೆ ಅಂದ್ರೆ ಅಂತೀರಾ? ನೀವು ತೊಂದರೆ ಕೊಡ್ತಾ ಇದೆ ಮಕ್ಕಳಿಗೆ ಹೆಚ್ಚು. ಯಾಕೆ? 1-2 ಎಕ್ಸಾಂಪಲ್ ಹೇಳ್ತೀನಿ. earlier, I mean, plastic, recycled plastics are dangerous. Tapu plastic ಇದೆಯಲ್ಲ ಅದರೊಳಗೆ leachable metals ಅಥವಾ material is too high. That's why contamination will be too high. ಮತ್ತೆ ನಾವು ಸ್ಟ್ರಾ ಯೂಸ್ ಮಾಡ್ತೇವೆ, ಸಿಂಗಲ್ ಯೂಸ್ ಪ್ಲಾಸ್ಟಿಕ್ಸ್ ಬ್ಯಾನ್ ಮಾಡಬೇಕಾಗಿದೆ, ಪ್ಲಾಸ್ಟಿಕ್ ಶೀಟ್ಸ್ ಮಾಡಬೇಕಾಗಿದೆ, ಅದೆಲ್ಲ ಸರಿ ಇದೆ. ಬಟ್ ಪ್ಲಾಸ್ಟಿಕ್ ಬಳಕೆಯ ವಿಧಾನವನ್ನ ನೋಡಿ, ನಾನು ಅವ್ರಿಗೆ ಪ್ಲಾಸ್ಟಿಕ್ ಬ್ಯಾನ್ ಮಾಡಿ ಅಂತ ಹೇಳೋರಿಗೆ ಈ ವಿಷಯ ಹೇಳ್ತಾ ಇರ್ತೇನೆ. ಪ್ಲಾಸ್ಟಿಕ್ ಪ್ರೊಡಕ್ಷನ್ ಫ್ಯಾಕ್ಟ್ರಿ ಆಗ್ತದೆ, ಸರಿ ತಾನೆ? ಫ್ಯಾಕ್ಟ್ರಿ ಆಗುವಾಗ ನಿಮ್ಗೆ ಏನಾದ್ರು ಪೊಲ್ಯೂಷನ್ ಮಾಡಿದ್ಯಾ? ಎಲ್ಲಾದ್ರೂ ತೋರಿಸಿದ್ರೆ ಪ್ರೊಡಕ್ಷನ್ ಆದ್ಮೇಲೆ ಗೋಡನ್ಗೆ ಸೇರ್ತದೆ, ಅಲ್ಲಿ ನಿಮ್ಗೆ ಪೊಲ್ಯೂಷನ್ ಆಗ್ತಾ ಇದೆಯಾ? ಗೋಡನ್ ಆದ್ಮೇಲೆ ಮಾರೋಡಿ ಗೋಡನ್ ಹೋಗ್ತದೆ ಪೇಟೆಗೆ, ಅವನ ಹತ್ರ ಪೊಲ್ಯೂಷನ್ ಆಗ್ತಾ ಇದೆಯಾ? ಮಾರೋಡಿ ಗೋಡನ್ನಿಂದ ಐಸ್ ಕ್ರೀಮ್ ಫ್ಯಾಕ್ಟ್ರಿಗೆ ಅಲ್ಲಿಗೆ ಇಲ್ಲಿಗೆ ಎಲ್ಲ ಕಡೆ ಹೋಗ್ತದೆ, ಅಲ್ಲಿ ನಿಮ್ಮ ಐಸ್ ಕ್ರೀಮ್ ಫಿಲ್ಅಪ್ ಮಾಡುವಾಗ ನೀರು ತುಂಬುವಾಗ ಪೊಲ್ಯೂಷನ್ ಆಗ್ತಾ ಇದೆಯಾ? ಪ್ಲಾಸ್ಟಿಕ್ ಇಂದ, ಬೇರೆ ವ್ಯವಸ್ಥೆ ಇದ್ದಲ್ಲ. ಅದನ್ನ ನೀನು ಐಸ್ ಕ್ರೀಮ್ ಕಪ್ಪಿಗೆ ಹಾಕೊಂಡು ಐಸ್ ಕ್ರೀಮ್ ಕಪ್ ಅನ್ನ ಮತ್ತೆ ಸ್ಪೂನ್ ಅಲ್ಲಿ ನೀವು ತಿಂತಾ ಇದ್ಯಾ, ಅವಾಗ ನಿನಗೆ ಪೊಲ್ಯೂಷನ್ ಆಗಿದ್ಯಾ? ನಿನಗೆ ತೊಂದರೆ ಕೊಟ್ಟಿದ್ಯಾ? ಪ್ರಾಣಿಗಳಿಗೆ ತೊಂದರೆ ಕೊಟ್ಟಿದ್ಯಾ? ಓವರ್ ಆಲ್ ಸಿಸ್ಟಮ್ಗೆ ತೊಂದರೆ ಕೊಟ್ಟಿದ್ಯಾ ಆ ಪ್ಲಾಸ್ಟಿಕ್ ಐಟಮ್, ಕಪ್ಪು ಮತ್ತೆ ಸ್ಪೂನ್? Then why you want to say no to plastic? The moment it is consumed, the product is consumed. ನೀವು ಐಸ್ ಕ್ರೀಮ್ ಅನ್ನ ತಿಂದ ನಂತರ ಈ ಎಡಗೈ ನೋಡಿ ಕಪ್ ಅನ್ನ ಬಿಸಾಕ್ತಾ ಇದೆ, ಸ್ಪೂನ್ ಅನ್ನ ಬಿಸಾಕ್ತಾ ಇದೆ, ಇಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ ನಿಮ್ಮ ಸಮಸ್ಯೆ. ಅಂದ್ರೆ we don't have an infrastructure to retain this material which is thrown out of as garbage. ಅಲ್ಲಿ ಪ್ಲಾಸ್ಟಿಕ್ ಕಪ್ ಅನ್ನ ಸ್ಪೂನ್ ಅನ್ನ ಹೊರಗಡೆ ಬಿಸಾಕ್ತಾ ಇದೀವಲ್ಲ, ಬೇರೆ ಬೇರೆ ರೂಪದಲ್ಲಿ ಬಿಸಾಕ್ತಾ ಇದೀವಲ್ಲ, ಬಿಸಾಕಿರೋದನ್ನ ಹಿಡಿದಿಟ್ಕೊಳ್ಳಿಕ್ಕೆ ಬೇಕಾಗಿರುವ ಇನ್ಫ್ರಾಸ್ಟ್ರಕ್ಚರ್ ನಮ್ಮಲ್ಲಿ ಇಲ್ಲ. ಹಾಗಾಗಿ ಅದು ಚರಂಡಿ ಸೇರ್ತಾ ಇದೆ, ಹಾಗಾಗಿ ಬೀದಿ ಮಧ್ಯೆ ಕಾಣಿಸ್ತಾ ಇದೆ, ಹಾಗಾಗಿ ದನಗಳು ತಿಂತಾ ಇದೆ, ಅಥವಾ ಪ್ರಾಣಿ ಪಕ್ಷಿಗಳು ತಿಂತಾ ಇದೆ, ಇಲ್ಲಾಂದ್ರೆ ಮೈಕ್ರೋ ಪ್ಲಾಸ್ಟಿಕ್ ಹೆಸರಲ್ಲಿ ಸಮುದ್ರ ಸೇರ್ತಾ ಇದೆ, ಬಲೆಗಳ ಹೆಸರಲ್ಲಿ ಸಮುದ್ರ ಸೇರ್ತಾ ಇದೆ. ಸಮುದ್ರದಲ್ಲೆಲ್ಲ ಬೀಚ್ ಯೂಸರ್ಸ್ ಮೇಲೆ ದೊಡ್ಡ ಬೊಬ್ಬೆ ಇತ್ತು. ಏನಂದ್ರೆ ಬೀಚ್ ಯೂಸರ್ಸ್ ಆರ್ ದ ರೆಸ್ಪಾನ್ಸಿಬಲ್ ಪೀಪಲ್, ದೋಸ್ ಆರ್ ಕಾಂಟ್ರಿಬ್ಯೂಟಿಂಗ್ ಟುವರ್ಡ್ಸ್ ಮರೈನ್ ಪೊಲ್ಯೂಷನ್ ಅಂತ. ಸಮುದ್ರ ಮಾಲಿನ್ಯಕ್ಕೆ ಬೀಚ್ ಯೂಸರ್ಸ್ ಗೆ ಸಂಬಂಧ ಹೋಗ್ತೀರಾ? ಅವರಿಗೆ ಜಾಸ್ತಿ ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ನೋ, ಇಟ್ಸ್ ದ ಕ್ಯಾಚ್ಮೆಂಟ್ ಏರಿಯಾ ಪೀಪಲ್, ದೋಸ್ ಆರ್ ಕಾಂಟ್ರಿಬ್ಯೂಟಿಂಗ್ ಮೋರ್ ದನ್ 90% ಆಫ್ ಪೊಲ್ಯೂಷನ್ ಟು ದ ಮರೈನ್ ಎನ್ವೈರನ್ಮೆಂಟ್. ಅದಕ್ಕೆ ರಿಟೇಲ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬೇಕಾಗಿರೋ ವ್ಯವಸ್ಥೆ ಮಾಡಿದ್ರು, ಅದನ್ನ ರಿಟೇಲ್ ಮಾಡಬೇಕಾಗಿದೆ ಅಷ್ಟೇನೆ. ಇದು ಬಿಸಾಕಿರೋದನ್ನ ಸರಿಯಾಗಿ ಇಟ್ಕೊಳ್ಳಿಕ್ಕೆ ಬೇಕಾಗಿರೋ ವ್ಯವಸ್ಥೆ ಮಾಡಬೇಕಾಗಿದೆ ಅಷ್ಟೇನೆ. ನೀರು ಚರಂಡಿಗೆ ಹಾಕಿ ನೀನು ಅದ್ರ ಬಗ್ಗೆ ಆ ತರ ಒಂದು ವಿಸರ್ಜನಾ ಮನೋಭಾವ ಇಟ್ಕೊಂಡಿರೋದ್ರಿಂದಲೇ ತಾನೇ ನೀವು ಇವರನ್ನು ಅನುಭವಿಸ್ತಾ ಇರೋದನ್ನ. ಇಲ್ಲಾಂದ್ರೆ ಹೇಗೆ ಮಾಡ್ತಾ ಇದ್ವಿ? Everything, what we think of, what we really intended to think of, any subject for that matter, including your body, ನಿಮ್ಮ ದೇಹನು ಸೇರಿ ನೀವು ನಿಮ್ಮ ದೇಹ ಇವರೆಲ್ಲ ಆರೋಗ್ಯವಾಗಿದ್ದೀರಾ, ನೀವೆಲ್ಲ ಆರೋಗ್ಯವಾಗಿದ್ದೀರಾ. ಯಾಕೆ ಆರೋಗ್ಯವಾಗಿದ್ದೀರಾ? ಕರೆಕ್ಟ್ ಟಿಫನ್ ಮಾಡ್ತೀರಾ, ಚೆನ್ನಾಗಿ ಟಿಫನ್ ಮಾಡ್ತೀರಾ, ಕೈ ತೊಳ್ಕೊಂಡು ಟಿಫನ್ ಮಾಡ್ತೀರಾ. ಯಾಕೆ ನೀವು ಮಣ್ಣು ಮುಟ್ಕೊಂಡು ಗಲೀಜ್ ಮಾಡ್ಕೊಂಡು ಟಿಫನ್ ಮಾಡ್ತಾ ಇಲ್ಲ, ಊಟ ಮಾಡ್ತಾ ಇಲ್ಲ? ಯಾಕೆ ಅಂದ್ರೆ ದೇಹ ನಿಮ್ಮದು ಅನ್ಕೊಂಡಿದ್ದೀರಾ. ಅದಕ್ಕೆ ಬೈ ಚಾನ್ಸ್ ಆ ದೇಹ ನಿಮ್ಮದಲ್ಲ, ನಿಮ್ಮ ಹೆಂಡತಿರೋ ಅಥವಾ ಇನ್ನೊಬ್ಬರು ಯಾರು ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಅದನ್ನ ಚುಚ್ಚಿ ಬೇಕಿದ್ರೆ ಏನಾದ್ರು ಬೇಕಾದ್ರೂ ಪಂಚರ್ ಮಾಡ್ತಾ ಇದ್ರೆ ಮೇಂಟೈನ್ ಮಾಡ್ತಾ ಇರಲಿಲ್ಲ. ಸರಿ ತಾನೆ? ಸೇಮ್ ಅನಾಲಜಿ ಇಸ್ ರಿಕ್ವೈರ್ಡ್ ಟು ಪ್ರೊಟೆಕ್ಟ್ ದ ಎನ್ವೈರನ್ಮೆಂಟ್. ಯು ಶುಡ್ ಫೀಲ್ ದಟ್ ಇಟ್ ಇಸ್ ಯುವರ್ಸ್. ಅಷ್ಟೇ. ನೀವು ಅದನ್ನು ನನ್ನದು ಅನ್ಕೋಬೇಕಾಗಿದೆ. ಪೇಟೆಯಲ್ಲಿ ಯಾಕೆ ಕ್ರೈಮ್ ರೇಟ್ ಜಾಸ್ತಿ ಇರ್ತದೆ, ಗ್ರಾಮಾಂತರ ಪ್ರದೇಶದಲ್ಲಿ ಹಳ್ಳಿಗಳಲ್ಲಿ ಕಡಿಮೆ ಇರ್ತದೆ? ಯಾಕೆ? ಗ್ರಾಮಾಂತರ ಪ್ರದೇಶದಲ್ಲಿ ಆ ಪಕ್ಕದ ಮನೆ, ದೊಡ್ಡ ಮನೆ, ಆ ಮನೆ, ರೋಡ್ ಮನೆ ಮಕ್ಕಳು, ಅವಳು ಇವಳು ಎಲ್ಲಿ ಹೋಗ್ತಾಳೆ ಎಲ್ಲ ಗೊತ್ತಾಗ್ತದೆ. ಹಾಗಾಗಿ ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ಅಂಡರ್ ಕಂಟ್ರೋಲ್. ಆಸ್ ಇನ್ ದ ಸಿಟಿ ಅಂಡ್ ಸಿಟಿ ಲಿಮಿಟ್. ಪಕ್ಕದಲ್ಲಿ ಮನೆಯಲ್ಲಿ ಇರೋನು ಸತ್ತು ಕೊಳತು ಹೋಗಿ ವಾಸನೆ ಬಂದ ಮೇಲೆ ಅದನ್ನು ಬಾಗಿಲು ನಾನು ತೆಗೆದಿಲ್ಲ, ಪೊಲೀಸರು ಹೇಳಿ ಸರ್ ಪಕ್ಕದ ಮನೆ ಏನೋ ವಾಸನೆ ಬರ್ತಾ ಇದೆ, ನೀವು ಬನ್ನಿ. ದಟ್ ಇಸ್ ದ ಸಿಸ್ಟಮ್. core of the city is always for crime. ಹೌದು, ಅಲ್ಲಿ ಯಾಕೆ ಆಗುದಿಲ್ಲ? ಹಳ್ಳಿ ಯಾಕೆ ಅಷ್ಟು ಆಗುದಿಲ್ಲ? ಯಾಕಂದ್ರೆ everybody know to me. ನಿನ್ನ ಫ್ಯಾಮಿಲಿ ಯಾಕೆ ಕ್ಲೈಮ್ ಮಾಡೋದಿಲ್ಲ? every component is known to me. ಹಾಗೇನೂ ಇದೆ ಇಲ್ಲ, ಹಾಗೇನೇ ನಿಮ್ಮ ಪರಿಸರ ಯೋಚನೆ ಮಾಡುತ್ತೀನಿ ಅಲ್ವಾ? ಇಷ್ಟು ಹೇಳ್ತೇನೆ, ಸಾಕು ಮಾಡ್ತೇನೆ. ಥ್ಯಾಂಕ್ ಯು. ಯಾಕಂದ್ರೆ ಅರ್ಧ ಗಂಟೆ ಸಮಯ. ಇನ್ನೂ ಏನಾದರೂ ಪ್ರಶ್ನೆಗಳು ಕೇಳಲಿಕ್ಕಿದ್ರೆ ದಯವಿಟ್ಟು ಕೇಳಿ. ವಿಲ್ ಹ್ಯಾವ್ ಎ ವೆರಿ ಬ್ರೀಫ್ ಡಿಸ್ಕಷನ್. ಆರ್ ಎಲ್ಸ್ I'm very thankful to the AJIET institution and all the faculty, including the principal, for their gracious consideration for me to, deliver my findings or kind of things which have come across my lifetime. Okay, ಏನು ಹೇಳಬೇಕಂತಿದ್ರೆ ಎಲ್ಲ ಹೇಳಿದ್ದೇನೆ. ಇವೆಲ್ಲದಕ್ಕೂ ಎನರ್ಜಿಗೂ ಸಂಬಂಧ ಇದೆ. ನೀವು ನೋಡ್ತಾ ಹೋಗಿ ಬ್ಯಾಂಕಿಂಗ್ ಸಿಸ್ಟಮ್ ಎನರ್ಜಿಗೆ ಸಂಬಂಧ ಇದೆ, ಫುಡ್ ಹ್ಯಾಬಿಟ್ಸ್ಗೂ ಸಂಬಂಧ ಇದೆ. ನೀವು ಹೆಚ್ಚು ಊಟ ಮಾಡಿದ್ರೆ ನಿಮ್ಮ ಆರೋಗ್ಯ ಹಾಳಾಗ್ತದೆ, ಓಝೋನ್ ಲೇಯರ್ ಹಾಳಾಗ್ತದೆ ಅನ್ನೋದು ಇಮ್ಯಾಜಿನರಿ ಥಿಂಗ್ ಅಲ್ಲ. 100% ಲಿಂಕ್ ಇದೆ. 100%. ನೀವು ನಿಮ್ಮ ಆರೋಗ್ಯ ನಿಮ್ಮ ಹೊಟ್ಟೆ ನೀವು ತುಂಬೋದು. ಏನು ಮದುವೆ ಆಗ್ತಿರಲ್ಲ, ಇದಕ್ಕೂ ನಿಮ್ಮ ಹೊಟ್ಟೆಗೂ ಹೊಟ್ಟೆಗೂ ನಿಮ್ಮ ಆರೋಗ್ಯಕ್ಕೂ ಓಝೋನ್ ಲೇಯರ್ಗೂ ಸಂಬಂಧ ಇದೆ. ಅದೆಲ್ಲರಿಗೂ ಎನರ್ಜಿಗೂ ಸಂಬಂಧ ಇದೆ. ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್.
On behalf of AJIET family, I thank Mr. Lakshmikant sir. Thank you very much for your valuable inputs. Thank you very much. Moving to the next session, I request Ms. Rachana Kundra to introduce our resource person for the next session.
Sir, I'll take
Thank you, sir.
Thank you. I'm sorry.
It is my honor to introduce to you our next speaker of the day, Dr. Santosh K, Professor in the Department of Mechanical and Industrial Engineering at Manipal Institute of Technology, Mahe, Manipal. He is a result-oriented academician and researcher with over 13 years of experience in teaching, research and development, specializing in hydrogen energy, combustion analysis, emission reduction technologies, and carbon neutrality. Dr. Santosh earned his PhD from NIT Surat, where his doctoral research focused on experimental investigation of hydrogen and higher alcohol blends in CRDI diesel engines. He also holds an MTech in thermal power engineering and a BE in mechanical engineering from BT. His research interests span hydrogen energy, alternative fuels, SCR catalyst, NOx emission reduction, and sustainable energy systems. He has an impressive research profile with 18 international journal publications, many in high-impact QI journals such as Energy, Fuel, Energy Conversion and Management, and Journal of Cleaner Production. His scholarly contributions have earned him a H index of 8 with over 370 citations. In addition, he holds 3 published Indian patents related to automotive cooling, aerodynamics, and dust reduction system. Dr. Santosh has actively contributed to the academic community as a conference coordinator, session chair, PhD guide, and reviewer of the reputed international journals. He is proficient in advanced simulation tools such as AVL Fire and ANSYS and is deeply committed to mentoring students and advancing sustainable energy research. On behalf of AJIET Institute of Engineering and Technology, I extend a warm welcome to you, sir. May I request the coordinator, Dr. Suhan Das, to florally welcome our speaker. In view of your elaborate experience and credentials, we are now keen to hear your valuable perspective on hydrogen as a fuel in EC engine. I now hand over the stage to Dr. Santosh K. Over to you, sir.
So actually my session has to start at 11. So due to unfortunate reason it is extended. Okay, here so I'm here to present about hydrogen energy. So it's I'm going to talk about hydrogen energy, that is how it is going to get produced, its consumption and its challenges. So the production and consumption is very important. So hydrogen energy is one of the important energy. So that can create wonder in the energy sector. So we know that what are all the energy crises that we are facing today? Not because of unavailability of the unavailability of the energy, but it is because of geopolitics. and also what are the emissions that it emits due to combustion. Okay, we know that. So last from 1 or 2 decades, our climate has drastically changed. Okay, so the seasons have changed, and the emissions in the atmosphere that increased, and several changes that is happening, and in the environment, the humidity that increased, right? So I have seen in a Bangalore, the best example for the Karnataka scenario is the Bangalore. The last 10 to 15 years, whatever the scenario was in the Bangalore, but nowadays that scenario is not going to see. So we are experiencing a higher humidity in case of the Bangalore. So it is never happened in the history of the Bangalore because the Bangalore is created higher, higher sea level, higher than the sea level. So that is maybe around 900 to 1000 meters higher than the sea level. So usually one of the environment there or climate there in the Bangalore is not chilled. But nowadays, if you visit to Bangalore, it is not the whole of Bangalore. It has the drastic changes that is happened in the Bangalore. That is due to pollutions and the combustions of fossil fuels. That is one of the reasons. And another thing is that Bangalore population got increased. Usage of the electricity got increased because Bangalore is a high hub. Most jobs, everyone wants to move to Bangalore because Bangalore is a dream city for earning, for spending, for to lead the very good lifestyle. But nowadays the climate in the Bangalore got literally changed. And also Bangalore is not far away from the Bangalore. Bangalore is also and so much climate got changed. So maybe the starting of the monsoon may get delayed in some years, right? And also humidity got also increased in the Bangalore regions. And also due to industrial pollution, so the Bangalore is also ranked higher in pollution, that is environmental pollution. That is release of the CO2, NOx and the CO emissions, right? Need of hydrogen. Instead of directly going to the hydrogen energy, first we should know what is the need of hydrogen energy. Why we are most concerned towards the hydrogen energy, right? So as we can see in the global energy demand, in whatever that is happened, this clearly gives and figures about in 2024. But that we can clearly see that the requirement of the total energy demand is worth by 2.2. Also increased, that is around 3.2%, and the electricity demand is increased by 4.3%. So okay, along with the electricity demand, our GDP, it's a global GDP is also increased because of the increasing in the production sector and consumption, right? So why particularly why the electricity demand is increased instead of a fossil fuels, instead of an like petroleum resource? Why the electricity demand is increasing? That is mainly because of this data centers and electrifying the industrial sectors and using of AI. See, each and every information are keywords that we are searching in the internet that has to take and rigorous search in the data that has to give results. It consumes lot of electricity. So where this electricity will be produced? Ultimately from the burning of coal or maybe nuclear fuels or maybe something else. So our 95% of electricity demand is fulfilled by the fossil fuel itself. Maybe it's maybe a nuclear fuel, it may be a coal. Right, the total energy demand in a different countries. So when we are going to see the first two positions will be occupied by the China and India. The reason obviously that is increasing in its population. Obviously China is one of the leading country in the world, right? That producing almost all the consumer goods. If you want anything, that is made by the China. Because China has improved technology, manpower, not only the manpower, India has also had a lot of manpower, that is we crossed almost 130 crore. But when it comes to the China, they have technology. So they have the well-developed technology, they are working towards the improvement of the technology, they are working towards sustainability. almost always we are blaming China, but nowadays China is not in that position. It is produced everything and try to become a sustainable nation in the world. So that's why obviously the fuel consumptions are energy consumptions in the world. China stands first because the China supply almost all the goods, consumer goods to the world. Next, the India comes into the picture. Slowly, we are also moving towards the production sector to improve our GDP, right? And also, we try to become an independent nation in the production sector. That's why our electricity consumptions or energy consumption also increases. Apart from that, we are the hub for the data centers and technology sector, that is in the IT field. So that also requires a lot of energy consumption. So next, coming to the picture, United States, right? So they have owned their manufacturing sector. They are that is like a different sector, maybe there or maybe aeronautical sector. They are very and also they have a very good R&D. So they also come into the picture for the energy consumption. Next, the thing will come into that Europe. Europe will also consumes more energy because due to their less populations also they are consuming more energy for their heating purposes. Right? So they have the cold countries, obviously they need more natural gas for the heating purpose. So next, the Middle East or maybe Japan will come to the picture. So what is the global oil supplies then? So we can see the global oil supply in 2024, it's maybe around 103 million barrels per day. But it is estimated that it will reach around 105 million barrels liter, whatever that is million barrel per day in 2030. So almost it is an increasing in that rate. Why? Because the oil consumption in the automotive sectors and also for the small energy sector that is increasing drastically increasing. In the last decade also the oil consumption is increasing. It is not anywhere in the downtrend. Because due to an increasing in the automotive, the population and also according to that we have to provide and transportations. So not only the transportation sector and also for the energy demand, for the supply of energy demand, that is maybe the coal or maybe in industrial, that is for the electrifications of the industries also increase in the oil demand. Right. So in the figure we can see that the trend of the use of the clean energy. To meet this demand for energy demand, the use of the green energy that is increasing from year to year. That we can see the green trend. So it's almost from 1950 to 2050. It is in the increasing trend. So what is the future? Future is the green technology. Why we are more interested in the green technology? Because it is free from the emissions, especially the carbon dioxide emissions. Right, electrical sales. Okay, we talked about the demand in the electricity and also the oil supply. What is the oil requirement for the world oil requirement? Now we have to see an electric cars. So electric vehicles is not a new technology. It is a very old technology. As per my knowledge, I have seen Mahindra Reva car, the first electric car. Maybe before that one, I don't know. So whatever I saw that Mahindra Reva was the first electric car. So I have seen in Bangalore. So it is last from 20 years back. I have seen. But after that, there is no technology got improved because due to availability, abundant availability of the oil, that is fossil oils, right? The petroleum oil. So later after the COVID, suddenly the production of the electric vehicles got increased. So that is again due to international, that is maybe we can't tell that exactly lobby, but they are giving a importance to the other sector. They want the people to push into the different category to increase the purchase, right? So in almost in automotive sections, if you see any cars, whatever the engine used by the Tata, the same engine also used by the Mahindra or maybe someone else. Okay, there are one or two original equipment manufacturers are there that will provide the engines to the almost all the brands. They will brand it and they are going to sell their cars in the market. But the community has to push to purchase new vehicles, maybe in terms of labeling a green energy or something like that. So they introduced in 2019 to 20 the sale of the electric cars rose. So that is pushed by the again European countries and again by the United States. But nowadays you can see the sales of the electrical cars is the highest in China. China is one of the country that produces and varieties of electric cars that has a sustainability, that has a higher energy density, and also the life of the battery has got improved a lot from last 10 years. So in 2019, the sale of the electric cars was less, but when it comes to the 2024 in China, it is literally increased, and also in India also we are nowadays we are interested to purchase electric car because of like once it is charged, we can run at least 100 to 50 kilometer range. So for that reason, to avoid any fuel consumption, we are very much interested in the consumption of electric cars. So what is the electricity generation, right? On what basis? Okay, these are the demand, electricity demand. So then how to meet this demand, electricity demand? So whatever the orange color that you can see, that orange color indicates the use of the coal for the production of electricity. In almost in India, so if you take in India and China, we are the biggest consumers of the coal. The reason is that we have the abundant availability of the coal in India, right? The China have abundant availability of the coal, and also we have the abundant availability of the coal. For that reason, we are utilizing the coal and we are consuming it for the power production. But the drawback is that the coal, the combustion of the coal produces a lot of adverse effects, right? So it produces an CO2 emissions directly. Apart from that, it produces a fly ash. And also whatever the particulate matter that it produces, its size is more than 2.5 is there. The PM 2.5 is produced due to the combustion of the coal. So when it comes to the United States and when it comes to the European countries that drastically reduce the consumptions of the coal, they are dependent on the nuclear power and also they are dependent on the natural gases. So the highest natural gas consumption countries are European countries, but when it comes to the China and India, we don't have any other options. We want to be an energy independent nations. So to avoid any foreign transactions and to avoid any geopolitical tensions, we have given more importance to the consumptions of coal for the electricity. Right? So then, what is the CO2 emission? What is the CO2 emissions? Obviously, China and India will be in the higher positions. Why? Because we are we are consuming more amount of coal for the power generation. We can see what are the different sectors that contributes for the production, for the emissions of CO2. You can see here the China and India are drastically producers and CO2 and comes to the United States and European countries. So the Asia is the biggest productions of the CO2 emissions compared to and European countries are United States. So what is the energy demand in India? Okay, till now we talked about what is the energy about the globe. But when it comes to the Indian countries, what is the energy demand in India and where is the oil consumption, where is the natural gas consumption, so that we can see here. So it is a chart that is provided by the Ministry of Petroleum. So and we can see that the pink line indicates, the pink portion indicates that LPG consumption. Because so in India, every kitchen is completely supplied by the LPGs, right? Almost all in the village sites also, in the city sites also, almost all the kitchens are equipped with LPG cylinders and stoves. Because to avoid any the CO2 emissions, right, drastic CO2 emissions from the burning of the biomass, right? So that's why from the last one decade, from last 10 years, the continuous usage of the LPG got increased. That's why in the energy chart, in the pie chart, it consumes and more space. And only 11.5% oil demand is there in India. So always we are blaming the automotive sectors. Automotive sectors are the largest largest producers of the CO2 NOx emission. But when you come to a chart, you can clearly indicate that only around 11.5% that is oil consumption is there for the automotive sectors. Not only for transportation sector and also for the commercial side, that is in the agriculture sector also it includes. And also we don't have any other options. We can't be able to avoid the use of the petroleums, the oils in case of a transportation sector, especially in like agriculture sectors or maybe and handling the big equipments. So only the passenger vehicles can be converted into EVs, but other than the passenger vehicles, we don't have any other choice of converting the entire thing into the EV. Because again, if you use an EV also, the requirement, it leaves an carbon footprint more than the automobiles, that is ICTE vehicles. Because the productions of the batteries, recycling of the batteries, and the energy input to the battery, the energy storage. So where we are going to produce the electricity by utilizing again the coal. So and there is no, and like only we are avoiding that the emission of CO2 in the city limits. We are producing the CO2 emissions somewhere else. Okay. And also the forecasting in 2025 and 26. So again the LPG the portion that increased, and also oil portions also that increased because of increasing the populations and energy demand and the production sector. So all these, and also in India makes a Make in India concept. Under that concept, the investment is more, and also day by day and year to year, the consumptions of the power that increased in the industrial sectors. So crude oil import goes about almost 10 to 15, more than 15% of our GDP is invested to purchase the oil. So that is the biggest tension that is present in India. So already we are purchasing a crude oil of the Russia, and due to that we are facing a highest tariff from the US. So this is the geopolitical tensions. And also in 2019 or before that, when the Russia-Ukraine starts, that also causes an adverse effect in the energy supply. So to avoid all these tensions, to avoid spending more money on the energy, we should be an energy independent nations. Then only it is possible to concentrate on the other sectors, right? So foreign policies. So in every news, the headline is like that: US, Russia, oil, India. Why is that? Because of this energy. So what we call this is a fossil fuels. We call it as a black gold. So whatever the mafia that is there in the world, that is the biggest mafia is the oil mafia. That is fossil fuel mafia. So because the entire world is dependent on the energy. So who is the king? So the one who independent on energy. So if the US is not dependent on anyone, so then he is the king and is ruling. So that's why their dollar price is increasing. So whenever the exchange happens, obviously our rupees has to pay more to exchange the dollar. So this is a CO2 emission by the category wise is there. So you can see where is the most CO2 that is produced in the electricity, right? Because the consumptions. The consumptions of the electricity drastically increases, and you can see the transportation sector. The chart in the area is very small, the gray area is there. Compared to an electricity production, whatever the chart is there, whatever the area is there, that is in the gray color indicated, it is very small. The transportation sector consumes a very less amount compared to electricity production. It is only around 11.5 or 13% of oil, right? And also its CO2 production is also less compared to electricity productions. So then, sectoral wise green gas emissions. So the first production is that energy sector, right? And the second one comes into the picture, agriculture. For nowadays, almost all the agriculture works becomes dependent on the automotives. That is, the tractors for the harvesting, for any kind of the work, the agriculture, the farmers are highly dependent on the automotives. Right? For that reason, it produces almost higher emissions compared to the transportation sectors, and some other waste, biomass waste, and from the other sectors also some CO2 emissions are greenhouse emissions are produced. So renewable energy progress. Yes, already we know that the adverse effect of consumptions of fossil fuels. So that should be reduced. Why? We have to avoid a greenhouse that is whatever the CO2 and NOx is there, that we have to reduce. So what we have to do, we have to improve the sustainability in the energy sector. So for that reason, we have to consume a natural available energies. right? So we can see that. So what is the largest thing is that solar parks. We developed in Karnataka the biggest solar park that is there in Tumkur district, that is in the Pavagada. So it has a very big project, and also if you see, if you go to in nearby Chittoor, that we can see, and the windmills are there. So that is possible productions of the renewable energy. We are the biggest. I mean, in Karnataka, we are contributing more towards the renewable energy. That is green energy. And also solar. So what are the possible green energy that we can go? Solar, wind energy, and part of the biomass energy. So then what are the regulated emissions? So only I am going to talk about the regulated emissions. I am not going to talk about the not regulated emissions. The non-regulated emissions maybe more, maybe AJIET or something is there, maybe that also, but the portion is very less compared to regulated emissions. The common regulated emissions are CO2, CO, HC, and NOx. So these are some of the normal, common regulated emissions from the industry also. Industry, if I include the industry, it may be particulate matter and fly ashes may be there. So these are some of the possible emissions from the both automotive sectors and the industry. So why these emissions are going to get formed? That is due to incomplete combustion. So due to inefficient burning of the fuel. So that's why what happened. The India has moved from BS4 to BS6 to increase its combustion efficiency by skipping F5. So we'll talk later. So now what is the adverse effect of these emissions? You can see a small video that it contains that shows how the globe temperature is changing from blue to red hot. So it is the video that is available in the NASA website that you can go and see. From it is recorded, the temperature is recorded from 1950 to 2003 or something is there. So we can see a lot of changes happened in the globe temperature, right? So that is happened due to this greenhouse gas emissions. So we can see in every year an increment of 0.2 degrees Celsius of temperature is adding to the globe temperature. So and then what is global warming exactly? So why it is happening? So this is, you can see that during the daytime what happens, and radiations from the sun is received by the earth. So the temperature on the earth is going to get increases during the daytime. So that should be re-radiated back during the night time. That is due to a temperature difference. Right? Exponential difference, it should be a natural process. Okay, when you avoid that natural process, then what happens? So whatever the energy received by the sun, it is going to get trapped on the earth's surfaces. So why it is happening? So that is happening due to a formation of thick layer of gases around the earth. So these formations of thick layer on the earth's surface that avoids the re-radiations of the sun energy during the night time. So that is trapped on the earth. So that's why every year an increment of 0.2 degrees. So that leads to a global warming. So this is an exact application for the global warming. So what is the cause? The main cause is greenhouse gas emissions, carbon dioxide, methane, and that is NOx or N2O, and fluorinated gases from the industry. So these are the fundamental cause for the that is global warming, right? And what is the adverse effect of global warming on the nature? You can see the melting of the glaciers, right? And what happens? The increasing in the sea level. So increasing in the temperature of the earth, right? And moving the vegetation from one side to other side. So and what happens? The migrations of the animals from one region to another region. So right? And what happens? You can see increased humidity got increased. So these are the major adverse effect of the global temperature, an increment in the global temperature. So CO2 emission, again I am going to talk about the global CO2 emission because this is the biggest culprit for contributing the climate change. So where we are, China is the biggest producer of the CO2 emission, but India is also contributing more towards the CO2 emissions. So then why? Okay, fine. So the global the climate is changing, its temperature is increasing. okay, what are the measures that we have taken to reduce the temperature? So that is a Paris Agreement comes into the picture. So already we reached, the global temperature is already reached more than 2 degrees Celsius. But the exact figure, we are not, the policy makers, the industrialists, it's a pool of a policy maker, industrialists, politicians and the researchers are there in the group. So it is already reached more than 2 degrees Celsius, but they are telling only 2 degrees Celsius and they want to reduce it into the pre-industrial level, that is 1.5 degrees Celsius. Okay, that is to attain this global change, whatever the climate change that has happened, to avoid that one, an agreement is made. So that is, we call it as a Paris Agreement. So what are the key objectives of the agreement? To reduce the temperature of the globe, and whatever the developed nations are there that has to contribute to reduce these greenhouse gas emissions, that has to help, that are in the financial aid, that they have to give a financial aid to the developing nations, right? So, but in 2024, what happened? The United States, the the biggest contributor for this Paris Agreement are the United States. But in 2024, the Trump come out from this Paris Agreement claiming that, so we are not able to provide a financial aid for the developing countries like India. They are slightly named like India. So reason is that India is no more a developing country, it's already developed, their GDP is increasing. Still, they are claiming that we are a developing countries, we can't able to give any financial aid or assistance to these kind of the countries. So for that reason, they came out from Paris Agreement. So we can see what is Paris Agreement.
The Paris Agreement is a legally binding international treaty on climate change to limit global warming to well below 2, preferably to 1.5 degrees Celsius compared to pre-industrial levels. This requires economic and social transformation to face the climate challenges now and moving into the future based on the best available science. The Paris Agreement works on a 5-year cycle of increasingly ambitious climate action. By 2020, countries communicate their plans known as nationally determined contributions. Countries communicate actions they will take to reduce their greenhouse gas emissions in order to reach the goals of the Paris Agreement. Countries also communicate actions they will take to build resilience to adapt to the impacts of rising temperatures. This may include information on adaptation and finance flows. The Paris Agreement also provides a framework for financial, technical, and
yes. So
this is the Paris Agreement.
So this is the main reason why India is concentrating towards a greener energy sector. So India is also pushing in the EV sector, and also India made a stricter emission norms to reduce the CO2 emission from the automotive sector. So whatever the possible measures that is taken by India has been in all the way, and also the set up a national hydrogen mission to increase the utilizations of the hydrogen in almost all the sectors. So we can see, to avoid this CO2 emissions, we are also a part of the Paris Agreement. So India started to adopt in 2000. So India started to adopt an emission norms for the automotive sectors. So directly it is copied from the European Union. So that is Euro 1, Euro 2, very directly copied. From afterwards, what we did, we changed to BS3, BS4. So and straight away we skipped BS5 and adopted a BS6. And our Indian policy makers are very, they have a stringent emission norms that has to be surely followed by the production sectors, that is automotive production sector. So compared to BS4, with the drastic reductions that is happened in the productions, maybe in case of a CO, maybe in case of a particulate matter, maybe in case of a NOx emissions. So we can see, compared most of the car manufacturer, the automotive manufacturer, all to the productions of diesel engine because they can't able to maintain the BS6 norms, right? So for that reason, they are only running some petrol cars only. The best example is that and Suzuki vehicles, Maruti Suzuki vehicles, they completely halt the productions of the diesel vehicles. But only nowadays in 2026 also, the most emissions will come from the Indian government. And again, the Toyota is going to stop one of its most the largest sale car, that is Innova Krista. Innova Krista is going to get stopped the productions in 2026, that is 8th of 2026. So instead of Innova Krista, they are trying to sell an hybrid mode car that is in the name of Innova itself. So these are the comparison between the BS4 and BS6 emission norms. So and NOx and soot are the most contributors from the automobiles. That is definitely we have to reduce, right? So what are the adverse effect of the greenhouse gas emissions are the CO2 or CO2 or HC emissions? Directly it affects the health. Yes, obviously it affects the health. Maybe it leads to the everyday consumption of these emissions leads to causing cancer also. So not only the peoples are in other part of the Karnataka, the peoples are in Bangalore or Mangalore also suffering from cancer. So why? Because of these our condition. So these are some of the adverse effects, maybe serious health concern, health issues that we are going to face by using these emissions. So next, what is the final solution? Okay, we till now we around half an hour we talked about energy and its adverse effects and the geopolitics tensions and what we are spending. Almost all we talked everything. But what is the solution? The ultimate solution is the using a greener side of the energies. So what are the greener side of the energies? Maybe utilizations of the solar energy, maybe utilizations of the wind energy. But we are not able to utilize it properly because we don't have a sustainable technology utilizing it. So most of the technology is in the European countries and the technology transfer is not yet possible. But an agreement is going to get happen. So within 1 or 2 days, so maybe it may be the European peoples calling it as a mother of all the agreements between India and European countries. So especially the Germany will, the Germany wants to transfer its almost all green the green technologies to the India. That is going to get happen soon. But Indian government already invested more on hydrogen. So hydrogen is the only possible way in the future can be a cause for the sustainable. Okay, now I am going to stop. So after the lunch, I am going to cover what is the importance of the hydrogen, how we are going to manufacture the hydrogen, how we are going to utilize the hydrogen. Thank you.
Dear participants, afternoon we'll start the session at 1:45. We have Associate Professor Dr. Kumar GN from NITK will be starting with the session. After that, at 3:30 again, Santosh sir will continue. Thank you.
ಎಲ್ಲರಿಗೂ ನನ್ನ ವಂದನೆಗಳು. ನಮಗೂ ಸ್ವಲ್ಪ ಕನ್ನಡ ಮಾತಾಡೋದು ಕಷ್ಟ ಆಗ್ತದೆ. ಈಗ 10ನೇ ಕ್ಲಾಸ್ವರೆಗೂ ಕನ್ನಡದಲ್ಲೇ ಓದಿದ್ದು, ಬಟ್ ಆಮೇಲೆ ಏನಾಗ್ತದೆ ಈ ಒಂದು ಶಬ್ದಗಳು ಟ್ರಾನ್ಸ್ಲೇಟ್ ಮಾಡೋದು ತುಂಬ ಕಷ್ಟ. ಆದಷ್ಟು ಇಂಗ್ಲಿಷ್ ಮತ್ತೆ ಕನ್ನಡದಲ್ಲಿ ಟ್ರೈ ಮಾಡ್ತೀನಿ. ಪ್ರೀವಿಯಸ್ ಅಂದರೆ ಮೊದಲನೇ ಸ್ಲೈಡು ಕನ್ನಡದಲ್ಲಿ ಮಾಡಿದ್ದೀನಿ, ಮಿಕ್ಕಿದೆಲ್ಲ ಇಂಗ್ಲೀಷಲ್ಲೇ ಇದೆ. ಆದಷ್ಟು ನನಗೇನು ಗೊತ್ತಿದೆ ಅದನ್ನ ನಿಮ್ಮಲ್ಲಿ ಶೇರ್ ಮಾಡೋದಕ್ಕೆ ಇಷ್ಟಪಡ್ತೇನೆ. ಓಕೆ, ಇಂದಿನ ಸ್ಪೀಕರ್ ಡಾಕ್ಟರ್ ಸಂತೋಷ್ ಅವರು ಆಲ್ರೆಡಿ ಹೈಡ್ರೋಜನ್ ಬಗ್ಗೆ ಒಂದು ಸ್ವಲ್ಪ ಇಂಟ್ರೊಡಕ್ಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಮತ್ತೆ ಎನರ್ಜಿ ಬಗ್ಗೆ ಸಹ ಹೇಳಿದ್ದಾರೆ. ಈಗ I'll be focusing on more on pure hydrogen when we use in spark ignition engine. What are the modifications you have to do? What are the advantages and disadvantages? That is, ಏನು ತೊಂದರೆಗಳಿದೆ ಅಥವಾ ಏನು ಉಪಯೋಗಗಳಿದೆ ಅದರ ಬಗ್ಗೆ ಹೇಳಿ. ಈ ಹೈಡ್ರೋಜನ್ ನಾನು IIT ಡೆಲ್ಲಿಲಿ ಜಾಯಿನ್ ಆದಾಗ ಮೊದಲ ಸೆಮಿಸ್ಟರ್ ಅಲ್ಲೇ ನನ್ನ ಒಂದು ಸೂಪರ್ವೈಸರ್ ಕರೆದು why can't we work on hydrogen? But after consulting with my fellow students, they have expressed displeasure because hydrogen cannot be considered out of field. That is during 2006. No one were working except my supervisor were working long back, and no technology was available at that time. Even lab people were also not experienced much on hydrogen utilization. ಸ್ವಲ್ಪ ದಿನ ಆದಮೇಲೆ ಒಂದು ಸ್ವಲ್ಪ ಲಿಟರೇಚರ್ ಸರ್ವೆ ಎಲ್ಲ ಮಾಡಿ ಆಮೇಲೆ ವರ್ಕ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ವಿ. ಆಕ್ಚುಲಿ ಮಹೇಂದ್ರ ಅದು ಕನ್ಸಲ್ಟೆನ್ಸಿ ವರ್ಕ್ ಮಾಡ್ತಾ ಮಾಡ್ತಾ ಎಷ್ಟು ಇದಾಯ್ತು ಅಂದ್ರೆ ಈವನ್ ವರ್ಲ್ಡ್ ಹೈಡ್ರೋಜನ್ ಎನರ್ಜಿ ಒಂದು ಕಾನ್ಫರೆನ್ಸ್ ಮಾಡಿದ್ವಿ. ಪ್ಲಸ್ ಇದರಿಂದ ಟರ್ಕಿಯಿಂದ ಒಬ್ಬ ಕನ್ಸಲ್ಟೆಂಟ್ ಪಾರ್ಟ್ನರ್ ಆಗಿ IIT ಡೆಲ್ಲಿ ಮತ್ತೆ ಮಹೇಂದ್ರ ಮತ್ತೆ ಮಿನಿಸ್ಟ್ರಿ ಅವ್ರ ಜೊತೆಗೂಡಿ ಈ ನಂದು ವರ್ಕ್ ಏನಿತ್ತು ಅದನ್ನ ಮುಂದೆ ತಗೊಂಡು ಅಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗಿದ್ದು. ಆಗ ಅಂದ್ರೆ 2006 ಅಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಇಸ್ ನಾಟ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ ಎ ಆಟೋ ಫೀಲ್ ಬಿಕಾಸ್ ಆಫ್ ಇಟ್ಸ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆರ್ ಡಿಸ್ಅಡ್ವಾಂಟೇಜಸ್. ಬಟ್ ಈಗ ಪ್ರಸ್ತುತ ಸರ್ಕಾರ ಗವರ್ಮೆಂಟ್ ಆಫ್ ಇಂಡಿಯಾ it is giving more importance to hydrogen utilization or pure hydrogen because of many reasons. Already Dr. Santosh has told the Paris Agreement. So 2015 ರಲ್ಲಿ ಏನು ಪ್ಯಾರಿಸ್ ಅಗ್ರಿಮೆಂಟ್ ಆಯಿತು, ಎಲ್ಲ ವರ್ಲ್ಡ್ನ ಲೀಡರ್ಸ್ ಎಲ್ಲ ಮೀಟ್ ಮಾಡಿ ಒಂದು ಡಿಸೈಡ್ ಮಾಡಿದ್ರು ಹೌ ಟು ರೆಡ್ಯೂಸ್ ದಿ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್, ಓಕೆ, ಆರ್ ಕಾರ್ಬನ್ ಕಂಟೆಂಟ್ ಇನ್ ದಿ ಅಟ್ಮಾಸ್ಫಿಯರ್. With respect to that, ಎಲ್ಲ ಗೌರ್ಮೆಂಟ್ ಈವನ್ ಡೆವಲಪ್ಡ್ ಆರ್ ಡೆವಲಪಿಂಗ್ ಕಂಟ್ರೀಸ್ ಒಂದು ನಿರ್ಧಾರಕ್ಕೆ ಬಂದು we have to go for clean fuel. Okay, clean fuel is nothing but hydrogen. Because if you take any fossil fuels like petrol, diesel, it consists carbon. And the carbon ಇರೋದ್ರಿಂದ ಆಕ್ಸಿಜನ್ ಕಂಬಷನ್ ಆದಾಗ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಅಥವಾ ಕಾರ್ಬನ್ ಮಾನಾಕ್ಸೈಡ್ ರಿಲೀಸ್ ಆಗ್ತದೆ. ಅದು ನಮ್ಮ ಒಂದು ಪರಿಸರಕ್ಕೆ ಎಫೆಕ್ಟ್ ಆಗ್ತದೆ. ಅದನ್ನ ಗಮನದಲ್ಲಿ ಇಟ್ಕೊಂಡು ಹೈಡ್ರೋಜನ್ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿದ್ದಾರೆ. ಸೊ ನಾವು ಪ್ರೆಸೆಂಟ್ ಗವರ್ಮೆಂಟ್ ಪಾಲಿಸೀಸ್ ಮಾಡಿದ್ದಾರೆ. ಆ ಪಾಲಿಸೀಸ್ ಇಟ್ ವಿಲ್ ಹೆಲ್ಪ್ ಇನ್ ಇಂಟ್ರೊಡ್ಯೂಸಿಂಗ್ ಪ್ಯೂರ್ ಹೈಡ್ರೋಜನ್. But how to introduce in automobile sector? So Dr. Santosh already ಹೇಳಿದ್ದಾರೆ ಏನಂದ್ರೆ ಈಗಿನ ಒಂದು ಕಂಡೀಷನ್ ನಲ್ಲಿ ಒಂದು ಆಟೋಮೊಬೈಲ್ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರರ್ ಆಗಲಿ ಅಥವಾ ಕಸ್ಟಮರ್ ಆಗಲಿ ದೇ ಆರ್ inclined towards electric vehicles. There are many advantages and disadvantages. The intention of introducing electric vehicle is just to reduce the emission at the utilization area, that is in urban areas. But again, electric vehicle, we need electricity. If electricity is produced from renewable energy, that is solar energy or wind energy, it will be useful. That is, we can say emission-free vehicle. But if you take electricity from fossil fuels, that is a thermal power plant and other plants, then we cannot say hydrogen is not electric vehicle is a clean, zero emission vehicle. Because for producing electricity, we are burning carbon. May not be burning in urban area, but it will be burnt in power plants, maybe 500 kilometers away from this one. Finally, the carbon emissions are added to the atmosphere. So, to avoid that one, we can use hydrogen. Again, hydrogen production I'm going to highlight. Storage also I'm going to highlight. Initially, actually, I could not I mean, I try to give all the information related to the hydrogen utilization in the spark ignition engine, including diesel. If you have any specific queries, maybe you can ask anytime. So I'll start with the basic things. Why we are doing alternative research, or why we are looking for alternative technology, just to focusing on energy. Because most of the countries, that is, whether you take a developed country like US, China, and European countries, they have rich in energy, maybe in different form. Okay, in Indian context, you know, petrol nearly 70 to 80% fuel is imported from the other countries, and we are spending huge money on that. So when we spend huge money on that, so our economy also fluctuating, because the prices of the fuel again depends on the country where, I mean, source country, I mean, where we are getting from the source. So GDP is fluctuating. To avoid this one, generally what we are doing, our government is doing, why can't we generate our own fuel, or why can't we dependent on our own energy? So you might have seen the renewable energy research activities increasing day by day, including with respect to transportation, hydrogen fuel activities. It may be a production, or it may be a storage, or it may be utilization. So right now I'm focusing on the transportation, that is automobile engines, how hydrogen fuel can be used as an alternative fuel. Okay. So starting from this, so whenever we do the research, that is ಒಂದು ಸಂಶೋಧನೆ ಮಾಡುವಾಗ with ಎನರ್ಜಿ ಬಗ್ಗೆ ನೀವು ಅದರದ ಎಫಿಷಿಯನ್ಸಿ ಹೇಗೆ ಇಂಪ್ರೂವ್ ಮಾಡೋದು ಅಥವಾ ಎಮಿಷನ್ಸ್ ಹೇಗೆ ಕಡಿಮೆ ಮಾಡೋದು ಅದ್ರ ಬಗ್ಗೆ ನಾವು ಫೋಕಸ್ ಮಾಡ್ತೀವಿ. ದಟ್ ಇಸ್ ಹೌ ಟು ಇಂಪ್ರೂವ್ ದಿ ಎಫಿಷಿಯನ್ಸಿ ಆಫ್ ದಿ ಡಿವೈಸ್ ಆರ್ ಹೌ ಟು ರಿಡ್ಯೂಸ್ ದಿ ಎಮಿಷನ್ಸ್. ಸೊ ನಾವು ಮೆಕ್ಯಾನಿಕಲ್ ಇಂಜಿನಿಯರ್ ಆಗಿ ನಾವು ಯಾವುದೇ ಒಂದು ಯಂತ್ರ ಅಥವಾ ಡಿವೈಸ್ ಡಿಸೈನ್ ಮಾಡಿದಾಗ ಅದರದ್ದು ಎಫಿಷಿಯನ್ಸಿ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಈಗ ಅಂದ್ರೆ 20 ವರ್ಷಗಳ ಹಿಂದೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಆಗ 1 ಲೀಟರ್ ಪೆಟ್ರೋಲ್ಗೆ 8 ಕಿಲೋಮೀಟರ್ ಬರ್ತಾ ಇತ್ತು, ಈಗ 15, 16 ಅಥವಾ 20 ಕಿಲೋಮೀಟರ್ ಬರ್ತದೆ. ಯಾಕೆ ಅಂದ್ರೆ ವಿ ಹ್ಯಾವ್ ಇಂಟ್ರೊಡ್ಯೂಸ್ ನ್ಯೂ ಟೆಕ್ನಾಲಜೀಸ್, ಹೊಸ ಟೆಕ್ನಾಲಜಿ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿ ಅದರದ ಎಫಿಷಿಯನ್ಸಿ ಇಂಪ್ರೂವ್ ಆಗಿದೆ, ಅದಲ್ಲದೆ ಅದರದ ಎಮಿಷನ್ಸ್ ಕೂಡ ಇಂಪ್ರೂವ್ ಆಗಿದೆ. ಸೊ these are all the basic things. Just if you have any doubt with respect to the basics, you can ask me. ಈ IC engine is ಹೊಸ ಟೆಕ್ನಾಲಜಿ ಅಲ್ಲ. Feedback effect, or you generate electricity, even a small amount of electricity that can be fed back to the battery. So the overall efficiency of the engine will increase. So what I want to say is, compared to 30-40 years, nowadays due to this new technologies, the overall efficiency of the engine is increased, so that finally we can save the energy. Maybe I'll come back to you with this. Yeah. Generally, nowadays, why we worrying about alternative fuel is, so the people, I mean, the population is increasing day by day. So maybe you can see this slide. So maybe after 15 years, after 15 years, the population may reach to 9 billion, 900 crores. Right now, approximately 600 crores. That's the one reason we have to look for the energy. Whatever energy is available, we have to use effectively. That's the one reason. And you can see the population located in a different continent. So if you compare Asian continent, nearly 50% or 75% of the population located in Asian continent, whether you take India, China, or Pakistan. So the most of the population are located in Asian continent and remaining maybe in other continents. So when people are there, finally we are moving towards the comfort zone. So we need energy. Okay? That's one reason. Where Dr. Santosh already explained about some of the information. This I'll skip. Okay. Energy demand by sector, electricity, industrial, transportation, and commercial. So the energy demand. So we are mainly focusing on the transportation. Even you can observe gradually it is increasing, maybe because of introducing new technology. This is the alternative fuels used in this is the different types of fuel and different areas. How the energy consumption is increasing every year. This is with respect to the introduction of the fuel. You can see including hybrid and etc. So initially, before EV, the hybrid vehicles have been introduced. So the thermal efficiency gradually increased. But again, we are in a confusion state whether we have to continue with the electric vehicle or we have to continue with IC engine. But as of today, the IC engine will exist another 50 to 60 years. Okay? Why means, there is one more, I'm going to highlight the fuel cell. The technology is going to come. The fuel cell technology is giving better thermal efficiency. That is compared to IC engine, compared to electric vehicle, the fuel cell technology will give better thermal efficiency. So overall efficiency. So because of that reason, maybe new technology, that the fuel cell technology will come. It will take over all these technologies, but we have to wait. So this is with respect to the type of fuel, and nowadays with respect to the diesel engine, we are looking for the alternative fuel. That is, as I said, how to reduce the import fuel, that is maybe petrol or diesel. So with respect to this, that is with respect to compression ignition engine, the biodiesel can be used as an alternative fuel or substitute. We can do the substitution. That's one thing. And with respect to the petrol, nowadays ethanol is used as a substitution. Okay, so that is the one thing. So you can see the how transportation sector is increasing every year. So maybe after 2040, so 65% demand growth will be there. Okay, so when transportation growth is there, obviously we need energy, and right now we are depending on the fossil fuel. So we have to look for the alternative fuel for the fossil fuel. And obviously, when we burn the fossil fuel, the emissions will be there because it's made up of hydrocarbon. And maybe the new technology, that is, even the technologies has been introduced in fuels also. Okay, when you take maybe 15 to 20 years back, the petrol had a lead content, but now it is reduced. Even the sulfur content is also reduced a lot. That's the one research is happening related to the fossil fuel. These are all the data. Maybe Santosh will give more details on this. So, some information. Yeah. Now I'll give more information on the hydrogen. How hydrogen can be used in existing spark ignition engine or compression ignition engine. So what technology can be adopted or can be modified in the existing engine? Just I'll give information. If you have any doubt, you can ask me. And this is the physical characteristic or the characteristics of hydrogen. You can observe. Generally, when you take any substance, hydrogen will be present. But only thing is, like crude oil, when you take out crude oil from the earth after processing the refinery, so we will get petrol, diesel, kerosene, and etc. But hydrogen is not available freely. It's always combined with another element. That is one disadvantage. But other physical properties are you can observe. So to get pure hydrogen, so we need some another energy. Okay, that is electricity, or we may require another type of energy. So the cost is very high right now. Maybe in future it will come down, and it has the lowest energy density of any energy carrier. That is, for example, when you take a petrol per 1 liter, maybe 47 or 45,000 kilojoules per kg, whereas hydrogen is very less in terms of gaseous form. If you convert into liquid form, it is very high, 3 times or 4 times higher than that. So what I want to say is the density of hydrogen is 0.08, whereas density of liquid fuel like petrol or diesel, it will be around 850 or some kg per meter cube. So that's a one problem. And as per this one, I can say it's hydrogen is a renewable energy. Okay. If you use solar or wind energy for hydrogen production, because if you see this, if you take a water as a source and you can split water into H2 and oxygen, hydrogen can be stored or oxygen can be added to the atmosphere. So we can use in existing spark ignition engine or fuel cell. We can observe after combustion, again the product will be water, again you can recirculate. Only thing is how we are converting H2O into hydrogen and this one. That is an important thing. The primary energy. So maybe Santosh also will give you some information, but I'll highlight all these three things: production, storage, and utilization. Because when you introduce any fuel, whether it may be LPG gas or CNG gas, the properties are very important thing, and it should be environmental friendly. Maybe some you ask your parents when LPG gas was introduced, maybe 30, 40 years back, people were hesitant to use LPG gas because maybe 100% technology was not available or safety precautions were not taken. Some explosion or taken. The safety precautions are taken. New technologies have been introduced. Similar way, when we introduce hydrogen as an alternative fuel for fossil fuels, so important thing is storage, and the first part is the production. How to produce hydrogen? Because till today we have experienced with electrolysis of water. That is, in school days we have studied how to convert water into hydrogen and oxygen. That we studied, but only thing is we are not taught how much energy consumption or the cost is involved in the technology. But right now, many technologies are available for hydrogen production, and the many technologies are available for storage and utilization. Again, the research is started and started with maybe this one. Okay. I see. So first, when you take hydrogen production, there are many technologies. The second one already I explained. Anyway, some slides are there. With respect to steam reforming or steam methane reforming, there is an existing technology for hydrogen production at larger quantities. When I was in Delhi, so maybe IOC they started introducing this technology, that is converting CNG gas to hydrogen. And they started using hydrogen along with the CNG. Generally, they called as ethane fuel. That is 85% of CNG gas and remaining 15% hydrogen. 85% CNG and 15% hydrogen. So ethane gas they introduced, and hydrogen come from methane. Okay. Second, electrolysis method, renewable energy from biomass, direct thermal decomposition of water, and nuclear energy. These two technologies still at laboratory condition, because when you use nuclear energy, maybe the source is also an important thing, and the technology is also still at laboratory or restricted condition. Second one, last but one, here direct thermal decomposition of water. Water can be split into H2 and oxygen. Again, we need at higher temperature, maybe 2500 degree. So, if you maintain water at the higher temperature, it will split it into hydrogen and oxygen. But again, 2500 means we need primary energy, and again, technology is at a laboratory condition. These three are popular and extensively used worldwide. Whether you take steam methane reforming method, or electrolysis of water, or including pyrolysis or renewable energy using the pyrolysis method. So it's a simple method. That is you can ask me a question: why CNG cannot be used directly? As I said, CNG consists of carbon. You can observe CH4. So when carbon burns, carbon dioxide or carbon monoxide will be there. Due to carbon dissociation of this one, the overall efficiency of the engine may come down. Instead of using CNG gas, we can convert into hydrogen. Okay, using steam reforming or steam methane reforming method. Using CNG gas in presence of water, in presence of high temperature, and in presence of catalyst, maybe nickel or chromium. So the reaction will happen, and finally hydrogen will be produced. Some impurities will be there that it can be purified, and it can be used as in application. This is a simple layout of the plant. So you can observe steam and the hydrocarbon fuel is taken, including CNG. Yeah. So at high temperature and catalyst presence, so hydrogen can be produced. Okay. So this is a simple method available in the market. Advantages, again, when CNG is available, so we can supply in terms of in pipeline method, or even we can place the plant nearer to the wherever CNG gas is available. That's the one advantage. Most, presently cost efficient. But only thing is the finite resources. That is, CNG is available at some limited places, including in Indian context, maybe Northeast or Odisha. CNG gases are available in plenty. But right now we are focusing on the direct utilization. Second, rising natural prices. So that is included in the cost of the hydrogen. So this already you are all familiar in school days. Even projects, small projects. So water can be used as a source, using electricity as a one, primary energy, hydrogen, and oxygen can be split. Even with respect to this, a lot of research is happening in this, because how to reduce the electricity or the cost of the electricity produced from renewable energy. So the debate is going on with respect to this. But in Indian context, we are mainly depending on the electrolysis of water, because hydrogen can be used for other applications, including welding and other applications in a space purpose. Advantage: there is no carbon dioxide, because the source is water. So after splitting, only H2 will be there, no carbon dioxide compared to the steam methane reforming method. Disadvantage, expensive because the primary energy used as it helps. So, with respect to the worldwide, this is how it stands. Natural gas is around 48% energy is produced. The hydrogen is produced from the natural steam methane reforming method and from the refineries, coal and electrolysis. So as I said, countries like in India, we are mainly depending on this. But nowadays we are moving towards the steam methane reforming method. So because the natural gases resources are we are finding and we are trying to introduce steam methane reforming method. Okay. So after producing hydrogen, we have to transport. So with respect to the properties, the physical or chemical properties, the density of the hydrogen is very, very less. Okay, that is compared to air, 10 times lesser. So that is 0.08 kg per meter cube. So with respect to that, it is stored in a different form. So including the compressed form or liquid, cryogenic condition or metal hybrid condition. So here you can see the compressed gas in high pressure cylinders. You might have seen in welding shops or including. It is similar to the LPG or CNG cylinders. Only thing is because of density, it is stored at a high pressure compared to CNG or LPG. It's stored at a high pressure, maybe 180 bar or 200 bar. And nowadays we are changing. Material also changed. So from steel to reinforced, even we can go up to 700 bars. So you know, when 700 governments, if it explodes, disaster will be there. But the technology is available and it will withstand with high pressure. There are two types of cylinder, type 10 and type 4, and we can store up to 700 bar. This is our technology, liquid hydrogen, generally used for space application as well as Indian context. Only in ISRO they are working. Even Tata Motors, they started doing research on this, but they could not produce for public. But it is at laboratory condition. A lot of research is happening related to the liquid hydrogen utilization in ICU. Thing is, so if you want to make a liquid hydrogen, the temperature you have to maintain at negative condition. Okay, so it means that you have to use cryogenic storage system, and then only the gaseous form to liquid form to become nuclear. So for this, we require a lot of energy again. The third method of this method is very less compared to other things because the hydrogen can be stored at a different material and hydrogen can be released when the temperature is maintained at this temperature, that is 100 to 120 degrees centigrade. So, but initially if you want to maintain 120, then you have to burn fossil fuel, petrol or diesel. Then the exhaust gas or heat can be supplied to the metal so that the metal will release hydrogen and that released hydrogen can be fed back to ICTE. Okay, a lot of research is happening in Indian context. Only BHU is working on this area, and but the ministry has given a lot of funding. They introduce more devices, but they could not make popular because of overall efficiency, very less compared to other. So we are all focusing on this part nowadays. Okay? So hydrogen fuel in alternative fuel of the extension. So you can observe similar slide, but here I could have introduced or Dr. Abdul Kalam also, because in his book in 2020 Vision, even he also given the importance to the water. It can or hydrogen. Hydrogen can improve the our GDP and etc. So, with respect to this international level, you can observe in 1876, Jules Verne has told one day petrol will be the future fuel. He realized, and today we are doing this. And even George Bush also told, and Dr. Abdul Kalam sir also told. So we are depending on the naturally available fuel. So this already highlighted. Once the hydrogen is produced, stored, and how to utilization. So with respect to the existing technology, we are all familiar with IC engines as a PW. 150 years of history is there with respect to the IC engine, and the fuel technology is there in our laboratory and automobile manufacturers side, but maybe one day to come. So when we compare both fuel cell technology and IC engine, just I will explain some advantages and disadvantages we can observe here. So with respect to the IC engine, the combustion will be there. So that's one part. So when combustion is involved, there is a piston cylinder arrangement. So the moving will be there. There are disadvantages, uh, smaller inside, shorter fuel refueling. So other things you can see, uh, eliminate greenhouse gases with respect to the hydrogen fuel IC engine, and overall efficiency is less compared to fuel cells. As I said, once the fuel cell comes, the efficiency will be more because we are mainly focusing on the efficiency and operate noisy. Here the combustion is involved, the noise will be there, and even vibration will be there. Okay, so the moving parts. So compared to fuel cells and other things, disadvantages, maybe this can be improved. This is a very important thing because whenever you do the research, so we check the properties. Okay. Here, just comparison between gasoline, CNG, and hydrogen. You can have a look. So here the properties are listed and the comparison is made. Why the comparison means we are all pretty familiar with gasoline as a petrol. So when we are replacing hydrogen or when we are using in the spark ignition engine, okay, so you can see the properties. So the first one is the flammability limit. So in petrol engine, I don't know how many of you have done this automatic calculation. So nearly, the spark ignition engine works near to the equivalence ratio, that is 0.9 to 1.1. Mean it should not be too lean or it should not be too rich. The combustion won't be stable. So keeping in that mind, hydrogen even at 0.1 equivalence ratio or 7.1 equivalence ratio, the combustion happens. Mean misfiring won't occur in hydrogen fuel IC engine. So we can expect better combustion here. That's one advantage. The second advantage, you can see the burning velocity or flammability. Once the spark comes, how fast the flame is moving. That is a very important thing. So when we compare these two, gasoline or CNG and so on, we can observe 1.85 meter per second. That is, the combustion will be very fast. So because of that reason, we can expect better thermal combustion. Combustion efficiency. That is the advantage of hydrogen. Next, the octane number. Generally, when we, I don't know how many people have observed when you visit filling station, there are two types of petrols are available or two types of diesels are available. The price also generally varies. Why means the octane number generally. Okay, so here it is 86 to 93 or so. So if higher octane number is there, they charge very high. So and the advantage is better combustion, better mileage. Okay, so generally if the octane number is very high, it is used for racing cars and other things. But nowadays, the high-end vehicles like bikes, they are using a higher octane number. Similar way, when we compare octane number of gasoline and hydrogen, you can observe what is the advantage? It is it mainly affect on the compression ratio. So if better octane number is there, we can increase the compression ratio. So already I told you as per the thermodynamic point of view, the thermal efficiency is mainly depends on the compression ratio. So because of higher octane number, higher compression ratio, better thermal efficiency. You can see the advantages. But there will be disadvantages. As I told you, when you introduce any fuel, it has got disadvantages, but we should know how to convert disadvantages to advantage. So here, one is the stoichiometric volume. You can observe 29.53 compared to 2%. That is, when you take 100 cc cylinder, only 2 to 3% volume is filled with petrol, whereas hydrogen, so nearly 30% volume is filled with hydrogen and remaining percent is oxygen. Initially, I told you, if you want more power, then we have to add more energy. I mean more fuel. If you want to add more fuel, we need more air. So how to increase this? Because we are adding energy plus air, 30% energy, 30% air. So the power output will be less. So how to improve? Just we go for the turbocharger or supercharging method, so that we can add more fuel and we can burn more and this one. So there are technologies available. Second one, minimum ignition energy. Because of this reason, the backfiring or pre-ignition problem will come. Okay, backfiring means maybe if the cylinder is hot or the spark plug is hot, the combustion is initiated itself without waiting for the spark plug. So spark from the spark plug. So this is a disadvantage. How to improve? Just maybe we can improve the cooling method, or we can go for the electronic ignition method like laser ignition or this one. We can or change the energy input to the charge, so that the combustion or the backfiring can be avoided. So next is quenching distance. You can see when burning happens, the flame is moving towards the cylinder wall. The distance between the cylinder wall and the flame, here in this case, you can observe maybe 2 mm. The flame is coming and it stops here. Why it stops? Because the flame will release the heat energy, and heat energy will be transferred to the wall and it extinguishes, or it stops here. Whereas in hydrogen, you can observe 0.64 mm. Still it will go nearer to the wall. It means that if flame stops before, with respect to this 2 mm, lot of unburnt fuel will be there. That is, fuel will be present. That will be very by introducing some method, so that the overall efficiency can be improved compared to the gasoline. So the disadvantages are highlighted here, but nowadays we have overcome from this, including flashback or backfiring, re-ignition problem, rate of pressurized. So here backfire, even petrol engine also you might have experienced. Early morning when we start the engine, so before sometime the flame is initiated, and the combustion takes place in the inlet manifold from the, maybe because of flame is coming towards the carburetor or injector side, that is the backfiring. And even pre-ignition, already I told you, the charge won't wait for the spark from the spark plug. So the combustion is initiated, maybe heat will be present, or the minimum heat energy present in the spark plug or the cylinder walls. So that's one. Rate of pressure rise because of burning burning velocity, the rate of pressure rise will be very high. That is, combustion takes place very fast, and the pressure will rise very fast. But we can adjust according to our requirement. That is, maybe I'll tell you. Yeah, this is one important thing as per my topic, dual fuel engine. Okay, how hydrogen can be mixed with other fuel. Whether we can mix or what modification we have to do, that's something. So here you can see the mean hydrogen. But today we are all moving from this to this, that is neat hydrogen operation, because even gasoline direct injection, gasoline direct injection technology is available right now, and we can move to the direct injection system also. So other things, hydrogen supplement, that is a dual fuel engine or dual fuel mode with respect to the diesel engine. Okay, CA engine and SI engine. So with respect to CA engine, we can replace the diesel with we can use as a DL as a pilot fuel. That is, we can initiate the combustion with the diesel, and we can add the hydrogen, that was dual fuel engine. And even here also, we can add petrol along with the hydrogen. You can see CNG with hydrogen, LPG with hydrogen in spark ignition engine. So when research is started with the carbonation system, because with respect to the spark ignition engine, we know how to use a carburetor, there is a fuel supply system. And then we have moved to the injection where we stand today. So again, the injection system are depending upon the injection pressure or depending upon the position of the injector. So we can classify into three types: inlet manifold injection system, inlet port injection system, and in-cylinder injection. Here you can observe low pressure or high pressure. But right now, we are facing problem with this direct injection system. Again, a lot of research is happening with respect to the material or designing of the injector, direct injection system. So this other technologies already introduced and explored in the laboratory level. Many automobile manufacturers working on this, and they produce vehicles, and even they a lot of research is happening in India in context. Okay. This thing. This is what I did at IIT Delhi. So this is a Mahindra sponsored project. So I could able to, or we could able to develop the hydrogen fueled spark ignition engine, placed in the three-wheeler, and it was running in the campus, IIT campus. Later, it was taken to another level because the power output was very less, and it is taken to higher level by changing the compression ratio and other things. And even it is extended to the multi-cylinder engine. Right now, in IIT Delhi as well as in Mahindra, they have this technology. If government permits, maybe hydrogen fueled vehicles will come. Yeah. Now, with respect to the whether you take petrol, then generally what we do, we compare the performance comparing with other fuel. So you can see when you take an engine, if you vary speed from maybe ideal speed to higher speed, how the power will vary. So with respect to the petrol, you can observe the power will be very high. and hydrogen it is less. Why means already in property table I explained the density of the fuel is very less and it occupies more space, and because of that energy is also will be less. So the power output will be very less. So it can be improved by adding or by supercharger or turbocharger. We can go up to or above petrol engine. That is the advantage of new technology. So this is the volumetric efficiency. So the volumetric efficiency of the petrol engine, and I can also, sorry, thermal efficiency. So the thermal efficiency of the hydrogen is higher compared to gasoline, because in property table I told you the burning velocity affects on the combustion, and because of higher burning velocity, combustion will be fast. That is, whatever fuel we are feeding, the input energy will be converted into mechanical energy in this aspect compared to this. This is a break specific energy consumption, or generally we if we take single fuel, we go for fuel consumption, and that when we compare two different fuel, we compare the energy. So here for producing 1 kilowatt hour, the hydrogen consumption will be less compared to gasoline. That is petrol. That is the advantage of hydrogen. Maybe because of the properties, like burning velocity. Next comes volumetric efficiency. This is a disadvantage. In the first slide, the brake power is less because of this. It occupies or air input or air input to the cylinder will be less, and overall volumetric efficiency will be less for hydrogen compared to here. This is with respect to the emission. This is one more maybe disadvantage. If you move towards the higher equivalence ratio, that is, if you add more and more fuel, the combustion will be better. But only thing is the NOx emission will be more, because the temperature, the combustion temperature increases, and we know because of higher temperature, NOx also increasing from low ppm to higher ppm. So how to avoid? We may have to work with a very low equivalence ratio so that NOx emission can be reduced. But only thing is, if you work with a low equivalence ratio, then the power output will be less. So the conclusion, you can see when you take the method production, steam reforming method is suitable. Okay. For pure hydrogen, electrolysis method for less cost, renewable energy. And with this, from my experience, we can avoid abnormal combustion, we can avoid mixture, and we can improve the power output, even we can reduce the NOx emission, etc., by introducing or by taking precautions. Okay. So what I want to say is the existing technology can be used for alternative fuel for the hydrogen. So I'll stop here. If you have any queries, please, from basic to research. Maybe few questions. Student point of view, maybe thermodynamics or combustion or alternative fuels. Not only hydrogen, you can ask questions related to alternative fuels.
NOx emission is in the case of blending products. Blending of hydrogen gas.
See, NOx emission, when you take any hydrocarbon fuel, mix with oxygen or combustion atoms, The NOx emission maybe depends on temperature. If the higher temperature is there, NOx emission also gradually increases. So we have to reduce NOx emission. There are two methods. One is by in the combustion we can reduce the NOx emission, or after the combustion. That is during combustion by supplying the EGR, exhaust gas recirculation, or water injection. Or after combustion means in exhaust pipe we are adopting the ACI technology.
Suppose 100% hydrogen is used, is there any chances of NO expansion?
Again, one slide I explained the NOx emission gradually increases from at a lower equivalence ratio, maybe 0.5, 0.6, because we are adding less fuel. The combustion temperature will be less. So NOx emission will be less. But when you increase the hydrogen percentage, heat hydrogen only, but when you increase the hydrogen, the combustion temperature gradually increases. With respect to the NOx also increases. Any next? Thermodynamic point of view. Thermodynamics is a very good subject. Please read, because our economy is mainly depends on energy, and energy depends on our studies or introduction of the or introducing the new technology. Please focus on thermodynamics. We can do some good things.
Yeah, petrol engine will have a petrol tank, and the signal will be going from the tank into the cylinder, the combustion will take place. What about the construction of the engine working with hydrogen?
See, when you work with atmospheric pressure or below atmospheric pressure, maybe without any pump, petrol I'm talking. So without any pump, the carburetor will take care of fuel supply. With respect to hydrogen, we may have to go for some slightly improved technology, because hydrogen is stored at high pressure, around 200 bar. Proper regulation should be there. Okay, because in inlet manifold, maybe the pressure will drop below atmospheric pressure. We have to match with that, and we have to inject the hydrogen. Okay, the injector will maybe with respect to manifold injection, the injection pressure will be around 2 bar or 3 bar up to 7 bar. But if you go beyond that, there will be backfiring. Okay, it should be near to atmospheric pressure. Okay. And when we move to the direct injection system, even petrol also we need pump, because we have to inject the fuel with high pressure. Okay, even hydrogen we need some fuel.
Why does hydrogen like fuel induction rather than fuel injection?
Induction, that is, the fuel is added to the air. The pressure will be same. Okay. Whereas injection, the injection pressure will be more than the atmosphere pressure, 8 bar, 10 bar. But when you use induction method, there will be backfiring, disadvantages with that, and also there will be power output will be very less. That's a disadvantage. Any other things? No more questions. Thank you.
I would like to thank Dr. Kumar Jain, Professor, National Institute of Technology, Karnataka, for an insightful session. Thank you, sir. May I request Dean Academics, Dr. P. Mahabaleshwarappa, to present a memento to our speaker as a token of love and gratitude. Thank you, sir. We will now have a short break. kindly assemble back at 3:15 for the next session.
Welcome back to the afternoon session. Actually, in the morning, we discussed about that is importance of the energy, right? So it is an very fundamental things that we should know because the topic is on utilization of hydrogen, that is towards a greener environment. So when the production and utilization have more challenges in case of an hydrogen, then you might ask a question like, then why we have to use hydrogen when oil or maybe coal or maybe any other energy sources are abundantly available? Then what is the use of using a hydrogen? With investing more money on R&Ds or developing a new technology. So for that reason, in the morning session, I gave an introduction about the demand of the energy, what is the adverse effect of burning and fossil fuels, that is hydrocarbon fuels, maybe it's a coal or maybe it's a oil or maybe gas. Okay. So and how this geopolitics plays a very important role in the development of economy. So our entire GDP it depends upon the energy, what we consume, what we purchase from the other countries. So almost all the developed countries will try to control other countries in the name of energy. Either they put the restriction in transferring the technology, either they avoid or create an interrupt in the supply chain of the energy, maybe in terms of fossil fuels, right? But when we independent on the use of energy, when we try to use more renewable energy sources for our energy needs, then the sustainability will improve and also will directly contribute for the development of our GDP and for the per capita income. So when the money is the utilization and the fuel is reduced, so that money can be redirected for the development of education. So in our GDP or maybe in our budget, the contribution for the education is not more than 10%. Even the 10% is a huge money. We are not spending not more than 5 to 10% of money on education. But still, we have around more than 50 institutes in India that has an international rankings within 500. So that is because of our talent only, because of our goals, whatever our things, the motivations behind that. So we know what we want at the end. Okay. So now we have to see that why the hydrogen energy is needed. So okay, to solve all these fundamental problems associated with the energy, so then it is very important thing is that we should be sustainable. Sustainability is possible if you are using a hydrogen. Then why hydrogen? So hydrogen is the most abundantly available thing. It is most abundantly available. So it is the lightest element on the table, that is periodic table, and it contains one proton and one neutron, and it exists at a lower concentrations in the atmosphere. And combustion with other elements may form the compounds. For example, hydrogen don't exist alone in the nature. It is always combined with any one of this element. Maybe If it is combined with O2, it's going to form an H2O. It combined with C, it's going to get formed an hydrocarbon fuel. It combines with nitrogen, it's going to get formed. I mean, if it is going to get combined with N, it's going to get formed nitrogen, oxide, trioxide, and whatever. Okay. So this is hydrogen, and we should know the history of the hydrogen. Around in 1766, and a scientist by Henry Cavendish identified the hydrogen as one of the flammable gas. So we know that the nitrogen was there, but its characteristics, its nature, we wouldn't know that before this 1766. The Henry Cavendish identified nitrogen was one of the flammable gas, and it can be used for the combustion purpose. And later in the 19th century, what happened? So this hydrogen gas is used as a carrier gas. That means for the balloons carrier or whatever. So zip lines, they are abundantly used in the zip lines. But what happens in 1934, I think, 1937, a disaster happened that we call it as a Hindenburg disaster. So hydrogen gas was catch a flame, and it started to burn and makes a big disaster in the zip lines. So from that onwards, and for the usage of the hydrogen, the government puts in more regulation for the usage of the hydrogen. So from that day onwards, we think like okay, hydrogen utilization is very difficult because its nature, high flammability, and its density is too low. So we are neglecting the use of the hydrogen. And also one of the reasons is that so during that time, the elements, whatever the fossil fuels are abundantly available. What are these OPEC nations? OPEC nations in the sense those who are selling the highest to the other countries, the MEDA group, and then we call it as OPEC nations. Those OPEC nations are selling the oils to the entire world with low prices, right? So from that, they won't get any obstacles for using the energy from the fossil fuels. But later, as greenhouse gas emissions and Paris Agreement was put restrictions on the use of these fossil fuels. Later, we think in a different way to utilize the renewable energies. So later, what happens? It is hydrogen is utilized, abundantly utilized in industries for various processing industries, and it is one of the important commodity, or maybe is one of the important thing in the fertilization. So we know that Bangalore is a hub for producing the fertilizers. It's a hub for refining process, and it is a also we have a Adani coal power production plant here. So Mangalore has everything, and also the air quality. So when you compare the air quality of Mangalore regions and Bangalore region, both are same. Even with the denser populations in Bangalore, the air quality is similar to Mangalore because here the more industries are there, especially refineries are there, fertilizing preparations of industries are there that producing a more greenhouse gas emissions than any other part. So it is abundantly used for this fertilizing things, and also so in the NASA used this one as an energy source around in 1960s. So these hydrogen fuel cells, they made hydrogen fuel cells, and they used this hydrogen fuel cells as a energy carrier for in the space mission in 1960. So it gives an hint that yes, we can produce the electricity by using the hydrogen, maybe in terms of the fuel cells, also maybe in terms by direct combustions, maybe in a combustion chamber. Not exactly in the direct combustion, I mean IC engines, maybe in by combustion we can produce the heat. So we can see what is the energy systems. We can see that there are the different sources are there. There are the different sources are there. So here maybe the renewable source is there, and nuclear, maybe biomass, maybe different sources are there. From that sources, what we are producing electricity. Then that electricity is utilized to produce the hydrogen. Then the hydrogen is utilized for the various industrial purpose, not for any direct utilization. That is for the transportation purpose or maybe any energy production basis. Maybe in the future it will go like this. So hydrogen can be directly produced from a different sources, and that hydrogen may be a fuel for lighting our houses, maybe for the transportation sectors, and in the future hydrogen plays a very big role in that. Okay, so how these hydrogens are going to get produced? So already in the last session, Dr. Kumar James gave some introduction regarding about productions of the hydrogen. So here I am going to take once again in the brief, that is how these hydrogens are produced in a different methods. So and before that one, we have to know that what are the color codes for hydrogen. So fuel is one, okay. So when for the same fuel, why we have to put more color codes? Yes, it is very important because so hydrogen can be produced from the various sources for the and also whatever the sources also from the renewable sources. So by using those renewable sources, if you produce the hydrogen, then we call it as a green hydrogen, and the code for that hydrogen is the green. So next one is the yellow one. Okay, if the electricity available for the productions of hydrogen is utilized from the solar, we call it as a yellow, because solar, whatever the energy that is produced from the solar will also leave its carbon footprint, because the production of solar panels, so the mining of the raw material required for the production of solar panels also leaves some carbon footprint. So that's why whatever the hydrogen that is produced, we categorize as a yellow by using the solar electricity. So later by using any blue hydrogen, that is natural gas. Yes, natural gas, we know that the combination of natural gas, the major portion of the natural gas is CH4. Yes, from the CH4, by using the CH4, we can be able to produce the hydrogen, right? And during the hydrogen, whatever the carbon that is produced, so that can be captured and utilized, or at least that is captured. So that kind of the production of hydrogen by using a carbon capture and natural gas, we code it as a blue hydrogen. Okay, next one is the gray or black hydrogen. That is, if the carbon produced during the production of hydrogen, if you are not going to store that one, or if you are not going to utilize that one, so then that we call it as a gray hydrogen. And whatever the hydrogen that is produced from the coal gasification, that is syngas. So from that method, if you produce a hydrogen, so then we call it as a black hydrogen, and also without any CO2 capture. So these are the different color codes of the hydrogen. See, yes, European Union made a strict rule on utilizations of hydrogen in the industries. If any industry produced the product, if that industry didn't utilize the hydrogen for their process, the European Union put more tax on that process. So if the industry utilizes an hydrogen for their production, if they put a 10% tax for that one, if they didn't utilize any hydrogen for their process, they put more than 30 to 40% of tax on their production. So if you want to export our products to the European Union, why this? Why they made a rule that? Because due to the Paris Agreement, they want to show their sustainability, they want to show their active involvement for the Paris Agreement. And also they are giving a financial aid for the developing countries for their development, for their energy needs, and also they are involved in the technology transfer. So for that reason, so in almost all the industries in India nowadays, if they want to export their products to the European Union, if the market is there, they have to utilize, they have to use hydrogen at 100%. At any cost, they have to utilize the hydrogen. Maybe it's a grey, maybe it's a black, maybe it's a green, depending on the strength or production capacity. Yes. So in the last week, the Indian government are trying to make a deal with European Unions. That is because the US government put a more tariff on Indian products. We want to search a new market for our Indian products. So we made a deal. Most probably it is going to get finalized within 1 or 2. Almost all the things are done. Whatever the things are done, but only the technical things are left. So if that gets succeeds, again, a more demand will be rises for the production of hydrogens in the energy sector. Because at any cost, the industries has to use the hydrogen utilization for their productions. So it's our current production. So 98% of approximately, okay, you can say 90 to 95% of our hydrogen production is from the fossil fuels. It may be a like coal, or it may be a natural gas. Only around a small 4 to 5% of hydrogen is producing from the green sources, utilizing the electricity from the either solar, either the wind, or from any other green renewable energy sectors. So it is very important to increase our strengthen on the production of hydrogen in a green hydrogen. So we can see how this hydrogen produces and what are the color codes and what is the carbon footprint that leaves during the production of hydrogen and what is the cost of production of hydrogen. First one, when it comes to the green hydrogen, its production cost involves around $6 to $8. Yes, sorry, $2. If it is a green hydrogen, if it is a completely a green hydrogen without involving any carbon footprint, it costs maybe $2 per kg. If you go as the CO2 capture a zero CO2 capture, and that leads to an increase of the production cost about $10 to $13. And also in similar way, you can see black, grey, the other hydrogen production. The cost may be within $10. If they are going to use and carbon capture technology, maybe the cost is going to get increases. But that reduces the carbon footprint. And also, we don't know that what we are going to do with that captured carbon. So whatever the carbon produced, we are trying to capture and we try, and whatever the captured carbon is there, that is we are going to bury under earth surface. So instead of doing that one, we have to utilize the carbon for the various purposes, and future maybe business or technologies also will get improved in the utilizations of the captured CO2. So what are the properties of the hydrogen? So properties maybe already in the previous session the Kumar sir explained about its properties. So its fundamental properties are low volumetric energy density. Yes, if you store as a liter in terms of in the gaseous form, its energy density is low. But again, if you store the hydrogen in terms of mass, its energy density is increased. And its density of this one is the lightest gas. It's around 0.08 is only there compared to air, it is much lower. And hydrogen absorption by the material, you can see in the figure. So it is the figure, you can see what happens to the absorptions, that is from metal to the due to that absorption, it causes an breaking. That is, and it creates a crack by absorption in the hydrogen. So that's why we should have take more care while storing the hydrogen. So it is so the storage of hydrogen is already well established things are there, but the automotive industries are just waiting for the government rules or government push. Once the government gives an order for the production of hydrogen vehicles, then almost all the technology is there, but they're just waiting for these policies and other things. So and it's a non-toxic, obviously, because only during the production of hydrogen it leaves some CO2, but the utilization of hydrogen is completely non-toxic. It won't produce due to a combustion. Any harmful gases, it won't produce. The byproduct is only a H2O, maybe carbon. So how we are going to produce the hydrogen? Hydrogen is from around 90 to 95%. I already told that around 95% of hydrogen is produced from the fossil fuels. See what are the different methods are there? So different method. The first method is the steam methane reformation method. So it is the most commonly used method for the production of hydrogen because they are extensively depends on the fossil fuels. So we call it as SMR method. So in this, what is this method? So it is widely used in industry for the production. And in the first step, what happens? See, whatever this CH4 is there. So we are using a natural gas for this as a source for the production because it contains most amount. The CH4 is the maximum amount. So when the CH4 reacts with water, what is going to get produces? And H2O plus H2 plus CO is going to get produces. Okay, it's an endothermic reaction. Obviously, we have to provide some energy for the production of hydrogen. It utilizes some amount of energy. In the next step, what is going to get happen? See, whatever the CO that is produced during a reformation process, that can be converted into CO2 by producing an additional amount of H2 also. So right, so you can see that CO plus H2O it becomes a CO2 plus additional
and productions of some H2 is there. It's an so the overall reaction goes like this: CH4. When the CH4 reacts with H2O, it's going to get produces around H2O and some amount of the CO2. So right, the direct CO2 emissions per kg is around up to 12 kg is there. If we are going to utilize the carbon capture technology, maybe we can reduce the production of CO2 and we can count it as a blue hydrogen. If you are not using any carbon capture technology, then we can name it as a grey hydrogen. This next method is that coal gasification. It's also India. India is very dependent on the coal gasification process because the coal is abundantly available in India, and also an exclusive syngas production center is set up by the Indian Oil exclusively for their own hydrogen production center. So some of these oil refinery centers, maybe these whatever this companies from the government, they will install for the market purpose. They installed Indian Oil installed a very big syngas production center. From the syngas, they are going to produce a nitrogen and supply to the various industries through the pipelines. So we can see that the first gasification process goes like this. See the carbon. Obviously, the coal contains a maximum amount of carbon. When the carbon reacts with H2O, it is going to get produces H2. That is, a production of hydrogen is going to get happen plus with some amount of CO. Again, in the next process, we are going to convert that CO into H2 by again reacting with the H2. So hydrogen production from the electrolysis method. So these method, that is coal gasifications, or maybe SMR methods, are completely hydrogen, that is a grey method, or maybe we can term as a blue method. But it leaves some carbon footprint and also it consumes and some energy and also the fossil fuels. But we are highly concentrated on the production of hydrogen without leaving any carbon footprints. But till now it is not yet possible. But one of the methods that we can achieve by using an electrolysis. But compared to an syngas and gas reformation, so it is one of the low CO2 production method, because only we are using electricity for the production of the electrolysis process for the production of hydrogen. So in this electrolysis method, various kinds of electrolysis methods are there. The most advanced methods also developed nowadays, that is to increase the production capacity and also for the purity. So here what happens, obviously we know this electrolysis method, how it works. Cathode, anode is there, exchange of electrons and ions is going to happen, and that leads to the production of hydrogen. So in the next step we are going to see one by one. So the first, the important parts, the important parts of electrolysis are there. Anode will be the cathodes, and electrolyte is one of the important thing in the electrolysis methods, and we have to supply some power for this process, for the breakdown of the H2. Right? So what are the types of electrolysis method? So the alkaline methods, PEM, polymer exchange material, and maybe solid state electrolysis methods are there. So these are some of the important electrolysis methods. So the first one is alkaline method, is one of the oldest method that we follow for the production of hydrogen. So here we can see in the figure, we can see there is an anode and cathode is there. So right, by the supply of external power, what happens? So slowly we can see this in the reaction section. H2O is going to get split up, right? So when the circuit is closed, electron is started to move from anode to cathode, right? So then that leads to the productions of hydroxyl ions, that is OH ions, and also that leads to the production of H2. So by using these methods, we can able to produce the hydrogen with minimum consumption of the electricity. So anode reaction, in anode reaction what happens? The hydroxyl ions is released, like the OH ions. So that is going to get combined, that again that leads to the productions of again oxygen in the anode reaction, and also that leads to the productions of H2O along with the electrons. So these alkaline, whatever this alkaline water electrolysis method is there, it can able to produce oxygen and also hydrogen. In the cathode section, it is able to produce hydrogen, and in the anode section, it can able to produce an oxygen. So next method is that solid state electrolysis method. So here the electrolyte, whatever the electrolyte is one of the important thing in the production in the electrolysis method. Here we are using a solid ceramic kind of an electrolyte. So what it will do?
We can see in the reactions in the cathode reaction, H2O is there. That leads to the supply of an electron from the external source, that is power source, right? That leads to the productions of H2, and along with that one, it leads to the productions of oxygen ions, right? So in the last method, that leads to the productions of OH ions, but here in this process, that leads to the productions of oxygen ions because electron, right? And in the anode reactions, what happens? These O2 reacts with the O2 again is going to get split up, and again it leads to the production of electrons only. So next one is PEM electrolyte method. So here we can see a solid membrane is there. So this is because this is one of the important method. It produces an 99.9% of pure hydrogen, and also it is somewhat complicated and expensive compared to other two methods, right? Here H2 is directly going to split, that leads to the production of H2 plus O2. So in the anode reactions, again H2 is going to get split, O2, and then formation of electrons and formations of this hydrogen ions. So next in the anode reactions, what happens? So again, these hydrogen combines with electron, that leads to the formations of H2, that is production of H2. So that is what is its purity of 99.9% purity is there, and also its efficiency is very high is there. But for the initial investment also huge compared to other two electrolysis methods. So these are the comparison. So electrolytes, maybe working temperature, and what is the dynamic process, H2 purity, and the global integrations. This is some comparison you can see. And history of the hydrogen. The utilizations of the hydrogen, or use of the hydrogen, the production of hydrogen is not at all a new concept. It is very old concept. But why it is not so familiar? So in the 18th century, the usage of the hydrogen started, but in the 21st century also, we felt like that hydrogen is a new concept. The reason is that availability and the type of the usage. Whichever is available freely and abundantly, so only that thing we are interested in using. For example, fossil fuels, ice. Okay, in the olden days, maybe just 10 to 15 years back, the price of the petrol is very less, so it's not more than 50 to 60 rupees. So, and also the diesel was also very less. So we are used to use petrols and diesels in our automobiles, and also government won't care about this emissions and climate change and nothing. But nowadays, emission norms and the policy makers and international pressures, everything made the government to make some policies, utilizations of energy, and they try to concentrate on the greenhouse countries. You can see in the picture. So in 18th century, the inventions of the hydrogen engine started, utilization for hydrogen. But in 1970 it stopped, and from the 1970 to 2000, no activity was there. Slowly in the 2000, again the automotive sectors started and some R&D utilizing the hydrogen. So we can see some MAN company, we know that this is an original equipment manufacturer, the MAN company, that leads to that is they are going to produce so these passenger vehicles, yes, and also some BMW cars, and some other companies are interested in productions of the hydrogen vehicles, and also they sold some few vehicles to the citizens for their R&D purpose. So next in 2020 to present, exactly. So whatever the concept of energy was exactly skipped or maybe changed completely after COVID in 2019, right? So after immediately and EV come into the picture. Before 2019, we don't know what is EV, how it works, and everything. But nowadays, everyone is going to talk about EV, right? So even in Mangalore, if you go to any village side, also you're going to see an EV two-wheelers. Maybe it's Aether, maybe it's Ola, maybe it's anything. So right, immediately the Ola company is just it's a service provider company for booking the vehicles to the long line. But suddenly it is emerged as a production company, an EV vehicle production company. What they did initially, they imported each and every parts from the China and assembled in India and named it as a Ola and sell it. And the government also price it like anything, advertise it like anything, and also give a lot of subsidy to purchase the EV, the taxpayer money. Ultimately, we ended up in Ola. So everyone. So about 1,20,000 we are spending Ola after 3 years, 5 years. So the value of the vehicle is 0. Even though if you sell your vehicles, nobody want to buy that vehicle for 2,000 because main component is the battery. So the battery life is not more than 10 years. Around 60 to 70% of the vehicle cost includes the battery. Once the battery life exhausts, so then the vehicle cost will be 0 after 10 years. So again they are claiming that yes, you can charge easily, no money will going to spend, no cost of the fuel. Within 3 years, whatever they spend money will be leaked. But it is not like that. So you can calculate what is the kilowatts of the power. I mean, what is the power of the battery? What is the energy consumption to charge from 0 to 100%? What is the range it is going to get given? What is the losses occurred during the charging and discharging? That is SOC and DOC, right? And what is the energy? I mean, what is the temperature that is going to get liberated during its operations? How the BMS is contributor for the Paris Agreement. So this is one of the EV category. But still, I am not against the EV. If the EV performs well, if the EV like the battery, whatever the battery is there, if the recycling infrastructure is well developed, and also if we find any again whatever the raw material is required for the battery development, also if it is easily available, then yes, it is one of the important or one of the good technology that may save some CO2, that is on the city sides. And if it is completely chargeable using a renewable, exactly it is one of the fantastic technology. Yes, what are the active patents when it comes to the hydrogen? So about China and Japan have the highest patents, especially China continuously working on the various technologies. So yes, we can fight with China, we can blame China, but when it comes to the technology, yes, we can't able to beat the China. And the working ability of the Chinese people, we can't able to beat them because their working style, working efficiency, and so their thinking level is like. So their thinking level is like the scientific temperament. Whether is educated or uneducated, if anything comes to your mind, you should be think with a scientific temperament. Then only the decision will be good. Otherwise, what happens? What we have ended up like this: 140 crore populations, still depending upon the other nation for everything. For internet, yes, we are depending on the other nations. For food security, yes, we are importing. Energy, yes, we are importing. Clothes, yes, we are importing. Now, every class made by Bangladesh. The entire our industries are shifted from Bangalore to Bangladesh because low workforce. So again, almost all the things we are importing. Automobiles, spare by spare, we are importing and assembling in maybe Toyota, India or somewhere else, and we are selling, made in India, making India. So it won't work. So when we think every thoughts will be on scientific temper, then only we can really make India concept success. Yes. So that we can, if we can find out India, what are the patents filed by India in the hydrogen technology? You can see 1 or 2 patents. So again, okay, why we have to give more importance for the hydrogen? So because of these properties, the properties were well explained by Dr. Kumarji and sir. So I won't take much time on the properties of hydrogen. So it's an carbon content 0, so no production of CO2. Low heating value is high compared to petrol or diesel. Any hydrocarbon fuel density is very low, 0.08, and auto ignition temperature is very high. And then minimum ignition energy requires 585 around. Yes, so it is higher. And quenching distance, it's around a small quenching distance is there. And lambda flame speed is very high compared to petroleum fuels, and flammability limit is very high. So we have around, for example, around 2 to 4 kg of hydrogen. If you store like a 200 to 250 or 300 bar pressure, so it may lead to the blast of entire Turkey or maybe not. So that's why the government had made a rules and strict emission. I mean, the strict regulatory for the storage and utilization of the hydrogen. So hydrogen limits, the storage of hydrogen limits not more than 150 bar. That is with permission. But usually we are going to store the hydrogen with the 70 to 80 bars for industrial applications. Yes. So in the last, ultimately I told that how the hydrogen can be produced with a more greener without utilizing a single thing from the non-renewable source, even though electricity.
So it is still under development. It is not fully developed. It is in the incubation center, that is in the research center. So this is, we know that the concept of photosynthesis. What is the meaning of photosynthesis? So the photosynthesis is that the plants will utilize by using a chlorophyll. It will produces its own food, that is glucose, by using a sun energy. Right? In the similar way, we are using the same concept. Instead of a plant or a leaf or a chlorophyll, we use a catalyst. So that catalyst is going to get activated with the help of the solar energy, then that leads to the production of energy. Right? So this is the one of the technology. It is not a developed. So this technology we call it as a photocatalysis. It is not a photosynthesis, it is a photocatalysis. Catalyst is activated under the sun energy. That leads to the production of hydrogen. So just like what happened, so this catalyst will dissociate H2, the water with H2 and productions of hydrogen and oxygen. Yes. So yes, utilizations of the hydrogen in a engine. It is one of the important concepts. How to, okay, still now we talked about what is the requirement, how we are going to produce, right? But how to utilize this? So this is also part of the theme. How to utilize this one? Especially I am going to concentrate on utilizations of the hydrogen in IC engine. So in IC engine we can use the hydrogen in two ways: the first generation and second generation. Right? So the injection of hydrogen into the inlet manifold. So that is the first generation concept. Second generation concept is that injection of hydrogen directly into the combustion chamber. So here you can see that. So this entire setup shows and the first generation concept. This is our own setup only. So I worked on this setup. So we designed this whole setup. The induction of hydrogen into the intake manifold. The reason is that we don't have the hydrogen supply injector, and also we don't have the proper ECU for the supply of the hydrogen. So for that reason, we choose a first generation method to prove the concept. Yes, hydrogen works well, and only we can able to supply around 15% of energy. So for example, for the production of some amount of energy, it consumes, for example, okay, in the smaller terms, I can say that to run engine at 20 km. So if the energy requirement is 1 liter, in that the 60 to 70, 75% of energy is supplied by the fossil fuel, and remaining energy is supplied by the hydrogen. Because what is the restriction? The restriction for the utilization of hydrogen in the inlet manifold is that we are injecting the hydrogen or induction of hydrogen that is happened in the inlet manifold. It replaces maximum amount of air because due to its density, the lower density. When we are going to inject hydrogen, it occupies more space and avoids the flow of the air into the combustion chamber. So that puts a restriction for the higher amount utilizations of the hydrogen in a SI engine. You can see this one. So how the fuel, how the air is, so how the hydrogen is injected into the inlet manifold along with the air. So it works like this. So what are the disadvantages? Lower efficiency. Yes, we can't able to put more hydrogen, or we can't able to supply more hydrogen into the combustion chamber due to its lower density. It requires, it occupies more amount of the space, and backfiring risk. Exactly about the backfiring, already told by Dr. Kumar sir. So this backfiring risk is also associated with the utilization of the hydrogen and limited power output, because we are supplying only a small amount of hydrogen, that is not more than 30 MB. So this second generation, second generation is a well-developed system. Already almost even Ashok Leyland in Indian sector. Tata is also with the fuel cell technology. Tata comes with the fuel cell technology. Ashok Leyland comes with the direct combustion technology. And apart from this one, Toyota. Have you seen any EV vehicles from Toyota? Have you seen any EV vehicles? Is there any EV vehicles from Toyota? Right? The Toyota is one of the largest manufacturer of the, the automotives. But still they don't have any EV vehicles, right? Even BMW have. Because their technology is different, they have a well-developed hydrogen technology.
They know what is the future. Instead of creating a new manufacturing lines for the EVs, simply they sell their whatever the cost is there. Yes, obviously their share of in this automotive sector they reduce. They combine with Maruti Suzuki. They sell Baleno as renamed it as a Toyota car, and they sell. Because of this, they are not concentrated on EV. Still, they are waiting for the production of hydrogen vehicles. And once the hydrogen vehicles, once the Indian government or maybe any government in the world gives a green signals, obviously, these Toyota will make a big impact on the production of hydrogen vehicles. So this is how this hydrogen vehicles works. Actually, whatever the fuel line supply. So we know that hydrogen is one of the lightest gas available, right, in the fuel sector. Even if they find a very small hole or a gap, it will escape. So the creating of fuel lines for the hydrogen supply, and especially, and also the injection system is designed by the Bosch. So this is a gas injector, hydrogen injector that is produced from the Bosch. It has a capacity of 17 gram of H2 per second. It can be able to deliver around 17 gram of H2 per second, right? And design is robust, that is purely for the heavy vehicle, that is transportation, that is for goods carrying vehicles. And also it's can able to deliver the hydrogen at a 15 bar. Also, that is port fuel injection system. If you are going to inject hydrogen into this port, if you want, else you can for the direct injection, it can able to inject at a 40 bar. So that pressure is enough. We can store and inject hydrogen at a 150 bar also, but we are using an low pressure injector. We are going to step down the storage injector to the supply. The storage pressure to the supply pressure. So this is what is happened from 2017 to 2030. So what is the future? Also, the future is predicted. What is going to get happen? So these are the vehicles developed by the various manufacturers. You can see. So again, I will show this Toyota in 2022 and Ashok Leyland in India. So they released in 2022-23 exclusively. And you can see in 2017 to 20, the Toyota Endurance is there that uses H2 IC engine. It is not a fuel cell. So these vehicles are not a fuel cell vehicles. Fuel cell technology is completely different. It is these engines are completely run by the direct combustions of the hydrogen. So it is one of the important technology because it won't emit any harmful emissions. So this is we can tell. So this is Ashok Leyland that is in Bangalore. Recently, in 2023, in the Bangalore Automobile Expo, they launched these hydrogen vehicles, and they are going to set up and in Lucknow. They are going to set up their hydrogen production center. That is hydrogen vehicle production center in Lucknow. Yes. So yes, this is about how the production, utilization, and some challenges limited. So that is I discussed. Then what is the policy that is made by the government, and why this AICTE gave an importance to the conduct this FD? That is due to National Hydrogen Mission. So what is this National Hydrogen Mission? Actually, we discussed in 2017 when we meet V.K. Saraswat. This is one of the NITI Aayog member, and also is from the ex-defense ministry. So we meet in 2017 when we conducted one conference along with in the species of combustion coal. So it's the end of the Indian section. When we meet, me and Kumar sir, when we meet and we proposed. So why we can't? So many people are telling that yes, it is the end of the era of the IC engines. There is no use of the IC engine. If you ask anybody, yes, IC engine era is over, but still they are using the IC engine. That is the tragedy. They are going to tell there is no use of the IC engine emitting that thing, this thing. Yes, I agree. This IC engine polluting the atmosphere, but why you guys are using for everything? You need a luxury cars, you need a two-wheeler, everything you need. So, but still they are blaming the IC engine. We should not suppose to blame any IC engine. We have to always, when it comes to the technology, there are always pros and cons are there. So we have to accept that one, and we have to improve those cons from the negative sides of the technology. So then hydrogen is coming to the picture. The Indian government and given national hydrogen mission. So along with they know that, so I wrote the hydrogen importance, and along with the alignment with the Paris Agreement, they want a sustainable greener energy. So that's why the Indian government gave a push to the development of the hydrogen R&Ds in India. And for the development of hydrogen R&D in India, the Indian government gives a lot of funding to research institutes under the ANRF, now the DST fund. So under the ANRF also it gives a lot of fund, and also VGST. So VGST also give a lot of fund for the academic institute in the research of hydrogen and all those things, especially the greener side of it. So in the not only and the DST or something like that, almost all the companies like Indian Oils or maybe HPCL have their special green R&D in Bengaluru. They are continuously working. They have the huge facilities of this engine testing facilities, and they have a separate department, chemical department, and they have a hydrogen production department. Yes, each and every automotive sector, the companies in automotive sectors or maybe the fuel suppliers are continuously working for the production of hydrogen, utilizations of hydrogen. So what are these vision and objectives? The key objectives includes the green hydrogen production capacity of 5 million tons per annum in 2030. So yes, we are producing the hydrogen, but there is a grey side of the hydrogen. But the intent is the intention is to production of hydrogen with the greener. Yes, reduction in cost. Obviously, in the current trends or current method have a including a higher cost, so that we have to reduce the cost of the production by increasing the research and development in the our sectors, and promotion of domestic manufacture of electrolysis. Yes, it is another taking into account. So we have to promote instead of instead of buying the electrolysis or of the electrodes that is from the different countries, we should develop our own technology. That is, electrodes should be developed locally, and we have to use for the electrolysis methods. And the development of hydrogen across industries, transport, and power applications. You can see this point: deployment of hydrogen in industry, transport, and power sectors. So now, almost all the sectors, when it comes to the energy sector, in the future days, hydrogen will take over, but only waiting for the storage. The storage is the biggest problem. So what happens when it comes to the storage? It will increase the weight of the vehicle when it comes to the transportation. Because a robust cylinder is needed, its weight is already higher. So when we use that one, obviously the weight of the vehicle is increases, that leads to the reduction of efficiency of the mechanical efficiency of the vehicle. So and also the risk with the explosion. If the hydrogen is stored at a 150-200 mark, if there is a small leakage or maybe explosion happen, so that leads to a big disaster. So the scientists are continuously working to reduce the risk associated with the hydrogen. And in 2000, maybe 18 or 19, you have observed when a hydrogen explosion has happened in IAC. That is with the use of this hydrogen in AICTE. So maybe one research fellow may be died due to this explosion. So policy and financial support. Yes, NITI Aayog. Again, the NITI Aayog coming to the picture. So the Ministry of New and the MNRE, the Ministry of New and Renewable Energy, and in coordination with NITI Aayog. So they invested a lot of money in the R&D sectors, right? So waiver of infrastructure transmission charges, open access to the renewable electricity, single window clearance for hydrogen production, so support for pilot projects and demonstration plants. So if you have any plans, regarding this hydrogen, the government is ready to support it fully, but we have to show our abilities. So research and development, funding for R&D in advanced electrolysis, catalyst, storage, material and fuel cells, development of code standards and safety regulations. Yes, we can work in that way also. And capacity building through the academic industry collaboration, that is one of the important things, right? And creation of skilled workforce in hydrogen technology. So these are some research and development skills that is undertaken by the Green Hydrogen Mission by the Indian government. And expected outcome, reductions in the CO2 emissions, fossil fuel imports, reductions in the fossil fuel imports, generation of new green jobs. Yes, that is one of the most important thing. When I spend something, so I need to get a job. So that is the main important thing. and strengthening the industry positions in the global hydrogen export markets, and acceleration of the transition towards net zero emission are taken up. So the final thing, I am going to end my session with the words, is independently I can't able to produce the energy, but I can save the energy. So each of you, if you save a small amount of energy per day, so that costs more to the national hydrogen machines, or maybe energy consumptions, or maybe CO2. How I can reduce the CO2 emission? Not only transporting in the public transport, not only by utilizing the public transport, even if I utilize light, fan, maybe ACs in a wise way, I can save a lot of CO2. So already we know that we are spending a lot of money and lot of like tools that we are using for the electricity productions. So any doubts, any questions? Any questions? It's okay.